Welcome to Simplilearn's AI full course. Artificial intelligence or AI allows machines to learn, think, and make decisions like humans. You've likely encountered it in virtual assistant, personalized Netflix recommendations, or even self-driving cars. In 2024, AI is in high demand, with industries like healthcare and technology leveraging it to boost efficiency and innovation, making AI professionals more sought after than ever. In this course, you will dive into the foundational topics like neural networks, deep learning, and recurrent neural networks, the core technologies powering AI. You'll also explore exciting career opportunities in AI and get practical guidance to prepare for job interviews, including mastering essential concepts and problem-solving skills. Let's embark on this AI journey together and unlock the potential of high-paying, future-ready career. Before we comment, if you want to enhance your career in AI, here's some quick info for you. Check out Simplilearn's postgraduate program in AI and Machine Learning in partnership with Purdue University and IBM. This course is perfect for aspiring AI enthusiasts and professionals looking to switch careers. Gain expertise in generative AI, prompt engineering, ChatgPT, explainable AI, machine learning algorithms, and many more. A year of experience is preferred. So hurry up and enroll now and find the course link mentioned in the description box and in the pinned comments. So let's get started.
Liam, a 19-year-old freshman, recently joined an Ivy League college to study history and political science. While reading about thinkers and scholars of the early 20th century, he stumbled upon a name, Alan Turing. Liam was fascinated by Alan and realized that the computer that he knows of today, Alan is considered to be the father of modern computer science that eventually led to the invention of his computer. But there was something that was even more fascinating about Alan. Although Alan Turing was famous for his work developing the first modern computers, decoding the encryption of German Enigma machines during the Second World War, he also built a detailed procedure known as the Turing test, forming the basis for artificial intelligence. Liam had his mind blown by this fact. He realized that AI is not a modern phenomenon, but rather more than a thought experiment existing since the early 90s. Liam used AI tools like ChatgPT, Perplexity, and Consensus on a daily basis for his research. He had a smartphone that he used for multiple tasks, like using Siri or Google Assistant to find local food places, using autocorrect on multiple apps like Instagram and WhatsApp, and even AI photo editing features. He realized that AI has seeped into almost every aspect of his life, from making trivial decisions like where to have his morning coffee, to complex AI tools like ChatgPT for his research, to even his father's self-driving Tesla that he used whenever he got a chance to. Artificial intelligence, or AI, in the 21st century has become a very subtle technology that exists in every human's life without them even realizing it. But what is this AI? Does this mean robots in a completely dystopian AI warlord future? Not really. Let us dive a little deeper into understanding everything about AI. Artificial intelligence, or AI, is like giving computers the ability to think and learn much like humans do. Imagine teaching a friend how to solve puzzles, and then that friend can solve different types of puzzles on their own. AI works similarly. It helps computers understand and carry out tasks that typically need human intelligence. These tasks include recognizing faces and photos, chatting with us through smart assistants like Siri or Google Assistant, and even driving cars. Think of AI as a smart helper that makes our daily lives easier. It can learn from data, make decisions, and improve itself over time. This means that AI isn't just about robots taking over the world, it's more about using smart technology to assist us in various ways, making complex tasks simpler and everyday routines smoother. AI has found its way into many areas of our lives, often making things easier without us even realizing it. In healthcare, for example, AI helps doctors by quickly analyzing medical images like X-rays to detect issues faster than the human eye might. In finance, AI works to keep our money safe by spotting unusual activities in our bank accounts that could indicate fraud. When you stream shows on Netflix, AI suggests movies and series based on what you've watched and liked before. In retail, AI manages stock and predicts what items will be popular, ensuring that store shelves are filled with what customers need. Even in our homes, AI is at work through smart devices like thermostats that learn your schedule and adjust the temperature automatically, or lights that turn on when you enter a room. AI touches so many parts of our daily lives, making things more convenient and efficient. One of the best AI applications today, which is very widely known and used, is ChatGPT, an advanced AI developed by OpenAI that can chat with you just like a human would. Imagine having a friend who knows almost everything and can help you with any question or topic. That's what ChatGPT does. But how does it work? ChatGPT is powered by something called a transformer model. This is a type of machine learning model that learns patterns in language by looking at a vast amount of text data from books, websites, and other sources. Think of it like reading millions of books and remembering important information from all of them. When you ask ChatGPT a question, it doesn't just pull out a random answer. Instead, it looks at the words you used, understands the context, and predicts what a good response would be based on what it has learned. For example, if you ask about the weather, it understands you are looking for current weather conditions and gives you relevant information. If you ask it to help with homework, it draws on its knowledge to explain concepts clearly. ChatGPT uses a process called deep learning, which is a bit like how our brains work. It breaks down sentences into smaller parts and looks at how these parts fit together. This helps it understand not just the meaning of individual words, but also how they combine to convey a complete idea. This is why ChatGPT can handle complex questions and give answers that make sense. To make sure it provides useful and accurate information, ChatGPT was trained on a diverse range of topics. This training helps it recognize and generate text on anything from science and history to entertainment and daily life. It's like having an encyclopedia and a friendly tutor rolled into one. Similar to ChatGPT, there are a plethora of other tools and applications being developed every day that are trained for various purposes using varied kind of data sets. For example, DALL-E, which has been trained on a diverse data set of text and images from the internet. Stable Diffusion, which has been trained on a variety of images and corresponding text descriptions. Tesla Autopilot, which has been trained on sensor data from Tesla vehicles and driving data, and so on and so forth. AI is a remarkable technology that holds great promise for the future, offering solutions to some of the world's most pressing challenges. Imagine a future where AI takes care of routine tasks, giving us more time to be creative and focus on what we love. AI can help in many ways, from improving medical treatments to making our daily lives more efficient. However, it's essential to use AI responsibly. This means creating guidelines and rules to ensure AI is developed and used in ways that benefit everyone. By embracing AI and understanding its potential, we can look forward to a future where technology and human creativity go hand in hand. AI is not just about smart gadgets. It's about opening new possibilities and making our world a better place. The future of AI is bright, filled with opportunities for innovation and progress, helping us achieve things we never thought possible.
AI will pretty much touch everything we do. It's more likely to be correct and grounded in reality. Talk to the AI about how to do better. It's a very deep philosophical conversation. It's a bit above my pay grade.
I'm going to say something, and it's going to sound completely opposite of what people feel. You probably recall over the course of the last 10 years, 15 years, Almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program. And that the programming language is human. Everybody in the world is now a programmer. This is the miracle.
Artificial intelligence or AI, from its humble beginnings in 1950s, AI has evolved from the simple problem solving and symbolic reasoning to the advanced machine learning and deep learning techniques that power some of the most innovative applications we see today. So AI is not just a buzzword. It is a revolutionary force reshaping industries, enhancing daily life, and creating unmatched opportunities across various sectors. AI is changing numerous fields. In healthcare, it aids in early disease diagnosis and personalized treatment plans. In finance, it transforms money management with the robo-advisors and fraud detection system. The automotive industry is seeing the rise of autonomous vehicles that navigate traffic and recognize obstacles, while retail and e-commerce benefit from personalized shopping experience and optimized supply chain management. So one of the most exciting developments in the AI is the rise of advanced AI tools like ChatGPT 4o, Google Gemini, and generative AI models. So these tools represent the pinnacle of conversational AI, capable of understanding and generating human-like text with remarkable accuracy. ChatGPT 4o can assist in writing, brainstorming ideas, and even tutoring, make it a valuable resource for students, professionals, and creatives. Similarly, Google Gemini take AI integration to the next level, enhancing search capabilities, providing insightful responses, and integrating seamlessly into our digital lives. Generative AI is a subset of AI, is also making views by creating new content from scratch. Tools like DALL-E, which generates images from textual description, and GPT-3, which can write coherent and creative text, are just the beginnings. So these technologies are changing fields like art, design, and content creation, enabling the generation of unique and personal outputs that were previously unimaginable. So beyond specific industries, AI applications extend to everyday's life. Voice-activated assistants like Siri and Alexa and smart home devices learn our preferences and adjust our environments accordingly. So AI is embedded in the technology we use daily, making our lives more convenient, connected, and efficient. So join us as we explore the future of AI, examining the breakthroughs, the challenges, and the endless possibilities that lies ahead. So whether you are a tech enthusiast, a professional in the field, or simply curious about what's next, so this video will provide you with a comprehensive look at how AI is shaping our world and what we can expect in the years to come. So before we move forward, as we know, ChatGPT, Gemini, generative AI tools is an AI based. And if you want to learn how these cool AI develop and want to create your own. So without any further ado, let's get started. So how AI will impact the future? The first is enhanced business automation. AI is transforming business automation with 55% of organizations adopting AI technology, chatbots, and digital assistant handle customer interaction and basic employee inquiries, speeding up decision making. The second thing is job disruption. Automation may displace job, with a one-third to takes potentially automated, while roles like securities are at risk. Demand for machine learning specialists is rising. AI is more likely to augment skilled and creative positions, emphasizing the need for upskilling. Data privacy issues. Training AI models requires large data set, raising privacy concern. The FTC is investigating OpenAI for potential violation, and the Biden-Harris administration introduced an AI bill of rights to promote data transparency. The fourth one is increased regulation. AI impact on intellectual property and ethical concern is leading to increased regulation. Lawsuits and government guidelines on responsible AI use could reshape the industry. Climate change concern. AI optimize supply chains and reduce emission, but the energy needed for the AI models may increase carbon emission, potentially negating environmental benefits. So understanding these impacts help us to prepare for AI's future challenges and opportunities. So now let's see what industries will AI impact the most. The first one is manufacturing. AI enhances manufacturing with robotic arm and predictive sensors, improving tasks like assembly and equipment and maintenance. The second is healthcare. AI changes healthcare by quickly identifying diseases, streamlining drug discovery, and monitoring patients through virtual nursing assistant. The third one, finance. AI helps bank and financial institutions detect fraud, conduct audits, and assess loan applications, while traders use AI for risk assessment and smart investment decisions. The fourth one, education. AI personalizes education by digitizing textbook, detecting plagiarism, and analyzing student emotions to tailor learning experience. The fifth one, customer service. AI-powered chatbots and virtual assistant provide data-driven insights, enhancing customer service interaction. So these industries are experiencing significant changes due to AI, driving innovation and efficiency across various sectors. So now let's move forward and see some risks and dangers of AI. So AI offers many benefits but also poses significant risks. The first one, job loss. From 2023 to 2028, 44% of worker skills will be disrupted. Without upskilling, AI could lead to higher unemployment and fewer opportunities for marginalized groups. The second one is human biases. AI often reflects the biases of its trainers, such as facial recognition favoring lighter skin tones. Unchecked biases can perpetuate social inequalities. The third one, deepfakes and misinformation. Deepfakes blur reality, spreading misinformation with dangerous consequences. They can be used for political propaganda, financial fraud, and compromising reputation. The fourth one, data privacy. AI training on public data risks breaches that expose a personal information. A 2024 Cisco survey found 48% of businesses use non-public information in AI tools, with 69% concerned about intellectual property and legal rights. Breaches could expose millions of consumers' data. The fifth one, automated weapons. AI in automated weapons fails to distinguish between soldier and civilian, posing severe threats. Misuse could lead endanger large population. Understanding these risks is crucial for responsible AI development and the use. So as we explore the future of AI, it's clear that impact will be profound and far-reaching. AI will change industries, enhance efficiency, and drive innovation. However, it also brings significant challenges, including job displacement, biases, privacy concern, misinformation, and the ethical implementation of automated weapons. So to harness AI potential responsibly, we must invest in upskilling our workforce, address biases in AI system, protect data, privacy, and develop regulations that ensure ethical AI use.
Today, we'll take you through the exciting roadmap of becoming an AI engineer. If our content piques your interest and helps fuel your curiosity, don't forget to subscribe to our channel. Hit that bell icon so you never miss an update. Now let's embark on this AI journey together. As artificial intelligence continues to revolutionize various industries, AI engineers stand at the forefront of this technological wave. These professionals are essential in crafting intelligent systems that address complex business challenges. AI projects often stumble due to poor planning, subpar architecture, or scalability issues. AI engineers play a crucial role in overcoming these hurdles by merging cutting-edge AI technologies with strategic business insights. So in this video, we'll guide you through the essentials of becoming an AI engineer. Let's start with the basics. What does an AI engineer do? An AI engineer builds AI models using machine learning algorithms and deep learning neural networks. These models are pivotal in generating business insights that influence organizational decision making. From developing applications that leverage sentiment analysis for contextual advertising to creating systems for visual recognition and language translation, the scope of an AI engineer's work is vast and impactful. So to succeed as an AI engineer, you need a blend of technical prowess and soft skills. So now let's break down this 8-month plan. Month 1, Computer Science Fundamentals and Beginner's Python. So before we delve into AI, it's crucial to establish a strong foundation in computer science. This month, you should focus on the following topics. Data representation. Understanding bits and bytes, how text and numbers are stored, and the binary number system is foundational for everything in computing. This knowledge helps in comprehending how computers interpret and process data. Now next comes computer networks. Learn the basics of computer networks, including IP addresses and internet routing protocols. It's essential to understand how data travels across networks using UDP, TCP and HTTP, which form the backbone of the internet and the World Wide Web. Next comes programming basics. Begin with the basics of programming like variables, strings, numbers, conditionals, loops, and algorithm basics. These fundamentals will allow you to write and understand simple programs. Simultaneously, you'll also start with Python, the preferred language for AI. So learn about variables, numbers, strings, lists, dictionaries, sets, tuples, and control structures like if conditionals and for loops. And then move on to functions and modules. Understand how to create functions, including Lambda functions, and work with modules by using pip install to add functionality to your projects. Next comes file handling and exceptions. You should also practice reading from and writing to files, as well as handling exceptions to make your programs more robust. Finally, grasp the basics of classes and objects, which are crucial for writing organized and efficient code. So this comprehensive overview sets the stage for more complex programming tasks that you'll encounter in the following months. Now in month 2, you'll move on to data structure algorithms and advanced Python. So building on the foundations from month 1, we'll now delve into data structure and algorithm. So familiarize yourself with the concept of big O notation to understand the efficiency of different algorithms and data structures. Learn about arrays, linked lists, hash tables, stacks, queues, trees, and graphs. Mastering these structures will allow you to store and manipulate data effectively. Now next comes algorithms. You should explore algorithms such as binary search, bubble sort, quick sort, merge sort, and recursion. These are essential for optimizing your code, and parallelly you'll advance your Python skills. So you can dive into inheritance, generators, iterations, list comprehensions, decorators, multi-threading, and multiprocessing. These topics will enable you to write more efficient and scalable code. So this month's learning prepares you to handle complex data operations and enhance your coding efficiency. Now in month 3, you'll move on to version control, SQL, and data manipulation. So in the third month, the focus shifts to collaboration and data management. Number 1, version control. So understand the importance of version control systems, especially Git and GitHub. So learn basic commands such as add, commit, and push. You should also learn how to handle branches, reword changes, and understand concepts like head, diff, and merge. So these skills are invaluable for tracking changes and collaborating with other developers. Next, pull requests. Master the art of creating and managing pull requests to contribute to collaborative projects. Next, we'll dive into SQL for managing databases. So first, we'll start with SQL basics. So learn about relational databases and how to perform basic queries. And then you'll move on to advanced queries. Understand complex query techniques such as CTEs, subqueries, and window functions. And then comes joins and database management. So study different types of joins like left, right, inner, and full join. You should also learn how to create databases, manage indexes, and write stored procedures. Additionally, you will use NumPy and Pandas for data manipulation and learn basic data visualization techniques. This comprehensive skill set will be crucial as you move into more advanced data science topics. So now in month 4, you'll deal with maths and statistics for AI. So mathematics and statistics are the backbone of AI, and this month is dedicated to these critical subjects. So first, learn about descriptive versus inferential statistics, continuous versus discrete data, nominal versus ordinal data, measures of central tendency like mean, median, mode, and measures of dispersion like variance and standard deviation. After that, understand the basis of probability and delve into normal distribution, correlation, and covariance. After which, you should move on to advanced concepts. So you can study the central limit theorem, hypothesis testing, p-values, confidence intervals, and so on. In parallel, you should also study linear algebra and calculus. So in linear algebra, learn about vectors, matrices, eigenvalues, and eigenvectors. And in calculus, cover the basics of integral and differential calculus. So this mathematical foundation is essential for developing and understanding AI models, setting you up for success as you transition into machine learning. Now in month 5 comes exploratory data analysis, which is EDA, and machine learning. So with a solid foundation in math and statistics, you are now ready to delve into machine learning. Number 1, pre-processing. Learn how to handle NA values, treat outliers, perform data normalization, and conduct feature engineering. You should also understand encoding techniques such as one-hot and label encoding. You'll also explore supervised and unsupervised learning with a focus on regression and classification, and learn about linear models like linear and logistical regression, and non-linear models like decision tree, random forest, etc. And then understand how to evaluate models using metrics such as mean square error, mean absolute error, mean for regression and accuracy, precision recall, etc.
Then comes hyperparameter tuning. Learn about techniques like grid search CV and random search CV for optimizing your models. After which you'll move on to unsupervised learning. Here you can study clustering techniques like K-means and hierarchical clustering and delve into dimensionality reduction with PCA. So this month's focus on EDA and model building will prepare you for more complex AI applications. Transitioning to the next phase, you will begin to work on deploying these models and real-world scenarios. So in month 6 comes ML Ops and machine learning projects. So this month we'll cover the operational aspects of machine learning and work on practical projects. So in ML Ops basics, learn about APIs, particularly using Fast API for Python and server development. Understand DevOps fundamentals including CI/CD pipelines and containerization with Docker and Kubernetes. You should also gain familiarity with at least one cloud platform like AWS or Azure. Now in month 7 comes deep learning. So in this month, we delve into the world of deep learning. So number 1 comes neural network. So learn about neural networks including forward and backward propagation and build multi-layer perceptrons. After which we'll move on to advanced architectures. So here explore convolutional neural networks which are CNNs for image data and sequence models like RNNs and LSTMs. So this deep learning knowledge will be crucial as we move into specialized areas of AI in the final month. Now in the final month, the 8th month comes NLP or computer vision. So the final month you have the option to specialize in either natural language processing, NLP or computer vision. So first we'll reveal NLP track. So here you should learn about regex, text representation methods like count vectorizer, TF-IDF, Bow, word-to-vec, embeddings and text classification with naive Bayes. And familiarize yourself with the fundamentals of libraries like Spacy and NLTK and work on end-to-end NLP project. And talking about computer vision track, focus on basic image processing techniques like filtering, edge detection, image scaling and rotation. Utilize libraries like OpenCV and build upon the CNN knowledge from the previous month. Practice data pre-processing and augmentation. So by the end of this month, you should have a solid foundation in your chosen specialization ready to embark on your AI engineering career. So in conclusion, adopting AI is more than just a trend. It's a strategic move that can transform your organization's approach to machine learning. So do check out our professional certificate course in AI and machine learning, which is designed to equip you with the skills needed to excel in this dynamic field. Through live classes led by industry experts, masterclasses from IIT Kanpur faculty, and hands-on projects, you'll gain a competitive edge in AI. To enroll in this program, candidates should have a bachelor's degree with a 50% or higher average, preferably 2 or more years of work experience and foundational knowledge in programming and mathematics. Check out the course link in the description box below. So that's all for today's video on becoming an AI engineer. We hope you found this guide valuable and informative.
Today we are talking about must-have Python AI projects and how to build them so that can really help you sharpen your skills and stand out in the growing field of artificial intelligence. So let's quickly see what is Python. Python is one of the most popular programming languages for AI because its simplicity and the powerful libraries it offers, like TensorFlow, Keras, and PyTorch. Building projects using Python is a great way to get started if you want to break into the AI industry. Whereas artificial intelligence is transforming industries like healthcare, finance, and even entertainment. Companies are now looking for experts who know how to apply AI to real-world problems. In this video, we will explore beginner level to advanced level projects. So these projects are designed to give you hands-on experience in building intelligent systems, analyzing data, and even automating tasks. So without any further ado, let's get started. So let's start with beginner level projects. So number 1, we have fake news detection using machine learning. So in today's world, fake news is a major concern, causing misinformation to spread rapidly across social media and news platforms. Detecting fake news is crucial to maintaining the integrity of the information we consume. So these projects aim to build a machine learning model that can identify fake news articles by analyzing their textual content, by learning from existing datasets of real and fake news. The model will be able to classify articles into these 2 categories, thus assisting media outlets and social media platforms in reducing the spread of misinformation. This project is perfect introduction to natural language processing, NLP, as it involves text data manipulation, feature extraction, and supervised learning. It can also be adapted for real-time use on website or social media platforms to flag suspicious articles and provide more reliable information to users. So now let's see how to build this. In this, first step is data collection. Use dataset like LIAR or fake news net that can contain label, real, and fake news articles. You can find dataset from the Kaggle. The second step is pre-processing. Clean the text by removing stop words, punctuation, and special characters. Tokenize and stem words using NLTK or Spacy. The third step is feature extraction. Use TF-IDF or bag of words to convert the text into numerical data for machine learning models. The fourth step is model training. Train a classifier like logistic regression, naive Bayes, or random forest on the dataset. The fifth step is evaluation. Evaluate the model using accuracy, precision, recall, and F1 score metrics to determine how well it classifies fake and real news. Tools you can use is NLTK, Scikit-learn, and Pandas. Skills you will gain from this are text preprocessing, NLP, classification models. And if you want to make us video on this project, please comment down below. In number 2, we have image recognition using CNN. Image recognition is one of the core applications of deep learning and computer vision, used in a variety of industries ranging from healthcare to autonomous vehicles. This project will guide you through building an image classifier using CNNs, a deep learning architecture designed specifically for image recognition tasks. The goal is to create a model that can accurately classify images, such as differentiating between cats and dogs. By working on this project, you will gain a solid understanding of the fundamental concepts of CNNs, such as convolutional layers, pooling, and activation functions. This project not only introduces you to the basics of CNNs, but also teaches essential skills like image preprocessing, dataset handling, and model evaluation, which can be applied to more advanced computer vision projects in the future. So now let's see how to build this project. In this project, first you have to import dataset. So use a dataset like CIFR10 or Kaggle cats versus dogs with labeled images. The second step is preprocessing. Resize, normalize, and augmented images using libraries like OpenCV or PIL to prepare the dataset. The third step is model architecture. Design a basic CNN model with convolutional, pooling, and fully connected layers using Keras or TensorFlow. The fourth step is training. Split the dataset into training and validation sets and train the CNN model to classify images. The fifth step is model evaluation. Use accuracy, precision, and confusion metrics to evaluate how well the model predicts the correct class label. Tools you will use in this project are Keras, TensorFlow, OpenCV, Pandas. Skills you will gain after doing these projects are image preprocessing, CNN architecture, model evaluation. And if you want to make us video on image recognition using CNN, please comment down below. Second, we have intermediate level projects. In this first, we have AI-based recipe recommendation system. Recommendation systems have become an integral part of modern digital platforms. From e-commerce website suggesting product to users to streamlined services recommending shows and movies. So in this project, you will build a recipe recommendation system that suggests dishes based on the ingredients a user has on hand. This project demonstrates how recommendation algorithms such as content-based filtering and collaborative filtering can be used to provide personalized suggestions. You will also learn how to pre-process data and clean textual data, such as ingredient lists, and implement a machine learning algorithm to match user inputs with recipe databases. This is an excellent project for understanding how recommendation systems work and how they can be applied in various industries, from food tech to personalized content recommendations. So now let's see how to build this. In this project, first step is data collection. Use web scraping tools like Beautiful Soup to scrape recipes from websites, or use datasets like Recipe1M. The second step is pre-processing. Normalize and clean ingredient data by standardizing ingredient names and handling missing values. The third step is recommendation algorithms. Implement content-based filtering and collaborative filtering to recommend recipes. Content-based filtering matches ingredient list, while collaborative filtering uses user preferences model. Fourth step is model training. Use cosine similarity to match user-provided ingredients with recipe ingredient in the dataset. And the next step is interface and tools. So create a simple web interface using Flask where users can input ingredients and receive recipe recommendation. Tools you will use: Beautiful Soup, Pandas, Scikit-learn, and Flask. So you will gain skills like web scraping, data cleaning, recommendation systems using this project, by doing this project. And if you want to make us video on this project, please comment down below. Number 4, we have chatbot with sentiment analysis. Chatbots have transformed how businesses and services interact with users, providing 24/7 support and personalized responses. In this project, you will build a conversational chatbot that can analyze the sentiment behind user inputs and respond accordingly. By incorporating sentiment analysis, the chatbot will not only understand the content of the user's messages, but also the emotional tone, such as whether the user is happy, frustrated, or neutral. This allows the chatbot to adjust its tone and responses to improve user satisfaction. For example, a chatbot could offer a more empathetic response if it detects a negative sentiment. This project will give you hands-on experience in building a conversational AI system while learning how to integrate machine learning techniques like sentiment analysis. The skills you develop in this project can be applied to customer service, healthcare, education, and more. So now let's see how to build this project. So before jumping to advanced level projects, here is a quick info for you. In this project, the first step is chatbot framework. Use tools like Dialogflow or Rasa to build a conversational chatbot capable of handling various user intents. The second step is sentiment analysis. Integrate a sentiment analysis model using pre-trained models like Veda or BERT. The third step is conversational flow. Adjust the chatbot's responses based on the sentiment, positive, negative, or neutral, detected in the user's input. The fourth step is integration and deployment. So build an interface, website, or messaging platform where users can interact with the chatbot in real time, and deploy the chatbot on a website or app, allowing user to engage with it and receive sentiment-aware responses. So you will use tools in this are Dialogflow, Rasa, Vader, Transformers, Flask, and you will gain skills like sentiment analysis, chatbot deployment, conversational AI. And if you want to make us video on this project, please comment down below. So now let's see some advanced level projects. In this we have AI powered image colorization. Image colorization is a fascinating application of deep learning that transforms black and white images into color by predicting and applying realistic colors to grayscale images. This project explores how CNN and GANs can be used to learn mapping between grayscale and colored images. You will gather dataset of colored images, convert them into grayscale, and train the model generate color versions. This project is especially useful in areas such as film restoration, photography, and artistic creation, where colorization can breathe new life into old black and white images. Moreover, it highlights the power of deep learning in understanding and generating complex visual data, giving you insight into how these models work for tasks like image generation, video prediction, and beyond. The skills you learn in this project will also be useful for other creative AI applications like style transfer and image synthesis. So now let's see how to build this project. So in this project, first step is data collection. Use dataset of colored image, convert them into grayscale, and use the grayscale images as inputs while training the model to output colorized version. The second step is pre-processing. Normalize images pixel values and resize them for training. The third step is model architecture. Implement a unit model or generative adversarial network (GANs) which are well suited for image generation tasks like colorization. Fourth step is training and evaluation. Train the model on grayscale images as input and colored images as output using mean squared error method for guidance. Evaluate with visual inspection and peak signal to noise ratio. The last step is deployment. So create a web interface where user can upload black and white images and get them colorized. So you will use tools like TensorFlow, Keras, OpenCV, and Flask. So we will gain skills like deep learning, CNNs, JNs, and image preprocessing. And if you want to make a video on AI-powered image colorization project, so please comment down below. And the last we have object detection using YOLO. You only look once. Object detection is one of the most popular computer vision applications, allowing machine to recognize and locate multiple objects within an image or video stream in real time. YOLO is a state-of-the-art object detection algorithm known for its speed and accuracy. This project involves building a real-time object detection system capable of identifying multiple objects in images or videos feeds by drawing bounding boxes around them. Object detection has widespread use in fields such as security surveillance, autonomous driving, and augmented reality, where systems need to understand and interact with their surroundings in real time. By working on this project, you will learn how to pre-process image data, format bounding box labels, and train a YOLO model using a dataset like Coco or Pascal. You will also gain a valuable experience in deploying object detection systems that process video streams, giving you the skills to build application in dynamic environment, from traffic monitoring to industrial robotics. So now let's see how to build this project. So in this project, we will first import dataset. So use a dataset like Coco or Pascal VOC, which contains label objects in images with bounding boxes. The second step is pre-processing. Resize image and normalize pixel values, ensuring bounding box labels are appropriately formatted. The third step is model architecture. Use the YOLO, you only look once architecture, which splits images into a grid and predicts bounding boxes and class probabilities for each object. The fourth step is training and evaluation. Train the YOLO model on labeled data using a framework like Darknet. Evaluate the model using metrics like intersection over union and mean average precision. The last step is deployment. Develop a system that can process video streams in real time, detecting objects and drawing bounding boxes around them. Tool you will use OpenCV, TensorFlow, and Darknet. You will gain skills like object detection, YOLO architecture, real-time video processing. And if you want to make videos on this project, please comment down below. So in conclusion, these Python AI projects not only help you build hands-on skills, but also provide a solid foundation for advancing your career in artificial intelligence. Whether you are working on fake news detection, image recognition, or developing advanced tools like chatbots and object detection systems, these projects offer real-world applications that companies are looking for. Start small, keep learning, and as you complete each project, you will get better prepared to take on the challenges in the growing AI field.
So let's talk about, is AI is a good career or not? You have probably heard a lot about artificial intelligence or AI. It's everywhere and it's shaking up industries all over the world. But here's the big question. Is AI a good career choice? Yes, absolutely, it is. Take Elon Musk for example. We all know him as the guy behind Tesla and SpaceX. But did you know he also co-founded OpenAI? Even Elon's diving into AI, and that just shows how massive this field is becoming. And guess what? AI isn't just for tech geniuses, there's room for everyone. Let's talk about numbers. AI jobs are growing like crazy, up to 32% in recent years. And the pay is pretty sweet, with roles offering over $100,000 a year. So whether you're into engineering, research, or even the ethical side of the things, AI has something for you. Plus, the skills you pick up in AI can be used in all sorts of industries, making it a super flexible career choice. Now, AI is a big field and there are tons of different jobs you can go for. Let's break down some of the key roles. First up, we have machine learning engineers. These folks are like the backbone of AI. They build models that can analyze huge amounts of data in real time. If you've got a background in data science or software engineering, this could be your thing. The average salary is around $131,000 in the US. Then there's data scientists, the detectives of the AI world. They dig into data to find patterns that help businesses make smart decisions. If you're good with programming and stats, this is a great option. And you can make about $105,000 a year. Next, we've got business intelligence developers. They are the ones to process and analyze data to spot trends that guide business strategies. If you enjoy working with data and have a background in computer science, this role might be for you. The average salary here is around $87,000 per year. Then we've got research scientists. These are the ones pushing AI to new heights by asking innovative questions and exploring new possibilities. It's a bit more academic, often needing advanced degrees, but it's super rewarding with salaries around $100,000. Next up, we have big data engineers and architects. These are the folks who make sure all the different parts of business's technology talk to each other smoothly. They work with tools like Hadoop and Spark, and they need strong programming and data visualization skills. And get this, the average salary is one of the highest in AI, around $151,000 a year. Then we have AI software engineer. These engineers build the software that powers AI application. They need to be really good at coding and have a solid understanding of both software engineering and AI. If you enjoy developing software and want to be a part of the AI revolution, this could be your role. The average salary is around $108,000. Now, if you're more into designing systems, you might want to look at becoming a software architect. These guys design and maintain entire AI system, making sure everything is scalable and efficient. With expertise in AI and cloud platforms, software architects can earn hefty salary about $150,000 a year. Let's not forget about the data analyst. They have been around for a while, but their role has evolved big time with AI. Now they prepare data for machine learning models and create super insightful reports. If you're skilled in SQL, Python, and data visualization tools like Tableau, this could be a great fit for you. The average salary is around $65,000, but it can go much higher in tech companies. Another exciting role is robotics engineer. These engineers design and maintain AI-powered robots, from factory robots to robots that help in healthcare. They usually need advanced degrees in engineering and strong skills in AI, machine learning, and IoT, Internet of Things. The average salary of a robotics engineer is around $87,000. With experience, it can go up to even more. Last but not the least, we have got NLP engineers. NLP stands for Natural Language Processing, and these engineers specialize in teaching machines to understand human language. Think voice assistants like Siri or Alexa to get into this role. You'll need a background in computational linguistics and programming skills. The average salary of an NLP engineer is around $78,000, and it can go even higher as you gain more experience. So you can see the world of AI is full of exciting opportunities. Whether you're into coding, designing systems, working with data, or even building robots, there's a role for you in this fastest growing field. So what skills do you actually need to learn to land an entry-level AI position? First off, you need to have a good understanding of AI and machine learning concepts. You will need programming skills like Python, Java, R, and knowing your way around tools like TensorFlow and PyTorch will help you give an edge too. And do not forget about SQL, Pandas, and big technologies like Hadoop and Spark, which are super valuable. Plus, experience with AWS and Google Cloud is often required. So, which industries are hiring AI professionals? AI professionals are in high demand across a wide range of industries. Here are some of the top sectors that hire AI talent. Technology. Companies like Microsoft, Apple, Google, and Facebook are leading the charge in AI innovation. Consulting. Firms like PwC, KPMG, and Accenture are looking for AI experts to help businesses transform. Then we have healthcare. Organizations are using AI to revolutionize patient with treatment. Then we have got retail. Giants like Walmart and Amazon leverage AI to improve customer experiences. Then we have got media. Companies like Warner and Bloomberg are using AI to analyze and predict trends in this media industry. AI is not just the future, it's the present. With right skills and determination, you can carve out a rewarding career in this exciting field. Whether you're drawn to technical challenges or strategic possibilities, there's a role in AI that's perfect for you. So start building your skills, stay curious, and get ready to be a part of the AI revolution.
The term generative AI has emerged seemingly out of nowhere in recent months, with a notable surge in interest according to Google Trends even within the past year. The spike in curiosity can be attributed to the introduction of generative models such as DALL-E 2, BARD, and ChatGPT. However, what does generative AI entail? As a part of our introductory series on generative AI, this video will provide a comprehensive overview of a subject starting from the basics. The explanation will cater to all levels of familiarity, ensuring that viewers gain a better understanding of how this technology operates and its growing integration to our daily lives. Generative AI is, after all, a tool that is based on artificial intelligence. A professional who seeks to switch careers with AI by learning from the experts. What is generative AI? Generative AI is a form of artificial intelligence possesses the capability of to generate a wide range of content including text, visual, audio, and synthetic data. The recent excitement surrounding generative AI stems from the user-friendly interfaces that allow users to effortlessly create high-quality text, graphics, and video within a seconds. Now moving forward, let's see how does generative AI works. Generative AI begin a prompt which can take form of text, image, video, design, audio, musical notes, or any input that AI system can process. Various AI algorithms that generate new content in response to the given prompt. This content can range from essay and problem solution to realistic created using images or audio of a person. In the early stages of generative AI, utilizing the technology involved submitting data through an API or a complex process. Developers need to acquaint themselves with a specialized tool and writing application using programming language like Python. Some of the recent and fully operational generative AIs are Google Bard, DALL-E, OpenAI ChatGPT, Microsoft Bing, and many more. So now let's discuss ChatGPT, DALL-E, and Bard, which are the most popular generative AI interfaces. So first is DALL-E 2, which was developed using OpenAI GPT implementation in 2021. Exemplify a multimodal AI application. It has been trained on a vast dataset of images and their corresponding textual description. DALL-E is capable of establishing connection between various media forms such as vision, text, audio. It specifically links the meaning of words to visual elements. OpenAI introduced an enhanced version called DALL-E 2 in 2022, which empowers users to generate imagery in multiple styles based on their prompts. And the next one is ChatGPT. In November 2022, ChatGPT, an AI-powered chatbot built on OpenAI GPT 3.5 implementation, gained immense popularity worldwide. OpenAI enabled users to interact with and fine-tune the chatbot's text response through a chat interface with interactive feedback. Unlike earlier version of GPT that was solely accessible via an API, ChatGPT brought a more interactive experience. On March 14, 2023, OpenAI released GPT-4. ChatGPT integrates the conversational history with a user, making a genuine dialogue. Microsoft, impressed by the success of new ChatGPT interface, announced a substantial investment in OpenAI and integrated a version of GPT into its Bing search engine. And the next one is Bard, Google Bard. Google was also an earlier forerunner in advancing transformer AI techniques for language processing, protein analysis, and other content types. It made some of these models open source for researchers but were not made available through a public interface. In response to Microsoft's integration of GPT into Bing, Google hurriedly launched a public-facing chatbot named Google Bard. Bard's debut was met by an error when the language model incorrectly claimed that the Webb telescope was the first to discover a planet in a foreign solar system. As a consequence, Google's stock price suffered a significant decline. Meanwhile, Microsoft's implementation of ChatGPT and GPT-powered system also faced criticism for producing inaccurate results and displaying erratic behavior in their early iteration. So, moving forward, let's see what are the use cases of generative AI. Generative AI has broad applicability and can be employed across a wide range of use cases to generate diverse forms of content. Recent advancements like GPT have made this technology more accessible and customizable for various applications. Some notable use cases for generative AI are as follows. Chatbot implementation. Generative AI can be utilized to develop chatbots for customer service and technical support, enhancing interaction with users and providing efficient assistance. The second one is language dubbing enhancement. In the realm of movies and educational content, generative AI can contribute to improving dubbing in different languages, ensuring accurate and high quality translation. And the third one is content writing. Generative AI can assist in writing email responses, dating profiles, resumes, and term papers, offering valuable support and generating customized content tailored to specific requirements. And the fourth one is art generation. Leveraging generative AI, artists can create photorealistic artwork in various styles, enabling the exploration of new artistic expression and enhancing creativity. The fifth one is product demonstration videos. Generative AI can enhance product demonstration video, making them more engaging, visually appealing, and effective in showcasing product features and benefits. So generative AI versatility allows it to employed in many other applications, making it a valuable tool for content creation and enhancing user experience across diverse domains. So after seeing use cases of generative AI, let's see what are the benefits of generative AI. So generative AI offers extensive application across various business domains, simplifying the interpretation and comprehension of existing content while also enabling the automated creation of a new content. Developers are actively exploring ways to leverage generative AI in order to enhance the optimize existing workflows and even to reshape workflows entirely to harness the potential of technology fully. Implementing generative AI can bring numerous benefits, including automated content creation. Generative AI can automate the manual process of writing content, saving time and effort by generating text or other form of content. The next one is efficient email response. Responding to emails can be made more efficient with generative AI, reducing the effort required and improving response time. And the third one is enhanced technical support. Generative AI can improve responses to specific technical queries, providing accurate and helpful information to users or customers. And the fourth one is realistic person generation. By leveraging generative AI, it becomes possible to create realistic representation of people, enabling applications like virtual characters or avatars. And the fifth one is coherent information summarization. Generative AI can summarize complex information into a coherent narrative, distilling key points and making it easier to understand and communicate complex concepts. The implementation of generative AI offers a range of potential benefits, streamlining process and enhancing content creation in various areas of business operation. So after seeing advantages of generative AI, let's move forward and see what are the limitations of generative AI. Early implementation of generative AI serve as vivid examples highlighting the numerous limitations associated with this technology. Several challenges arise from the specific approaches employed to implement various use cases. For instance, while a summary of a complex topic may be more reader-friendly than an explanation incorporating multiple supporting sources, the ease of readability comes at the expense of transparent identifying the information sources. So the first one is, when implementing or utilizing a generative AI application, it is important to consider the following limitation. I repeat, the first one is lack of source identification. Generative AI does not always provide clear identification of content source, making it difficult to trace and verify origin of the information. The second one is assessment of bias. Assessing the bias of original sources used generative AI can be challenging, as it may be difficult to determine the underlying perspective or agenda of the data utilized in the training process. The third one is difficulty in identifying inaccurate information. Generative AI can generate realistic content, making identifying inaccuracy or falsehoods within the generated output harder. And the fourth one is adaptability to a new circumstances. Understanding how to fine-tune generative AI for a new circumstances or specific context can be complex, requiring careful consideration and expertise to achieve desired result. And the fifth one is glossing over bias, prejudice, and hatred. Generative AI results may amplify or perpetuate biases, prejudices, or hateful content present in the training data, requiring vigilant scrutiny to prevent such issues. So, awareness of these limitations is crucial when the implementing of utilizing generative AI, as it helps users and developers critically evaluate and mitigate potential risks and challenges associated with the technology. So, future of generative AI. Furthermore, advances in AI development platforms will contribute to the accelerated progress of research and development in the realm of generative AI. The development will encompass various domains such as text, images, videos, 3D content, drugs, supply chains, logistics, and business processes. While the current standalone tools are impressive, the true transformative impact generative AI will realize while these capabilities are seemingly integrated into the existing tools with regular use.
Hello everyone, I am Mayank and welcome to this video on Gen AI projects. Generative AI is an exciting part of artificial intelligence that creates new things like text, images, music, and more by learning patterns from large datasets. It uses advanced tools like GANs, generative adversarial networks, and VAs, variational autoencoders, to produce content that feels human-made. This technology is transforming industries worldwide. In healthcare, it's helping doctors with medical imaging and drug discovery. In retail, it's personalizing shopping experiences with AI-generated recommendations. Education is seeing smarter tools like AI tutors and content creators. Even in finance, generative AI is improving fraud detection and automating reports. Its ability to create innovative solutions is truly changing the way businesses operate. Generative AI projects are a great way to stand out for your career. Companies always seek candidates who can solve real-world problems with hands-on experience. Building these projects shows your creativity and ability to apply AI in impactful ways, making you shine in job interviews. This video will explore exciting project ideas to help you learn, grow, and get noticed. Whether you are a beginner or already have some experience, these ideas will inspire you to dive into the world of generative AI and its endless possibilities.
So the first project is build a data science portfolio website with ChatGPT. So this project involves creating a professional portfolio website to display your data science projects, skills, and expertise. The highlight of this project is integrating ChatGPT to make the website interactive, allowing visitors to ask questions like what techniques did you use in your last project, or explain your expertise in machine learning. So key components are, for front-end development, you can use HTML, CSS, and JavaScript for designing the website. Use OpenAI API to enable chatbot functionality. For deployment, you can use platforms like Netlify or GitHub Pages for hosting. So this is perfect for data scientists who want to showcase their work in interviews or networking. It also demonstrates technical skills in AI integration and web development. And if you want us to make video on this project, please comment down below. Second, we have personalized voice assistant with ChatGPT and Whisper. So you can build a conversational AI voice assistant that understands user queries using GPT and responds in a human-like voice with Whisper's text-to-speech capabilities. Features can include setting reminders, answering questions, or even casual conversation. Key components are natural language understanding, GPT for processing user inputs and generating meaningful responses. For text to speech, use Whisper for realistic expressive voice output. For integration, you can use Python for seamless functionality. So this project highlights skills in conversational AI and can be applied to smart assistant, customer service bots, or personal productivity tools. And if you want us to make video on this project, please comment down below. And the third, we have AI powered translator. So you can develop an application capable of translating text between languages, potentially extending to real-time translation. The system can also provide context-sensitive translation, ensuring accuracy and fluency. Key components are Spacey or Hugging Face Transformer for processing language. You can use language translation API like Google Translate. For UI development, use Python framework like Flask for a user interface. So this project is ideal for application in global communication, education, or travel. It demonstrates proficiency in NLP and multilingual processing. If you want us to make video on this project, please comment down below. Number 4, we have research paper summarizer. So you can create a tool that summarizes lengthy research paper or articles into concise key point summarizes. This can save time for students, researchers, and professionals. Some key components are use tools like NLTK or Hugging Face for summarization algorithm. Implement extractive or abstractive summarization. Use Streamlit to build a web-based user interface. So, a practical application for academia and research showcasing skills in NLP and application development. And if you want us to make video on this project, please comment down below. Number 5, we have automated code documentation generator. So you can build a tool that scans code bases and automatically generates structured documentation by extracting comment and function description. Some key components are for parsing, use regular expression or abstract syntax trees AST to extract code annotation. Document framework, use tools like Sphinx to format and publish the documentation. Focus on Python but extendable to other languages. Streamline software's development workflows and is a valuable skill for developers working on large projects. Number 6, we have automate PowerPoint presentation. You can develop a tool that creates PowerPoint presentation dynamically by generating slides based on data, visual or input content. Some key components are use Python PPTX library for creating and modifying slides. Incorporate graphs and charts using Matplotlib or Plotly. Allow content to be updated based on external data sources like Excel or APIs. So this project is useful for business professionals and students, demonstrating expertise in automation and visualization. And if you want us to make video on this project, please comment down below. Number 7, we have AI generated music composition. You can create a system that composes original music based on user inputs like mood, style, or instrument. The AI can generate MIDI files that can be played or edited. Key components are use OpenAI MuseNet or other models for music generation. Generate MIDI files for compatibility with music software. Allow user to input desired music style or moods. So application in creative fields like entertainment, gaming or music production showcasing skills in deep learning and creative AI. And if you want us to make video on this project, please comment down below. Number 8, we have interactive story generator with reinforcement learning. So you can build an interactive storytelling tool where user can influence the plot and the AI dynamically adjusts the story using reinforcement learning. So you can train model to adapt narrative based on user choices. Use GPT or other NLP tools to generate dialogues and story elements. Build a text-based or graphical UI for user to interact with the story. So this is great for gaming and content creation, highlighting skills in reinforcement learning and NLP. And if you want us to make video on this project, please comment down below. Number 9, we have AI-based recipe generator and cooking assistant. So you can create an AI assistant that suggests recipes based on available ingredients and user preferences, providing step-by-step cooking guidance. Use algorithm to suggest recipes and incorporate datasets like recipe 1M for diverse recipe options and provide instruction interactively via chatbot or voice. So this project is practical for food tech, showcasing skill in recommendation systems and interactive AI. If you want us to make video on this project, please comment down below. At the last, we have AI-driven personal fashion stylist. You can develop a virtual fashion stylist that recommend outfit combination based on user preference, trend, and wardrobe items. Integrate augmented reality to allow user to try on outfit virtually. Key components are analyze upload images of clothing items using TensorFlow or OpenCV. Suggest outfits based on user preference, occasion, and current trends. Use tools like AR Core or 3D modeling libraries for virtual try-ons. So these projects cover a wide range of applications and technologies, making them excellent for building technical skills and showcasing them in interviews or portfolio. If you want us to make any video on this project, please comment down below.
So now let's see steps to get an AI engineer job. So to thrive in this field, developing a comprehensive skill set is crucial, while encompasses many specialized areas. So here are some certain core skills that are essential across most roles. So here is you can build these skills. First one is technical skills. So AI roles heavily rely on technical expertise, particularly in programming, data handling, or working with AI specific tools, or you can say the cloud specific tools. So here are some key areas to focus on. The first one is the programming languages. So proficiency in general purpose programming language like Python and R is the fundamental. Python in particular is widely used in AI for simplicity and robust libraries such as TensorFlow and PyTorch, which are crucial for machine learning and deep learning tasks. The second one is database management. So understanding how to manage and manipulate large datasets is essential in AI. Familiarity with database management systems like Apache Cassandra, Couchbase, and DynamoDB will allow you to store, retrieve, and process data efficiently. The third one, data analysis and statistics. Strong skills in data analysis are must. Tools like MATLAB, Excel, and Pandas are invaluable for statistical analysis, data manipulation, and visualization of trends in data, which are critical for developing AI models. The fourth one, cloud AI platform. Knowing of cloud-based AI platforms such as Microsoft Azure AI, Google Cloud AI, and IBM Watson is increasingly important. So these platforms provide pre-built models, tools, and infrastructure that can accelerate AI development and deployment. The second one is industry knowledge. While technical skills form the backbone of your AI expertise, understanding the industry context is equally important. For example, knowing how AI integrates with digital marketing goals and strategies can be a significant advantage if you are working in or targeting industries like e-commerce or advertising. So industry-specific knowledge allows you to apply AI solutions more effectively and communicate their value to stakeholders. The third one, workplace or soft skills. In addition to technical, industry-specific skills, developing workplace skills, or you can say soft skills, is essential for success in AI roles or any roles. So these soft skills often honed through experience include, the first one is communication. Clearly articulating complex AI concept to non-technical stakeholders is crucial. Whether you are explaining how machine learning model works or presenting data-driven insight, effective communication ensure that your work is understood and valued. Second one is collaboration. AI projects often require teamwork across diverse fields, including data science, software development, and other things. The third one is analytical thinking. AI is fundamentally about problem solving. You will need strong analytical thinking skills to approach challenges logically, break them down into manageable parts, and develop innovative solutions. The fourth one, problem solving. AI projects frequently involve unexpected challenges, whether it's a technical bug or an unforeseen data issue. Strong problem solving will help you navigate these hurdles and keep projects on track. So building these skills can be achieved through various methods, including self-study, online courses, boot camps, or formal education. Additionally, working on real projects, contributing to open source AI initiatives, and seeking mentorship can provide practical experience and further enhance your expertise. So next thing is learn advanced topics. So as you advance in your machine learning journey, it is important to delve into more advanced topics. These areas will deepen your understanding and help you tackle complex problems. So some key topics to focus are, the first one is deep learning and neural network. The second thing is ensemble learning techniques. The third thing is generative models and adversarial learning. The fourth one is recommendation system and collaborative filtering. The fifth one is time series analysis and forecasting. So now let's move forward and see some machine learning projects. So working on real world projects to apply your knowledge, focus on data collection and preparation, capstone project in image recognition and NLP, predictive modeling, and anomaly detection. Practical experience key to solidifying your skills. So now let's move forward and see what is the next skill. That is earn a certification. So if you are already hold an undergraduate degree in a field of related to AI, enrolling in a specialized course to enhance your technical skills can be highly beneficial. Even if you don't have a degree, earning certification can show potential employers that you are committed to your career goals and actively investing in your professional development. So you can unleash your career potential with our artificial intelligence and machine learning courses, tailored for diverse industries and roles at top global firms. Our program features key tools, enhance your AI knowledge and business acumen, join the job market, and become a sought-after professional. The next thing is continuous learning and exploration. So stay updated with the latest development by following industry leaders, engaging in online communities, and working on personal projects. Pursue advanced learning through courses and certification to keep your skills sharp. So now let's move forward and see some AI career opportunities with salary. So the job market for machine learning professionals is booming. The average annual salary for AI engineers can be vary based on location, experience, and company. So here are some roles like machine learning engineer, data scientist, NLP engineer, computer vision, and AI ML researcher. So now let's see how much they earn. So the first one is ML engineer. So machine learning engineers earn $153,000 in US and 11 lakh in India per annum. The second one is data scientist. The data scientists earn $150,000 in US and 12 lakh per annum in India. The third one is NLP engineer. They earn $107,000 in US and 7 lakh in India per annum. Fourth one is computer vision engineer, CV engineer. They earn around $126,000 in US and 6,50,000 in India. The last one is AI ML researcher. They earn $130,000 in US and in India they earn around 9 lakh per annum. So note that these figures can vary on website to website and changes frequently. So now last step is start applying for entry-level jobs. When you feel confident in your training, begin researching and applying for jobs. Many entry-level AI positions like software engineer or developer roles are often labeled as entry-level or junior in the job description. Jobs that require less than 3 years of experience are usually suitable for those just starting out. If you need additional support in your job research, consider applying for internship, taking on freelance projects, or participating in hackathons to further hone your skills. So these opportunities not only provide valuable feedback on your work, but also help you build connections that could benefit your career in the future.
We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. This is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under our quiz time. And we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee, and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings. But certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. HR hiring set up there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares. And we label them. We have what's a circle, what's a triangle, what's a square. And we have our model training, and it trains it so we know the answer. Very important. When you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning, and if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is, and what a triangle is, and what a square is, it goes in there, looks at them, and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide, because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future. It's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge, because now it's starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge, because this is going to come up in any project you're working on. We have, in supervised learning, we have labeled data. We have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predicted outcome. So you have a nice prediction. This new set of data is coming in, and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth, and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance in our head. We can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two, but let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time, and we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time, 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with the mean value of y of I equals 2.8, where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in, and we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of, designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind, this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, I, j, q, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you could imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning, and not a good day in the afternoon, or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. Two important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of and N, where P is the probability that you're going to play a game of golf, and N is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of P over P plus N minus N over P plus N times the log squared of N of P plus N. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the data set is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, you can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so when we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other three attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node, and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy. If it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the two groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the 2 points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is male. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a 3-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just two features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically, the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. They usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, you have different ways of referencing it, easily viewing it, and there's additional features you can run on a data frame. And Pandas kind of sits on numpy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn, we're going to use the sklearn model, import SVM, support vector machine. And then as a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human. But if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use 2 packages. We're going to import matplotlibary.pyplot as PLT. Again, very common. And we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on numpy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your percentage sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and use the pip or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, .read CSV. Remember, it was a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program, is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data. And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the 2 different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn in doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into 2 parts. We need a type label. And remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake. It knows 0 and 1. So what we're going to do is we're going to create a type label. And from this, we'll create a numpy array np where And this is where we can do some logic. We take our recipes from our Panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list. And this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features. Make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do. But for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them, but we're going to do just flour and sugar, and we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients, and you can see what that looks like. And so we have just the amount of flour and sugar, just the 2 sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything. We just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that and you'll see it's just the 2 columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. In this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value or whatever you're trying to work on. And SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar. And the type label, is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, where you split it into training data and test data, and they even do something where they split it into thirds, where a third is used for where you switch between which one's training and test. There's all kinds of things that go into that, and it gets very complicated when you get to the higher end. Not overly complicated, just an extra step which we're not going to do today because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear. And there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say, we're going to use a W for our variable on here. We're going to do model.coefficient_0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent two different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in two-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's two different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about numpy. So when I do a times xx, which is a whole numpy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup. And YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you want to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so it's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborn plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborn sits on top of pie plot, we can do the pie plot for the line going through. And that is simply plt.plot. And that's our XX and YY, our two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the pie plot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data. And you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through. And we'll create a function with def. And let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0. So we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in, and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if you're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. Oops, there we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below, where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do PLT plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come out. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin, which wraps up our cupcake versus muffin.
So what is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So this is made possible through neural networks, particularly deep neural networks, which consist of multiple layers of interconnected nodes. So these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantages of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs, inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces a network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn features from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So applications include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance costs, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training, whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large labeled datasets, often require extensive labeled dataset for training, which can be costly and time-consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learn relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex dataset and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP.
Hey everyone, welcome to Simplilearn. Today's video will compare and contrast artificial intelligence, deep learning, machine learning, and data science. But before we get started, consider subscribing to Simplilearn's YouTube channel and hit the bell icon. That way, you'll be the first to get notified when we post similar content. Before moving on, let me ask you two interesting queries. Which among the following is not a branch of artificial intelligence? Data analysis, machine learning, deep learning, neural networks. And the second query is, what is the main difference between machine learning and deep learning? Please leave your answer in the comments section below, and stay tuned to get the answer. First, we will unwrap deep learning. Deep learning was first introduced in the 1940s. Deep learning did not develop suddenly, it developed slowly and steadily over 7 decades. Many theses and discoveries were made on deep learning from the 1940s to 2000. Thanks to companies like Facebook and Google, the term deep learning has gained popularity and may give the perception that it is a relatively new concept. Deep learning can be considered as a type of machine learning and artificial intelligence, or AI, that imitates how humans gain certain types of knowledge. Deep learning includes statistics and predictive modeling. Deep learning makes processes quicker and simpler, which is advantageous to data scientists to gather, analyze, and interpret massive amounts of data. Having the fundamentals discussed, let's move into the different types of deep learning. Neural networks are the main component of deep learning, but neural networks comprise 3 main types, which contain artificial neural networks, or ANN, convolution neural networks, or CNN, and recurrent neural networks, or RNN. Artificial neural networks are inspired biologically by the animal brain. Convolutional neural networks surpass other neural networks when given inputs such as images, voice, or audio. It analyzes images by processing data. Recurrent neural networks uses sequential data or series of data. Convolutional neural networks and recurrent neural networks are used in natural language processes, speech recognition, image recognition, and many more. Machine learning. The evolution of ML started with the mathematical modeling of neural networks that served as the basis for the invention of machine learning. In 1943, neuroscientist Warren McCulloch and logician Walter Pitts attempted to quantitatively map out how humans make decisions and carry out thinking processes. Therefore, the term machine learning is not new. Machine learning is a branch of artificial intelligence and computer science that uses data and algorithms to imitate how humans learn, gradually increasing the system's accuracy. There are three types of machine learning, which include supervised learning. Well, what is supervised learning? Well, here, machines are trained using labeled data. Machines predict output based on this data. Now, coming to unsupervised learning, models are not supervised using a training data set. It is comparable to the learning process that occurs in the human brain while learning something new. And the third type of machine learning is reinforcement learning. Here, the agent learns from feedback. It learns to behave in a given environment based on actions and the result of the action. And this feature can be observed in robotics. Now, coming to the evolution of AI. The potential of artificial intelligence wasn't explored until the 1950s, although the idea has been known for centuries. The term artificial intelligence has been around for a decade. Still, it wasn't until British polymath Alan Turing posed the question of why machines couldn't use knowledge like humans do to solve problems and make decisions. We can define artificial intelligence as a technique of turning a computer-based robot to work and act like humans. Now let's have a glance at the types of artificial intelligence. Weak AI performs only specific tasks, like Apple's Siri, Google Assistant, and Amazon's Alexa. You might have used all of these technologies, but the types I am mentioning after this are under experiment. General AI can also be addressed as artificial general intelligence. It is equivalent to human intelligence, hence an AGI system is capable of carrying out any task that a human can. Strong AI aspires to build machines that are indistinguishable from the human mind. Both general and strong AI are hypothetical right now. Rigorous research is going on this matter. There are many branches of artificial intelligence, which include machine learning, deep learning, natural language processing, robotics, expert systems, fuzzy logic. Therefore, the correct answer for which is not a branch of artificial intelligence is option A, data analysis. Now that we have covered deep learning, machine learning, and artificial intelligence, the final topic is data science. Concepts like deep learning, machine learning, and artificial intelligence can be considered a subset of data science. Let us cover the evolution of data science. The phrase data science was coined in the early 1960s to characterize a new profession that would enable the comprehension and analysis of the massive volumes of data being gathered at the time. Since its beginnings, data science has expanded to incorporate ideas and methods from other fields, including artificial intelligence, machine learning, deep learning, and so forth. Data science can be defined as the domain of study that handles vast volumes of data using modern tools and techniques to find unseen patterns, derive meaningful information, and make business decisions. Therefore, data science comprises machine learning, artificial intelligence, and deep learning.
So guys, let's start first with a beginner level project. And the first project that we are going to encounter, that is home value prediction. So guys, this project aims to develop a predictive model to estimate the value of residential properties. The model will analyze various features such as location, square, footage, number of bedrooms and bathrooms, age of the property, and other relevant factors. By leveraging historical property data, the model will be able to provide accurate home value predictions, which can be useful for real estate agents, buyers, and sellers. So guys, the programming language that we are going to use all over here will be Python, and machine learning libraries that we will be using will be scikit-learn, TensorFlow, Keras, and for data handling libraries we have Pandas, NumPy, and for visualization we have to use Matplotlib and Seaborn. Now what will be the approach for this one, guys? So guys, the first one that we have a data collection. So here, what is going to happen, guys? So first you have to collect the historical property data from the sources like Zillow, retailer.com. You can also get database from the public real estate databases like Kaggle datasets, where you have Zillow home value prediction. Ensure that the dataset include features like location, where you have latitude, longitude, square footage, number of rooms, year built, property type, and previous sales. The next step that comes is data cleaning. You have to handle the missing values by using imputation techniques or removing incomplete records, removing outliers that may skew the model's prediction, normalize or standardize the data to ensure consistency. The third one that we have is feature engineering. You have to create new features such as proximity to schools, crime rates, and access to the public transportation. Encode categorical variables, example property type, location, using techniques like one-hot encoding. Generate interaction features that capture relationship between existing features. The fourth one that we have is model selection. Use regression models like linear regression, random forest, gradient boosting, neural networks. Experiment with different models to identify the best performing one. Now, in the next phase, all you have to do, guys, is model training and evaluation. Split the data set into training and test sets. Train the model on the training set and evaluate their performance on the testing set using metrics like RSME, which means root mean squared error. You can use cross-validation to ensure the model's robustness and avoid overfitting. The sixth one that we have all over here is hyperparameter tuning. You can optimize the model's hyperparameter using techniques such as grid search or random search to improve accuracy. And if you're looking forward to deploy your model, then you can develop a web interface using Flask or Django to allow users to input property features and get predictions. You can deploy the model on the cloud platform like AWS for scalability. Now, if we talk about the complexity level of this, we all know that it is a beginner level project. Now let us move on to the one more set, that is music genre classification and generation. So guys, this is also one of the most beginner level project. This project aims to develop a system that can classify music tracks into different genres and generate new music composition within specified genre. The goal is to build a model that analyzes audio features to categorize music and uses deep learning techniques to create new music. This project introduces advanced concept of audio processing, deep learning, and generative models. So guys, what will be used in this? So we'll have programming language that will be Python. For audio processing, we'll be using Librosa. For machine learning libraries, we'll be using TensorFlow, Keras, PyTorch. For data handling libraries, we'll be using Pandas, NumPy. For visualization, we'll be using Matplotlib, Seaborn. For the dataset, guys, you can use GTZan music genre dataset, or you can get it from Free Music Archive. So guys, in the first phase, we are going to have data collection. You can obtain datasets containing music tracks and their corresponding genre from the sources, from GTZan music genre dataset and the Free Music Archive. Ensure that a dataset includes diverse genre and substantial number of tracks per genre. Next, we'll go for data preprocessing. Use library Librosa to load and preprocess audio files, including feature extractions such as mil frequency, cepstral coefficients, chroma features, and spectral contrast. You can normalize the extracted features to ensure consistent input for the given models. Now, if we talk about feature engineering, guys, you can extract additional features from the audio files such as tempo, beat, zero crossing rate, etc. Create a feature matrix that represents the extracted audio features. Then go for the model selection. Use convolutional neural network or recurrent neural networks for the music genre classification. Split the dataset into training and testing dataset. Now, if we talk about model training and evaluation, guys, then you can train the selected classification model on the training set. Evaluate the model's performance on the testing set using metrics like accuracy, precision, recall, and F1 score. Use confusion matrices to understand the classification performance across different genres. Now, if we talk about model selection and training for the music generation, what you will do, guys, you can use the generative adversarial networks or recurrent neural networks such as LSTM, long short-term memory for music generation. Train the generative model on the dataset to create new music sequences. Next, we have model training and evaluation. You can train the generative model on sequences of audio features. You can evaluate the generated music by listening tests and by objective metrics like inception score or Friese audio distance. If I talk about hyperparameter tuning, guys, you can optimize the model. You can use the hyperparameters using techniques like grid search or random search to improve performance. If I talk about deployment, guys, you can deploy these models on cloud platforms like AWS. Now, let us move on to our next project. So guys, the complexity of this project is at the beginner level. Now, let us move to the intermediate level projects. Next project that we have all over here is sentiment analysis of Twitter data. This project aims to develop a sentiment analysis model that can classify tweets as positive, negative, or neutral. The goal is to analyze public sentiment on various topics or events using natural language techniques. So guys, what will be used all over here? So in this, we will have programming language like Python, okay, NLP libraries, NLTK Spacey. For machine learning libraries, you can use Scikit-learn, TensorFlow, Keras. For data handling libraries, we have Pandas, NumPy. For visualization, we have Matplotlib, Seaborn, and we can use the API Twitter for data collection. Now, how you're going to work on it, guys? So guys, if I talk about the data collection, use a Twitter API to collect tweets based on specific hashtags like keywords or topics. Extract relevant fields like tweet text, user information, timestamp, etc. Then if I talk about data pre-processing, guys, clean the tweet text by removing special characters, links, mentions, hashtags, and stop words. Tokenize the text and perform lemmaization or stemming to reduce the words to their base form. Next, if we talk about feature engineering, guys, you convert the clean text data into numerical representation using TF-IDF, bag of words, or word embedding. Now, if I talk about model selection, guys, you can choose the classification algorithms such as logistic regression, Naive Bayes, or LSTM. Split the dataset into training and testing dataset. Now, if I talk about model training and evaluation, then you can train the selected model on the training set. Evaluate the model's performance on the testing set using metrics like accuracy, precision, recall, and FN score. Use cross-validation to ensure the model's robustness. If I talk about hyperparameter tuning, guys, you can optimize the model's hyperparameters using grid search or random search to improve the performance. For deployment, which can be optional, you can deploy your model on AWS for real-time sentiment analysis. So if I talk about the complexity level, guys, its complexity is intermediate. So guys, our next project is customer segmentation using K-means clustering. This project aims to segment customers into distinct groups based on their purchasing behavior and demographic information. The objective is to understand customer segments and tailor marketing strategies accordingly. So guys, what programming languages we'll be using? So basically, we'll be using Python. For machine learning libraries, we'll have scikit-learn. For data handling libraries, we'll have pandas, numpy. For visualization libraries, we'll have matplotlib, seaborn. And the dataset source will be e-commerce transaction data. How we are going to work on this one? For data collection, we can obtain a dataset of e-commerce transactions that include customer demographics, purchase history, and product information. Next, we'll have data pre-processing. For data pre-processing, we are going to do the cleaning of the data by handling the missing values and outliers. Then, for feature engineering, we are going to create features like total purchase amount, purchase frequency, and recency of the purchases. Then we are going to proceed for the model selection. You can use K-means clustering to segment the customers into distinct groups. You can determine the optimal number of clusters using methods like elbow methods or Silhouette score. Now, if I talk about model training and evaluation, you can train the K-means model on the processed dataset. You can evaluate the quality of clusters by analyzing intra-cluster and inter-cluster distances. Next, we have the evaluation. You can visualize the clusters using techniques like PCA, principal component analysis, TSNE, etc. Next, we have the hyperparameter tuning. Now you can tune this model and interpret the characteristic of each segment. You can develop a target marketing strategies for each segment based on unique behavior and preferences. Now, deployment is optional. You can develop a dashboard using Flask or Django to visualize customer segments and track marketing campaigns. So guys, if I talk about the complexity of this project, so this is an intermediate level project. So guys, for dataset, you can use the Kaggle's customer segmentation dataset, which is available at the Kaggle's platform. Now, the third intermediate level project that we have all over here is building a chatbot with RASA. This project aims to build an intelligent chatbot using RASA framework. The chatbot will be capable of understanding user queries and providing appropriate responses, making it useful for customer support, personal assistance, or information retrieval. What languages we are going to use? So it will be Python based. We'll have the NLP libraries like RASA, NLTK, Spacy. For machine learning libraries, we are going to have scikit-learn, TensorFlow, Keras, etc. For data handling libraries, we are going to use pandas, numpy. So guys, this was what we are going to do it. And how you can work on this one? By collecting the data, collect the conversation data and FAQs from the target domain. Annotate the data to create training examples for the chatbot. Next comes is data pre-processing. Clean the text data by removing special characters and normalizing the text. You can tokenize and limitize the text to prepare for a training. The third one, we have the models training. You can use RASA's NLU's component to train a model for intent recognition and entity extraction. You can define the dialogue management policies to handle different conversation flows. Next guys, you can perform the feature engineering and integration. You can integrate the RASA's NLU and core components to build complete chatbot. You can connect the chatbot to messaging platform like Facebook, Messenger, etc. For model selection and testing, what you can do guys, you can test this chatbot with various inputs to ensure that it handles the scenarios appropriately. And you can also select the right model using this. Now, If I talk about model training, guys, what do you have to do? You have to collect the user feedback and conversational logs to continuously work on training the model. Next, similarly, you have to retrain the model periodically with the new data to see how it is working. So that will be your evaluation. Now, for the hyperparameter tuning, what are you going to do, guys? You have to check in those scenarios where it is able to tune up with those scenarios where it can handle the input appropriately. And next is deployment. So guys, for deploying it, you can use AWS. So guys, for a data set, you can use RASA's open source. So that's a very good data set for you to proceed. So guys, if we talk about difficulty of this project, this is an intermediate level project. Now let us move on to the advanced level projects. For advanced level projects, the first one that comes up to my mind is movie similarity from plot summaries. Now, this project aims to develop a system that can find out recommended movies similar to a given movie based on their plot summaries. By analyzing the textual content of the movie, plot summaries, the model will identify similarities and suggest movies with similar themes, storylines, or genres. This project introduces beginners to natural language processing, text similarly measures, and recommendation systems. What languages we are going to use, guys? We'll be using Python, NLP libraries like NLTK, Spacey, machine learning libraries like scikit-learn, data handling libraries like pandas, numpy, visualization, we can use numpy, and dataset source will be IMDb or Kaggle. So guys, this process is also involving the data collection, then you have to go for data cleaning, then feature engineering, next model selection. So similar process as I have discussed in other projects, so you have to also go through the same one. Next, what do you have to do, guys? Similarly, what do you have to do? You have to train the model, then evaluate the model, then hypertune it, and finally proceed for the deployment. So this is overall process of this project. Try to research on the website a lot, like how you can extract it. So guys, you can use Kaggle or Towards Data Science to research more about this project. Now guys, if I talk about the difficulty of this project, and this is an advanced level project. Now, let us move on to the next one that we have all over here. That is image segmentation project for brain tumor prognosis. This is a very amazing project and definitely you can put up on your portfolio. Basically guys, this project aims to develop an image segmentation model to identify and delineate brain tumors from MRI scans. The goal is to accurately segment the tumor regions which can aid in prognosis, treatment planning, surgical interventions. This project introduces intermediate level concepts of computer vision, deep learning, and medical image analysis. So guys, what we'll be using all over here? For programming languages, we can use Python. For deep learning libraries, we can use TensorFlow, Keras, PyTorch. For image processing libraries, we can use OpenCV, scikit-image. For data handling libraries, we can use Pandas, NumPy. For visualization, we can use Matplotlib, Seaborn. Now, if I talk about what is the process of developing this project, the first step will be the same, data collection. So next step, you have to go for data pre-processing. Third step, you have to do the model selection where you can use CNN models for image segmentation task. Then you go for model selection. Moving ahead, you're going to have the model training and evaluation. You have to split the data set into training and validation and testing data sets. Next, proceed for the evaluation phase. Okay, evaluate the model with certain metrics. So here I can give you certain idea, like you can use dice coefficient, intersection over union, or accuracy. Then go for hyperparameter tuning, where you have to optimize the model's hyperparameters. You can use grid search or random search as we have discussed. And finally, you can deploy this model on AWS. Now guys, we have come to the final project. This is also a very amazing project, guys. So guys, the complexity level of this project is advanced level. Now, let us move on to our final project, that is the impact of climate change on birds. This is a very amazing project and definitely you can add it on your resume. This project aims to analyze the impact of climate change on the bird population and migration patterns. By examining various climatic factors and their correlation with bird species data, the project seeks to predict how climate change might affect bird behavior and distribution. This project will introduce you some advanced level concepts like time series analysis, environmental data modeling, etc. So guys, what programming languages we'll be using? For data analysis, you can see we'll have Pandas, NumPy. For machine learning libraries, we are going to have scikit-learn, TensorFlow. For visualization, we are going to have Matplotlib, Plotly. For geospatial, we are going to have GeoPandas, Folium. For data source, we're going to have public data sets on bird observation and climate data sources from eBird. Now, what will the process flow for this one, guys? First, you have to proceed for data collection. Gather bird observation from the data like eBird, which provides extensive record of bird sightings. Okay. And for climate data, you can collect it from NOAA, including temperature, precipitation, and other relevant climatic factors over the time. Then similar next process will be the data pre-processing. Then you have to proceed for feature engineering. Then you have to go for model selection. Okay. Moving ahead, you have to go for model training, then evaluation, then hyperparameter tuning, and finally, you have to deploy the model. So research about this project, see what models you are going to use. Suppose I can give you a hint about this. You can use time series analysis models like ARIMA, or ML models. You can also use random forest or gradient boosting for predicting impact on the bird population. So guys, use Google exhaustively to research about this project. This is also a very amazing project and it's going to give you a lot of idea. Now, if I talk about the complexity level of this, it is an advanced level project.
Hello everyone, I am Mayank and welcome back to Simplilearn's YouTube channel. These days we usually ask Siri, "Hey Siri, how far is the nearest fuel station?" Whenever we ask Siri something, the powerful speech recognition system gets to work and converts the audio into its actual form. This is then sent to the Apple server for further processing. And then machine learning algorithms are run to understand the user's intent. And then finally Siri tells you the answer. Well, this is happening because of these machine learning algorithms. Think about it, not too long ago, most tasks were done by people. Whether it was building things, performing surgeries, or even playing games like chess. Humans were in control. But now things are changing fast. Almost all manual tasks are becoming automated, meaning machines and computers are taking over those jobs. This shift is redefining what we consider manual work. Machine learning, a type of artificial intelligence, is at the heart of this transformation. There are so many different machine learning algorithms out there, each designed to help computers learn and get better at tasks. From playing chess like Grandmaster to performing delicate surgeries with amazing precision. These algorithms are making technology smarter and more personal every day. So now that we have covered a brief about ML, I want you guys to quickly check out the quiz attached below in the description section. Take a moment to answer and let me know your thoughts in the comment section as well. In today's video, we are going to cover the top 10 machine learning algorithms that every aspiring machine learning engineer should know. Whether you are building models to predict the future, analyzing data, or creating smart apps. Mastering these algorithms will help you make the most of machine learning. So now let's get started with what is algorithm. What is an algorithm? In computer programming, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a bunch of information sources and delivers the ideal result. Most of us must be using Snapchat to apply filter on our faces while making videos or capturing photographs. But do you know how does Snapchat recognize your face while capturing videos or photographs and put filters on it? Even if there are multiple faces, it applies filter on every face accurately. This became possible with the help of the face recognition technique, which uses machine learning algorithms to detect faces and apply required filters on them. So this is the basic idea of how an algorithms work. So let's move ahead in this video and we'll see now how algorithm works in machine learning. So how do algorithm works? Everyone knows the algorithm is a step-by-step process to approach a particular problem. So there are numerous examples of algorithms, from figuring out sets of numbers to finding routes through maps to showing data on the screen. Let's understand this by using example. Every algorithm is built on inputs and the outputs. Google search algorithm is no different. The input is the search field and the output is the page of result that appears when you enter a particular phrase or keyword, also known as SERP or search engine result page. Google has algorithms so it can sort its result from various websites and provide the user with the best result. When you start, you will see the search box will attempt to guess what you are looking for. In order to better understand what the user is looking for, the algorithm is trying to gather as many suggestions from them as possible. The result from the search field that best matches the query will then be ranked. They choose which website will rank and in what position, using more than 200 ranking variables. Now that we have covered a brief about how algorithms work, I want you guys to quickly check out the quiz attached below in the description section. Take a moment to answer and let me know your thoughts in the comment section as well. Moving forward,
let's see types of machine learning. So machine learning is classified into supervised learning, unsupervised learning, and reinforcement learning. There are two sort of problems in supervised learning: classification and regression. Certain types of machine learning algorithms fall under the classification are decision tree algorithms, KNN algorithm, logistic algorithm, naive-bayes algorithm, support vector machine algorithm, SVM. However, in regression, types of machine learning algorithms are linear regression, regression trees, non-linear regression, Bayesian linear regression. Now talking about unsupervised learning, there are two sort of problem in unsupervised learning, which are clustering and association. Algorithms that fall under the clustering problems include k-means clustering algorithms, principal component analysis. However, algorithms that fall under association problem are a priori algorithm and FP growth. In reinforcement learning, there are two types: positive reinforcement and negative reinforcement. Reinforcement learning algorithms are mainly used in AI application and gaming application. The main used algorithms are Q-learning, state action reward state action, SAR, SA, and deep Q neural network DQN and Markov decision process. After discussing what algorithms is and its types, so now let's see some popular machine learning algorithms. The first one is linear regression, and the second one is logistic regression. Third one is decision trees, and the fourth one is SVM, support vector machine, and the fifth one is PCA, principal component analysis, and the sixth is k-means clustering, and seventh is random forest, and eighth is autoencoders, and ninth is DBSCAN. It's known as density based spatial clustering of application with noise. And the last one we have is hierarchical clustering. So now let's see these algorithms one by one. So first one we have linear regression, a statistical method used to model the relationship between a dependent variable, which is known as the target variable, and one or more independent variables, which are the predictors. It assumes a linear relationship between the inputs and the output. Real life example is house price prediction. Predicting house prices based on features like size, location, and number of rooms. So for example, on average, large houses cost more is the linear trend identified by this algorithm. Some applications are real estate price prediction, sales forecasting, and stock price prediction. And the second one is logistic regression, a classification algorithm used to predict binary outcomes, that is yes or no or true or false. It uses a logistic function to model the probability of a particular classes. Real life example is email spam filter, identifying spam emails based on certain features, keywords, sender, number of links. For instance, an email with claim your free gift now is classified as spam. Applications are email spam filtering, medical diagnosis, and customer churn prediction, and many more. The third one we have decision trees, a flowchart-like tree structure used to make decision. Each node in the tree represents a decision based on a feature, and each branch represents a possible outcome. Real life example is loan approval process. A bank using decision trees might ask, is the applicant credit score above 700, and proceed with further question to approve or deny the loan. Applications are loan approval, medical diagnosis, and marketing campaign analysis. The fourth one we have random forest, an ensemble method that combines multiple decision trees to improve accuracy. Each tree gives a vote on the outcome, and the majority vote determines the final decision. Real life example is medical diagnosis. Diagnosing diseases based on a patient data like age, cholesterol level, and blood pressure. Each decision tree in the forest makes a prediction, and majority vote decides the diagnosis. Applications are healthcare, disease prediction, fraud detection, and customer segmentation. Number fifth, we have support vector machine SVM, a classification algorithm that finds the optimal boundary to separate data into different classes, often used for binary classification. Real life example is image recognition, basically face detection. SVM can be used to detect faces in an image by classifying regions of the image as either face or non-face based on pixel value. Applications are facial recognition, speech recognition, and handwritten digit recognition. So now let's move forward and see some unsupervised learning algorithm. The number one is k-means clustering, a clustering algorithm that groups data into specified number k of a cluster based on similarity. The goal is to minimize the distance between data points in each cluster. Real life example is customer segmentation in marketing. Grouping customers into segments like high spenders, frequent shoppers, based on their purchasing behavior to personalize marketing efforts. Applications are customer segmentation, market basket analysis, and social media grouping. In number 7, we have hierarchical clustering, a clustering algorithm that creates a tree-like structure, which is also known as dendrogram, by grouping similar data points, which can be either agglomerative, which is bottom-up, or divisive, which is top-down. Real-life example is gene clustering in healthcare, clustering genes with similar expression patterns to study cancer cells. The dendrograms help researchers identify genes that behave similarly in response to treatment. Applications are gene expressive analysis, customer behavior analysis, and document clustering. In number 8, we have DBSCAN. The full form is Density-Based Spatial Clustering of Application with Noise. A density-based clustering algorithm that identify cluster based on the density of data point. It can also handle noise, which is outliers, by labeling them as noise point. Real life example is identifying crime hotspot, detecting areas with frequent criminal activity by clustering location based on crime density with outliers being excluded. Applications are crime hotspot detection, anomaly detection, and geospatial analysis. Number 9, we have principal component analysis, PCA, a dimension reduction that transforms data into smaller set of uncorrelated variables, which are principal components, to capture the most variance in the data. Real life example is image compression, compressing image by reducing the number of variables, retaining key features that preserve most of the image's information, thus reducing storage space. Applications are data compression, dimension reduction, and data visualization. The last one, we have autoencoders, a type of neural network used to learn efficient representation of data, typically for dimension reduction or anomaly detection. It encodes input data into a compressed representation and then reconstruct it back. Real life example is fraud detection in financial transaction, detecting unusual transaction by training an encoders or normal transaction data. When an outlier transaction occurs, it is flagged as potentially fraudulent. Applications are fraud detection, image denoising, and recommendation system. So these algorithms are the part of many real systems that we interact with daily, from predicting what product you might want to buy online to detecting frauds in your bank account. They are used in various industries such as healthcare, finance, retail, and security. Artificial intelligence, or AI, is transforming our world, making things faster and more efficient. But what happens when AI makes mistakes? When AI is biased, it can have serious consequences for companies and people's lives. Imagine missing out on a job, being wrongly identified in a photo, or being unfairly treated, all because a computer program made a bad decision. These mistakes don't just harm individuals, they can affect entire communities without realizing it. So AI bias is also called algorithmic bias. Happens when AI systems unintentionally favor one group over another. Take healthcare. For example, if the data used to train an AI system doesn't include enough women or people from minority groups, the system might not work as well for them. This can lead to incorrect medical prediction, like giving black patients less accurate results than white patients. In job hiring, AI can unintentionally promote certain stereotypes, like when job ads use terms like ninja, which may attract more men than women, even though the term isn't a requirement for the job. Even in creative areas like image generation, AI can reinforce biases. When asked to create picture of CEOs, AI systems often show mostly white men, leaving out women and people of color. In law enforcement, AI tools sometimes rely on biased data, which can unfairly target minority communities. So in this video, we will explore some well-known examples of AI bias and how these mistakes are impacting people and society, from healthcare to hiring and even criminal justice. AI bias is something we need to understand and fix. So let's dive in and learn how these biases happen and what can be done to stop them. So without any further ado, let's get started. So what is AI bias? AI bias, also called machine learning bias, happens when human biases affect the data used to train AI system, causing unfair or inaccurate results. When AI bias isn't fixed, it can hurt a business success and prevent some people from fully participating in the economy or society. Biases makes AI less accurate, which reduces its effectiveness. Businesses may struggle to benefit from systems that give unfair results,
and scandals from AI bias can lead to loss of trust, especially among groups like people of color, women, people with disabilities, and the LGBTQ community. AI models often learn from the data that reflects society biases. This can lead to unfair treatment of marginalized groups in the areas like hiring, policing, and credit scoring. As the Wall Street Journal notes, businesses still find it challenging to address these widespread biases as the AI use grows. So moving forward, let's see some sources of AI bias. Distorted outcomes can negatively affect both organization and society as a whole. So here are some common forms of AI bias. The first one is algorithm bias. If the problem or question is not well defined or the feedback provided to the machine learning algorithm is inadequate, the result may be inaccurate or misleading. The second one is cognitive bias. Since AI systems rely on a human input, they can be affected by unconscious human biases, which may influence either the dataset or the model's behavior. The third one, confirmation bias. This occurs when the AI overly depends on existing beliefs or trends in the data, reinforcing prior biases and failing to detect new patterns or trends. The fourth one, execution bias. When important data is omitted from the dataset, often due to the developer overlooking new or crucial factors, this type of bias arises. The fifth one, measurement biases. So this bias stems from incomplete data, such as when a dataset fails to represent the entire population. For instance, if a college analyzes only graduates to determine success factors, it would overlook reasons why others drop out. So moving forward, let's see how to avoid bias. So here are checklists of 6 process steps that can keep AI programs free of bias. The first one is choose the right model. Ensure diverse stakeholders select training data in supervised model and integrate bias detection tools in unsupervised models. The second one, use accurate data. Train AI with complete balanced data that reflects the true demographics. The third one, build a diverse team. A varied team helps spot bias, including innovators, creators, implementers, and end users. The next one, watch data processing. Bias can appear during any phase of processing, so stay vigilant throughout. The fifth one, monitor regularly. So continuously test models and have independent assessment to detect and fix biases. And the last one, check infrastructure. Ensure technological tools and sensors are functioning properly to avoid hidden biases. So conclusion is AI biases poses serious challenges by amplifying existing societal biases, affecting individuals and businesses. From healthcare to hiring, AI system can unintentionally reinforce stereotypes and inequalities. Imagine this, you are using a calculator app on your phone and it gives you an answer to be a complex math problem faster than you can blink. Pretty standard, right? But what if instead of just crunching numbers, that app could actually think through the problem, breaking it down like a human would, considering the best approach, and even explaining why it made certain decisions? Sound futuristic, doesn't it? Well, we are not too far from that reality. Today, we are diving into OpenAI's latest project, codenamed Strawberry, a new AI model that pushing the boundaries of reasoning and problem solving. So in this video, we will break down what makes Strawberry special, how it works, and why it could change the game for AI systems moving forward. So first off, what exactly is Strawberry? According to recent report, OpenAI is preparing to release this new AI model in the next 2 weeks or in the couple of weeks. And it's set to improve on things like reasoning and problem solving. Previously known as Q or Q star, this model is designed to be much better at thinking through problems compared to what we have seen from previous versions. What makes Strawberry different from what we have used before? So now let's take a look. One of the coolest things about Strawberry is that it uses something called system 2 thinking. This idea came from the famous psychologist Daniel Kahneman, and it refers to a more careful and slow way of thinking. Like when you really focus on solving a tricky problem, instead of answering question instantly, Strawberry takes about 10 to 20 seconds to process its thought. This extra time helps it to avoid mistakes and gives more accurate answers. But the model doesn't just think slowly. It's got some really cool abilities that makes it stand out. Let's talk about those. Strawberry is built to handle advanced reasoning and solve mathematical problems. These are areas where AI systems struggle. But Strawberry is designed to be a lot better at breaking down complex problems step by step. And here is something interesting. It might even be added to future versions of ChatGPT, possibly as a model name called Orion or GPT-5. If that happens, it could mean ChatGPT will become more smarter and more reliable in solving tough problems. Now, here is where it gets really fascinating. There is some research that might help us understand how Strawberry improves its thinking. Let's check it out. You might have heard about something called STAR, which stands for Self-Taught Reasoner. This is a method where an AI can actually teach itself to think better. Here is how it works. STAR starts with a few examples where the AI is shown how to solve problems step by step. Then the AI tries solving their problem on its own, getting better as it goes. It keeps improving by looking at its mistakes and learning from them. This could be what's happening with Strawberry. It's using similar method to teach itself how to reason better and solve complex problems. But the AI doesn't just think better. It's also learning how to break down the problems in a very human-like way. So now let's explore that next. Strawberry uses something called chain of thought reasoning. Basically, when faced with a complex problem, it breaks it down into smaller, manageable steps. Kind of like how we do when we are solving a puzzle. Instead of just jumping on to an answer, it takes its time to go through each step, making the solution more understandable and accurate. So this is especially useful in math, where Strawberry is expected to be really strong. With all its potential, what does the future hold for AI models like Strawberry? So now let's wrap this thing with a look at what's next. So now what's next for OpenAI? Well, Strawberry is just the beginning. There is talk about a future model called Orion, which could be the next big version after GPT-4 or GPT-4o. It may even use that Strawberry learners to get better at solving problems. But here is the thing. Training these advanced models is expensive. Training GPT-4, for example, cost over 100 million, even though OpenAI CEO Sam Altman said the era of just making bigger models is coming to an end. It's clear that the models like Strawberry are focused on becoming smarter and more efficient. So what does all of this mean for the future of AI and how we use it? Strawberry could represent a huge leap in AI's ability to reason and solve complex problems. So with its focus on slower, more deliberate thinking and its potential connection to the STAR method, it's paving the way for smarter, more reliable AI system. And this is just the start. As we move forward, models like Orion, the possibilities are endless. And that's a wrap on OpenAI exciting new model Strawberry. It's clear that this AI could bring major advancement in reasoning and problem solving. And we can't to see how it all unfolds. What are thoughts on your Strawberry? Do let us know in the comment section below. LLMs. If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that power search engines, LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By the end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So without any further ado, let's get started. So what are the large language models? Large language models like ChatGPT-4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze the relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant applications, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what are large language models used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how are large language models trained. Large language models typically undergo pre-training on a board, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. So there are some training processes of LLM which involve several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the text. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a sentence. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique. This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iterations or epochs until the model's output achieves a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of applications across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news websites or streaming services. So these applications highlight the potential impact of large language models in various domains for improving language understanding automation.
It was November 30, 2022. Sam Altman, Greg Brockman, and Ilya Sutskever would never have thought that with the push of a button, they would completely alter the lives of all human beings living on the earth and of future generations to come. On November 30, the OpenAI team launched ChatGPT. ChatGPT was born that day. Albeit a very small event in the history of internet evolution, but one that can no less be marked as one of the most significant events of modern IT industry. ChatGPT, a text-based chatbot that gives replies to questions asked to it, is built on GPT large language model. But what was so different? I mean, the Google search engine, YouTube, Firefox browser, they all have been doing the same for decades. So how is ChatGPT any different and why is it such a big deal? Well, for starters, ChatGPT was not returning indexed websites that have been SEO tuned and optimized to rank at the top. ChatGPT was able to comprehend the nature, tone, and the intent of the query asked and generated text-based responses based on the questions asked. It was like talking to a chatbot on the internet, minus the out-of-context responses with the knowledge of 1.7 trillion parameters. It was no shock that a computing system as efficient and prompt as ChatGPT would have its own setbacks. So did ChatGPT. It was bound by the parameters of the language model it was trained on, and it was limited to giving outdated results since the last training data was from September. Still, ChatGPT made waves in the tech community and continues to do so. Just have a look at the Google Trends search on ChatGPT. Every day, new content is being published on ChatGPT and hundreds of AI tools. The sheer interest that individuals and enterprises across the globe has shown in ChatGPT and AI tools is immense.
AI, generative AI, AI.
Now here comes the fun part. ChatGPT, or for that matter any large language model, runs on neural networks trained on multi-million, billion and even trillions of data parameters. These chatbots generate responses to user queries based on the input given to it. While it may generate similar responses for identical or similar queries, it can also produce different responses based on the specific context, phrasing, and the quality of input provided by each user. Additionally, ChatGPT is designed to adapt its language and tone to match the style and preferences of each user. So its responses may vary in wording and tone depending on the individual user's communication style and preferences. Every user has their own unique style of writing and communication, and ChatGPT's response can vary based on the input given to it. So this is where prompt engineers come into play. Prompt engineers are expert at prompt engineering. Sounds like a cyclic definition, right? Well, let's break it down. First, let's understand what prompts are. So prompts are any text-based input given to the model as a query. This includes statements like questions asked, the tone mentioned in the query, the context given for the query, and the format of output expected. So here is a quick example for your understanding. Now that we have discussed what a prompt is, so let us now understand who is a prompt engineer and why it has become the job for the future. Broadly speaking, a prompt engineer is a professional who is capable of drafting queries or prompts in such a way that large language models like GPT, Palm, Llama, Bloom, etc. can generate the response that is expected. These professionals are skilled at crafting accurate and contextual prompts, which in turn allows the model to generate desired results. So here is a quick example for you. Prompt engineers are experts not only at the linguistic front, but they also had extensive domain knowledge and are very well versed with the functioning of neural networks and natural language processing, along with the knowledge of scripting languages and data analysis. Leading job platforms like Indeed and LinkedIn already have many prompt engineer positions. In the United States alone, job postings for this role run in the thousands, reflecting the growing demand. The salary of prompt engineers is also compelling, with a range that spans from $50,000 to over $150,000 per year, depending on experience and specialization. So there are multiple technical concepts that a prompt engineer must be well versed in to be successful in their jobs, such as multimodality, tokens, weights, parameters, transformers, to name a few. Whether it's healthcare, defense, IT services, or edtech industry, the need for skilled prompt engineers is on the rise. There are already several thousand job openings in this field, and the demand will continue to grow. So if you want to hop on this amazing opportunity and become an expert prompt engineering professional, then now is the time. Let us know in the comments what you think about prompt engineering, and if you want to know more about the skills needed to become a prompt engineer, then make sure to like and share this video with your friends and family and tell them about this amazing new job opportunity.
Hello everyone, I am Mank and welcome to today's video where we will be talking about LLM benchmarks, tools used to test and measure how well large language models like GPT and Google Gemini performs. If you have ever wondered how AI models are evaluated, this video will explain it in simple terms. LLM benchmarks are used to check how good these models are at tasks like coding, answering questions, and translating languages or summarizing text. These tests use sample data and specific measurement to see how well the model performs. For example, the model might be tested with a few examples, like few short learning or none at all. like zero-shot learning, to see how it handles new tasks. So now the question arises, why are these benchmarks important? They help developers understand where a model is strong and where it needs improvement. They also make it easier to compare different models, helping people choose the best one for their needs. However, LLM benchmarks do have some limits. They don't always predict how well a model will work in real-world situations, and sometimes model can overfit, meaning they perform well on test data but struggle in practical use. We will also cover how LLM leaderboards rank different models based on their benchmark scores, giving us a clear picture of which models are performing the best. So stay tuned as we dive into how LLM benchmarks work and why they are so important for advancing AI. So without any further ado, let's get started. So what are LLM benchmarks? LLM benchmarks are standardized tools used to evaluate the performance of large language models. They provide a structured way to test LLMs on a specific task or question, using sample data and predefined metrics to measure their capabilities. These benchmarks assess various skills such as coding, common sense reasoning, and NLP tasks like machine translation, question answering, and text summarization. The importance of LLM benchmark lies in their role in advancing model development. They track the progress of an LLM, offering quantitative insights into where the model performs well and where improvement is needed. This feedback is crucial for guiding the fine-tuning process, allowing researchers and developers to enhance model performance. Additionally, benchmarks offers an objective comparison between different LLMs, helping developers and organizations choose the best model for their needs. So how LLM benchmarks work? LLM benchmarks follow a clear and systematic process. They present a task for LLM to complete, evaluate its performance using specific metrics, and assign a score based on how well the model performs. So here is a breakdown of how this process works. The first one is setup. LLM benchmark come with pre-prepared sample data, including coding challenges, long documents, math problem, and real-world conversation. The task span various areas like common sense reasoning, problem solving, question answering, summary generation, and translation, all present to the model at the start of testing. The second step is testing. The model is tested on one of the three ways. Few shot, the LLM is provided with a few examples before being prompted to complete a task, demonstrating its ability to learn from limited data. The second one is zero shot. The model is asked to perform a task without any prior examples, testing its ability to understand new concepts and adapt to unfamiliar scenarios. The third one is fine-tune. The model is trained on a dataset similar to the one used in the benchmark, aiming to enhance its performance on the specific task involved. The third step is scoring. So after completing the task, the benchmark compares the model's output with the expected answer and generates a score, typically ranging from 0 to 100, reflecting how accurately the LLM performs. So now let's move forward. Let's see key metrics for benchmarking LLMs. So LLM's benchmark uses various metrics to assess the performance of large language model. So here are some commonly used metrics. The first one is accuracy or precision. Measure the percentage of correct prediction made by the model. The second one is recall, also known as sensitivity. Measure the number of true positive reflecting the correct prediction made by the model. The third one is F1 score. Combines both accuracy and recall into a single metric, weighing them equally to address any false positive or negatives. F1 score ranging from 0 to 1, where 1 indicates perfect precision and recall. The fourth one is exact match. Tracks the percentage of predictions that exactly match the correct answer, which is especially used for the tasks like translation and question answering. The fifth one is perplexity gauges. Here it will tell you how well a model predicts the next word or token. A lower perplexity score indicates better task comprehension by the model. The sixth one is BLUE, bilingual evaluation understudy. Is used for evaluating machine translation by comparing n-grams, sequence of adjacent text element, between the model's output and the human-produced translation. So these quantitative metrics are often combined for more through evaluation. So in addition, human evaluation introduces qualitatively factors like coherence, relevance, and semantic meaning, provide a nuanced assessment. However, human evaluation can be time-consuming and subjective, making a balance between quantitative and qualitative measures important for comprehensive evaluation. So now let's moving forward see some limitation of LLM benchmarking. While LLM benchmarking are valuable for assessing model performance, they have several limitations that prevents them from the fully predicting real-world effectiveness. So here are some few. The first one is bounded scoring. Once a model achieves the highest possible scores on the benchmark, that benchmark loses its utility and must be updated with more challenging tasks to remain a meaningful assessment tool. The second one is broad dataset. LLM benchmark often rely on sample data from diverse subjects and tasks. So this wide scope may not effectively evaluate a model's performance in edge cases, specialized fields, or specific use cases where more tailored data would be needed. The third one is finite assessment. Benchmark only tests a model's current skills, and as LLMs evolve and new capabilities emerge, new benchmarks must be created to measure these advancements. The fourth one is overfitting. So if an LLM is trained on the same data used for benchmarking, it can be lead to overfitting, where the model performs well on the test data but struggles with the real task. So this result is scores that don't truly represent the model's broader capabilities. So now what are LLM leaderboards? So LLM leaderboards publish a ranking of LLMs based on the variety of benchmarks. Leaderboards provide a way to keep track to the myriad LLMs and compare their performance. LLM leaderboards are especially beneficial in making decisions on which models to use. So here are some. So in this you can see here OpenAI is leading and GPT-4o second and the Lama third with 405 parameter B and 3.5 sonnet is there. So this is best in multitask reasoning. What about the best in coding? So here OpenAI O1 is leading. I guess this is the Orion one, and the second one is 3.5 sonnet, and after that in the third position there is GPT-4o. So this is in best in coding. So next comes fastest and most affordable models. So fastest models are Lama 8B parameter, and the second one is LLAMA Lama 70B, and the third one is 1.5 Flash. This is Gemini 1, and lowest latency. And here it is leading Lama again. In cheapest models, again Lama 8B is leading, and in the second number we have Gemini Flash 1.5, and in third we have GPT-4o Mini. Moving forward, let's see standard benchmarks between Claude 3 Opus and GPT-4. So in general they are equal. In reasoning, Claude 3 Opus is leading, and in coding GPT-4 is leading. In math, again GPT-4o is leading. In tool use, Claude 3 Opus is leading, and in multilingual, Claude 3 Opus is leading.
Today, we will discuss about booming topic of this era, multimodal AI. Let's understand with an example. Imagine you are showing a friend your vacation photos. You might describe the sight you saw, the sounds you heard, and even your emotions. This is how humans naturally understand the world, by combining information from different sources. Multimodal AI aims to do the same thing. Let's break the modal AI first. Multimodal refers to the two different ways of communicating. Information like text, speech, images, and videos, where AI stands for artificial intelligence, which are systems that can learn and make decisions. So multimodal AI is a type of AI that can process and understand information from multiple sources, just like you do when you look at your vacation photos. Before delving more into multimodal AI, now that we have understood what is multimodal AI, let's now go a bit further. It is obvious that multimodal AI is not the only AI out there. But what is big deal about multimodal AI that everyone is talking about? That is what we will discuss in this segment. So now let's understand the difference between multimodal AI and the generative AI. While both multimodal AI and generative AI are exciting advancement in AI, they differ in their approach to data and functionality. So generative AI focus creates new data similar to the data it's trained on. And in multimodal AI, focus is to understand and processes information from multiple sources, that is text, speech, images, and videos. Data types of generative AI are primarily works with a single data type like text, writing poems or images, that is generating realistic portraits. Whereas in multimodal AI, data types works with diverse data types, enabling a more comprehensive understanding of the world. The third one is examples like chatbots, text generation models, image editing tools. Whereas multimodal AI example covers virtual assistants, medical diagnosis system, and autonomous vehicles. Strengths are can produce creative and innovative content, automate repetitive tasks, and personalize your experience. Whereas in multimodal AI, strengths are provides a more human-like understanding of the world and improve accuracy. In essence, generative AI excels at creating new data, while multimodal AI excels at understanding and utilizing existing data from diverse sources. They can be complementary, with generative models being used to create new data for multimodal AI systems to learn more from and improve their understanding to the world. Next, let's understand what are the benefits of multimodal AI. The benefits of multimodal AI is that it offers developers and users an AI with more advanced reasoning, problem solving, and generation capabilities. These advancements offers endless possibilities for how next generation application can change the way we work and live. For developers looking to start building, Vortex AI Gemini API offers features such as enterprise security, data residency, performance, and technical support. If your existing Google Cloud customers can start prompting with Gemini AI in Vortex AI right now. Next, let's see what are the multimodal AI big challenges. Multimodal AI is powerful but faces hurdles. The first one is data overload. Managing and storing massive, diverse data is expensive and complex. The second one is meaning mystery. Teaching AI to understand subtle difference in between meaning like sarcasm is tricky. The third one is data alignment. Ensuring data points from different sources staying in tune is challenging. The fourth one is data scarcity. Limited and potentially biased datasets hinder effective training. The fifth one is missing data blues. What happens when data is missing, like distorted audio? The last one is black box blues. Understanding how AI makes decisions can be difficult. So these challenges must be addressed to unlock the full potential of model AI. Next, let's see what is the future of multimodal AI and why is it important. Multimodal AI and multimodals represent a leap forward in how developers build and expand the functionality of AI in the next generation of application. For example, Gemini can understand, explain, and generate high-quality code in the world's most popular programming languages like Python, Java, C++, and Go, freeing developers to work on building more feature-filled applications. Multimodal's AI potential also bring the world closer to AI that's less like smart software and more like an expert helper or assistant.
OpenAI is one of the main leaders in the field of generative AI, with its ChatGPT being one of the most popular and widely used examples. ChatGPT is powered by OpenAI's GPT family of large language models, LLMs. In August and September 2024, there were rumors about a new model from OpenAI, codenamed Strawberry. At first, it was unclear if it was the next version of GPT-4o or something different. On September 12, OpenAI officially introduced the O1 model. Hi, I am Mayank. In this video, we will discuss about OpenAI model O1 and its types. After this, we will perform some basic prompts using OpenAI Preview and OpenAI Mini. And at the end, we will see comparison between the OpenAI O1 models and GPT-4o. So without any further ado, let's get started. What is OpenAI O1? The OpenAI O1 family is a group of LLMs that have been improved to handle more complex reasoning. These models are designed to offer a different experience from GPT-4o, focusing on thinking through problems more thoroughly before responding. Unlike older models, O1 is built to solve challenging problems that require multiple steps and deep reasoning. OpenAI O1 models also use a technique called chain of thought prompting, which allows the model to think through problem step by step. OpenAI O1 consists of two models, O1 Preview and O1 Mini. The O1 Preview model is meant for more complex tasks, while the O1 Mini is a smaller, more affordable version. So what can OpenAI O1 do? OpenAI O1 can handle many tasks, just like other GPT models from OpenAI, such as answering questions, summarizing content, and creating new material. However, O1 is especially good at more complex tasks, including the first one is enhanced reasoning. The O1 models are designed for advanced problem solving, particularly in subjects like science, technology, engineering, and math. The second one is brainstorming and ideation. With its improved reasoning, O1 is great at coming up with creative ideas and solutions in various fields. The number third is scientific research. O1 is perfect for tasks like annotating cell sequencing data or solving complex math needed in areas like quantum optics. The number fourth is coding. The O1 models can write and fix code, performing well on coding tests like Human Eval and Code Forces, and helping developers build multi-step workflows. The fifth one, mathematics. O1 is much better at math than previous model, scoring 83% in the International Mathematics Olympiad test compared to GPT-4o's 13%. It also did well in other math competitions like AIME, making it useful for generating complex formulas for physics. And the last one is self-fact checking. O1 can check the accuracy of its own responses, helping to improve the reliability of its answer. You can use OpenAI O1 models in several ways. ChatGPT Plus and team users have access to O1 Preview and O1 Mini models and can manually choose them in the model picker. Although free users don't have access to the O1 models yet, OpenAI planning to offer O1 Mini to them in the future. Developers can also use these models, OpenAI's API, and they are available on third-party platforms like Microsoft Azure AI Studio and GitHub models. So yes guys, I have opened this ChatGPT 4o model here and ChatGPT O1 Preview, as you can see. So I have this plus model, okay, the paid version of ChatGPT. So I can access this O1 Preview and O1 Mini model. Okay, we will go with O1 Preview model and we will put same prompts in both the model of the ChatGPT 4o and the O1 Preview and see what are the differences are coming. Okay, so we will do some math questions and we will do some coding. We will do some advanced reasoning and quantum physics as well. Okay, so let's start with, so I have some prompt already written with me. So first one is number theory. Okay, so what I will do, I will copy it from here and paste it in this and both. Okay, so let me run in 4o and O1 Preview. So here you can see it's thinking. Okay, so this is what I was saying, chain of thoughts. Okay, so these are the chain of thoughts. First is breaking down the primes, this is, and then is identifying the GCD. And now see the difference between the output. See, output is 561 is not a prime number and the GCD, greatest common deceiver, of 48 and 180 is 12. Okay, here see ChatGPT O1 Preview is giving the output in step by step. First see, determine if 561 is a prime number or not. The number 561 is not a prime number. It's a composite number because it has this. Okay, then second step, then the greatest common divisor. Then they found 12 and answer is no, 561 is not composite number because of this, and the greatest common divisor of 48 and 180 is 12. See, just see the difference between the two models. This is why ChatGPT O1 models are crazy for math, coding and advanced reasoning, quantum physics, for these things. Okay, so let's go with our second step. So here, if you will see, you can see the attach file option in ChatGPT 4o. Okay, you can come upload from your computer, but here you will see in O1 there is no attach file option. This is one drawback. Okay, so here upload from computer. So this is one small. Okay, and let me open this, and this is the question I have. Okay, yeah, so I will copy this, I will run this and this. Okay, see, it's start giving the answer and O1 is still thinking, solving the equation, then analyzing the relationship. Okay, so ChatGPT O1 will take time, but it will give you more accurate, more step by step as you want. Okay, so here you can see solve for x in question, this, and here the steps you can see. Okay, this is more structured way, you can say, in a good structured way. Okay, ChatGPT O1 Preview give you in good structured way as O1 Mini as well. Okay, so yeah, so here they wrote just 1 and 2, this, and here if you'll see question 1, solve for x in this, and step 1 is this, step 2 is this, and step 3 is this, then the answer of x is equals to 3. But here simply they wrote we know this, and x equals to 3. For the second question, see, expanding the left hand side, this, but here step 1, square both sides of the given equation. Start by squaring both sides. Okay, it's written but not in good way. Okay, so this is why O1 is better for math. Okay, so now let's check it for the coding part. Okay, so I have one question. Okay, Let me see what output it will give to. First I will write I need. Okay, leave it. I will copy it and I will copy it as well here. Run it and run it. See, it start giving answer. Okay, and still this will adjust the parameters, ensuring the code generation, because ChatGPT O1 will think first, then it will analyze, then after that it will give you answers. Okay, here the code is done. See, here the code is done and it's still thinking. Step 1, and first here you can't see anything. See, step setup development environment, pip install numpy matplotlib, then this, and here nothing. And but I will ask it, okay, give me code in one tab. Okay, here also I will write give me code in single tab. Okay, so I can just copy and paste. So what I will do, I will open one online compiler and I will directly copy it and paste. Okay, so let's finish this. I hope it will work. So let me open W3 Schools compiler. Okay, yeah, same I will open for this W3 School. Okay, so let me copy the code and my bad and paste it here. Same works for this. Okay, okay, I will copy the code and I will paste it here. Okay, I hope it gives something. Yeah, cool. So yes, now you can see the difference between the output. So this is the output of 4.0 and this is the output of O1 preview. See, O1 preview output is this and this is the output of 4.0. So this is the difference. This is why O1 takes time, but it will give you more accurate result in a good way. Okay, so now let's check something else. So moving on, let's see some advanced reasoning question. Okay, so this is the logical puzzle one, the first one. Okay, so I will copy it and I will paste it here. Okay, this is for O1, this is for preview. Because why I'm not comparing O1 with mini, because they both are same but slightly differences there. Okay, so here we can see more difference between 4.0 old model versus new model, you can say. Okay, so now see, the answer is end in this much only, but it will explain you in a better way. See, thoughts for 7 seconds, explanation, that case 1 then case 2. Okay, with conclusion in both scenarios, summary, and this here, this one small explanation, and that's it, right? So they created O1 preview for more, it will describe you more in a better way, right? Now let's see some scientific reasoning as well. Okay, so let me copy it here. So still thinking, but start giving answer. See, it's thought for 16 seconds. So again, I will say that ChatGPT O1 is much better than ChatGPT 4.0. ChatGPT 4.0 is great for content writing and all, but ChatGPT O1 preview and mini are very good for reasoning, math, coding, or quantum physics, these type of things. Okay, advanced reasoning. Okay, ChatGPT 4o is great for generative text. Okay, like for marketing, writing copies, emails, and all of those. So now let's see some comparison between O1 models and GPT-4o model. When new models are released, their capabilities are revealed through benchmark data in the technical reports. The new OpenAI model excels in complex reasoning tasks. It surpasses human PhD level accuracy in physics, chemistry, biology on the GPQA benchmark. Coding becomes easier with O1 as it ranks in the 89th percentile of the competitive programming questions Codeforce. The model is also outstanding in math. On a qualifying exam for International Mathematics Olympiad IMO, GPT-4o solved only 13% of problems, while O1 achieved 83%. This is truly next level. On the standard ML benchmarks, it has huge improvement across the board. MMLU means multitask accuracy and GPQA is reasoning capabilities. Human evaluation. OpenAI asks people to compare O1 Mini with GPT-4o on difficult open-ended tasks across different topics. Using the same method as the O1 preview versus GPT-4o comparison, like O1 preview, O1 Mini was preferred over GPT-4o for tasks that require strong reasoning skills, but GPT-4o was still favored for language-based tasks. Model speed. As a concrete example, we compared responses from GPT-4o, O1 Mini, and O1 preview on the word reasoning question, while GPT-4o did not answer correctly. Both O1 Mini and O1 preview did, and O1 Mini reached the answer around 3 to 5x faster. Limitation and what's next. Due to its specialization on STEM, science, technology, engineering, and math, reasoning capabilities, O1 Mini's factual knowledge on non-STEM topics such as dates, biographics, and trivia is comparable to small LLMs such as GPT-4o Mini. OpenAI will improve these limitations in future versions, as well as experiment extending the model to other modalities and specialties outside of STEM. On July 25th, OpenAI introduced ChatGPT, a new search tool changing how we find information online. Unlike traditional search engines, which require you to type in specific keywords, ChatGPT lets you ask questions in natural, everyday language, just like having a conversation. So this is a big shift from how we were used to searching the web. Instead of thinking in keywords and hoping to find the right result, you can ask now ChatGPT exactly what you want to know, and it will understand the context and give you direct answers. It's designed to make searching easier and more intuitive without going through links and pages. But with this new way of searching, so there are some important questions to consider. Can ChatGPT compete with Google, the search giant we all know? What makes ChatGPT different from AI overviews, another recent search tool? And how does it compare to ChatGPT, OpenAI, popular conversational AI? So in this video, we are going to explore these questions and more. We will look at what makes ChatGPT special, how it compares to other tools, and why it might change the way we search for information. Whether you are new into tech or just curious, this video will break it down in simple words. Stick around to learn more about ChatGPT. So without any further ado, let's get started. So what is ChatGPT? ChatGPT is a new search engine prototype developed by OpenAI, designed to enhance the way we search for information using AI. Unlike a typical chatbot like ChatGPT, ChatGPT isn't just about having a conversation. It's focused on improving the search experience with some key features. The first one is direct answer. Instead of simply showing you a list of links, ChatGPT delivers direct answer to your question. For example, if you ask, what is the best wireless noise cancellation headphone in 2024? ChatGPT will summarize the top choices, highlighting their pros and cons based on expert reviews and user opinions. So this approach is different from the traditional search engines that typically provide a list of links leading to various articles or videos. The second one is relevant sources. ChatGPT responses come with clear citations and links to the original sources, ensuring transparency and accuracy. So this way you can easily verify the information and delve deeper into the topic if you want. The third one, conversational search. ChatGPT allows you to have a back and forth dialogue with the search engine. You can ask follow-up questions or refine your original query based on the responses you receive, making your search experience more interactive and personalized. Now let's jump into the next topic, which is ChatGPT versus Google. So ChatGPT is being talked about a major competitor to Google in the future. So let's break down how they differ in their approach to search. The first one is conversational versus keyword-based search. ChatGPT uses a conversational interface allowing user to ask questions in natural language and refine their queries through follow-up questions. So this creates a more interactive search experience. On the other hand, Google relies on keyword-based search where user enter specific terms to find relevant web pages. The second thing is direct answer versus list of links. So one of the ChatGPT's standout feature is its ability to provide direct answers to the question. It summarizes information from the various sources and clearly cites them, so you don't have to click through multiple links. Google typically presents a list of links, leaving user to sift through the result to find the information they need. The third one, AI-powered understanding versus keyword matching. ChatGPT uses AI to understand the intent behind your question, offering more relevant results even if your query isn't perfectly worded. Google's primary method is keyword matching, which can sometimes lead to less accurate results, especially for complex queries. The fourth one, dynamic context versus isolated searches. So ChatGPT maintains content across multiple interactions, allowing for more personalized responses, whereas Google treats each search as a separate query without remembering previous interaction. And the last one, real-time information versus indexed web pages. ChatGPT's aim to provide the latest information using real-time data from the web, whereas Google Vast Index is comprehensive but may include outdated or less relevant information. So now let's jump into the next topic, which is ChatGPT versus AI overviews. So ChatGPT and AI overviews both use AI, but they approach search and information delivery differently. It's also worth noting that both tools are still being developed, so their features and capabilities may evolve and even overlap as they grow. So here are the differences. The first one is source attribution. ChatGPT provides clear and direct citation linked to the original sources, making it easy for user to verify the information. Whereas AI overviews include links. The citation may not always be clear or directly associated with specific claims. The second one is transparency control. ChatGPT promises greater transparency by offering publishers control over how their content is used, including the option to opt out of AI training. AI overviews offer less transparency regarding the selection of content and the summarization process used. The next one is scope and depth. ChatGPT strives to deliver detailed and comprehensive answers pulling from a broad range of sources, including potential multimedia content. And in AI overviews offers a concise summary of key points, often with links for further exploration, but with a more limited scope. Now let's jump into the next part. ChatGPT versus ChatGPT. ChatGPT and ChatGPT, both developed by OpenAI, share some core features but serve different purposes. So here are some differences. The first one is primary purpose. ChatGPT designed for search, providing direct answer and sources from the web, whereas ChatGPT focused on conversational AI, generating text responses. The second one is information sources. ChatGPT relies on real-time information from the web, whereas ChatGPT knowledge based on this training data, which might not be current. The third one is response format. ChatGPT prioritizes concise answers with citation and source links. So whereas ChatGPT is more flexible, generating longer text, summarizes creative content, code, and etc. The next feature is use cases. ChatGPT idle for fact-finding, research, and tasks requiring up-to-date information, whereas ChatGPT is suitable for creative writing, brainstorming, drafting emails, and other open-ended tasks. So now question arises, when will ChatGPT be released? ChatGPT is currently in a limited prototype phase, meaning it's not yet widely available. OpenAI is testing with a select group to gather feedback and improve the tool. So if you are interested in trying ChatGPT, so you can join the waitlist on its webpage, but you will need a ChatGPT account. A full public release by the end of 2024 is unlikely, as OpenAI hasn't set a timeline. It's more probable that ChatGPT features will gradually added to the ChatGPT in 2024 or in 2025, with a potential standalone release later based on testing and the feedback. So with this, we have come to the end of this video. If you have any question or doubt, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible.
So welcome to the demo part of the Sora. So this is the landing page when you will log in Sora. So let me tell you, I have the ChatGPT Plus version, not the Pro version. So I have some 721 credits left. Okay, later on I will tell you what are the credits. Okay, so let's explore something here. So these are some recent videos which I have created or tested, you can say, and this featured version is all the users of Sora which are creating videos, so it's coming under featured, so we can learn or we can generate some new ideas like this. Okay, like this parrot and all. Like, this is very cool for learning, and these are some of the saved version, and these are all videos and uploads like this. So let's come into the credit parts. Okay, so you can see I have 721 credit left. So if you will go this help openai.com page, and this page you can see what are the credits. So credits are used to generate videos with Sora. Okay, so if you will create 480p square 5-second video, it will take only 20 credits. Okay, for 10 it will take 40, then this, then this. Okay, for 480p this much credit, 25 credit, 50 credit, like this. 720 is different, 1080p different. Okay, so here it is written, please note that requesting multiple variation at once will be charged at the same rate as running two separate generation requests. Okay, so here this plus icon you can see, so here you can upload the image or video. Okay, so you can also do like this, you can upload the image and you can create the video from that image. Okay, and this is choose from library, your personal library, this library, right? And this option is for the variation. Okay, like these are basically presets like balloon world, stop motion, archival, film noir, or cardboard, and the paper. Okay, so this is the resolution. Okay, 480p, this is the fastest in video generation. Okay, 720p will take like 4x slower, and 1080p 8x slower. I guess 1080p is only available in ChatGPT's pro version. Got it? Okay, so we are just doing. I'm just showing you demo, so I will choose this fastest version only. Okay, so this is the time duration, how long you want, like 5 seconds, 10 seconds, 15 and 20 seconds is available in pro version, okay, of ChatGPT. And this is how much versions you want to take. I will select only 2, okay, because it will again charge more credits to you. Okay, and these credits are monthly basis, I guess. Okay, these credits are monthly basis. Okay, see again, recur, remix, blend, loop to create content. This will take again more credits. Okay, see here, ChatGPT Plus, up to 50 priority videos, 1000 credits. Okay, per month, I guess. Yeah, per month. Up to 720p resolution and the 5-second duration. And ChatGPT Pro, up to 500 priority videos, 10,000 credits, unlimited relax videos, up to 1080p resolution, 20-second duration, download without watermark. Here you can download with watermark, I guess. I don't know. Yeah, we'll see. About everything, okay, ChatGPT. But ChatGPT Pro is $200 per month. So, yeah, it's expensive, right? So yes, let's do something creative. So okay, I will write here. Okay, polar bear enjoying on the Sahara desert. Okay, Sahara desert. Yeah. Okay, you can do a storyboard as well, or you can create directly videos. Okay, so let me show you the storyboard first. Yeah, so frame by frame you can give different what to say, prompt. Okay, here you can give different prompt. Okay, polar bear with family. Okay, playing with sand, like this. Okay, and later on it will create a whole the video. Okay, third, you can describe again, you can add image like this. Okay, this is a story created by the ChatGPT. Okay, let's create. Okay, add it to the queue. Okay, it's very fast actually. Almost done. Yeah, see, with family, you can see playing with the sand. Okay, so these are the two variation. Okay, you can choose either this or either that one.
or either that one. Okay, I'm feeling this much as, yeah. So here you can again edit your story, recut, you can trim or extend this video in a new storyboard. Okay, so basically recut features allow you to creators to pinpoint and isolate the most impactful frame in a video, extending them in either direction to build out of like complete scene. Okay, if we'll choose recut, okay, this thing, fine. Then remix. What remix do is like the remix features allows user to reimagine existing videos by altering their components without losing that essence of the originality, you can say. Okay, you want to add or remove certain things. Okay, what if I want to remove that this polar bear or like this. Okay, or you can say we can change colors, or we can some tweak visual elements. And this blend, so this blend feature allows you to combine with different video. If I want to upload some videos, it will blend both the video, this video particular with that video which I will upload. Okay, right. And the last loop, by the name, loop features feature make it easy to create seamless repetition of the video. Okay, this is one option is ideal for background visuals, music videos like this. Okay, so this is how you can create video in 2 minutes, I can say, just by giving prompt. Okay, this one is favorite, you can save it for the favorite, and this you can sharing options are there, copy link or this unpublish, and you can download. See, I told you without watermark is available in only pro version. So I have this with watermark, you can download. See, download a video in just a click, or you can download as a GIF as well, right? And add to a folder. Okay, fine, this is the notification activity on, right? So let's create one. Okay, monkey with family driving car on the space. Yeah, so okay, I will choose this times 16:9. Let it takes more credit of mine, it's okay. Yeah, add it to the queue. If you'll go to favorites, it will come this one because I chose it. Okay, and if you will ask how this Sora is working, so it's like text to image generative AI models such as like DALL-E 3, Stable Diffusion, and Midjourney. So Sora is a diffusion models. That means that it starts with each frame of the video consisting of the static noise. See, oh, it's cartoonish, but yeah. See, if you want Lamborghini, you can add that I want Lamborghini or Tesla, whatever. So this is how you can generate videos with Sora, in a quick 2 minutes.
Think about this. You're about to create something amazing. An AI that can think, learn, and grow in ways we only dreamed of. And here's the best part. You don't need to be an AI expert to make it happen. What if you could use Langchain, a tool that connects most advanced language models to real-time data, allowing you to build AI applications that are both smart and flexible? It sounds like something out of science fiction, but with Langchain, it's real. As large language models quickly become the backbone of many applications, Langchain has emerged as a game-changing tool, transforming the way we use these powerful technologies. Today, we are diving into Langchain, the ultimate framework that makes AI development easier for everyone. Whether you want to understand user questions with one LLM, create human-like responses with another, or pull in data insights, Langchain makes it all happen. But Langchain is more than just making AI easy to use. It's about getting these models to work together seamlessly. Langchain simplifies what could be a complex process into a simple, powerful system. From smart chatbots to enhancing data for machine learning, the possibilities with Langchain are endless. So why has Langchain become one of the fastest growing open source projects ever? And how you can use Langchain to get ahead in the world of AI. So let's first start by understanding what is Langchain. Langchain is an open source framework designed to help developers build AI-powered applications using large language models or LLMs, just like GPT-4. But what really sets Langchain apart is its ability to link these powerful models with external data sources and other components. So this allows you to create sophisticated natural language processing NLP applications that can do much more than just understand and generate text. They can interact with live data, databases, and other software tools. Now you might be asking, is Langchain a Python library? Yes, it is. Langchain is available as a Python library, which means you can easily integrate into your existing Python projects. But it doesn't stop there. Langchain is also available in JavaScript and TypeScript, making it accessible to a wide range of developers. Whether you're working on a web app or backend system or a standalone tool, Langchain fits right in. So why should we use Langchain? So why is Langchain such a big deal? Developing AI applications typically requires using multiple tools and writing a lot of complex code. You need to manage data retrieval, processing, integration with language models, and many more. This can be time-consuming and complicated, especially if you're not deeply familiar with AI. Langchain simplifies the entire process, allowing you to develop and deploy and even manage AI applications more easily and efficiently. Let's break down this with an example. Imagine you're building a chatbot that needs to provide real-time weather updates. Without Langchain, you would need to manually connect your AI to a weather API, fetch data, process it, and then format the response. But with Langchain, the process becomes much more straightforward. You can focus on what matters the most, building the features and functionalities of your application, while Langchain handles the complex integrations behind the scenes. So let's discuss the key features of Langchain. Langchain is packed with features that make it incredibly powerful and flexible. Let's take a closer look at some of the key components. At first, we have model interaction. Langchain allows you to interact with any language model seamlessly. It manages the inputs and outputs to these data models, ensuring that you can integrate them into your application without a hitch. For example, if you want to use GPT-4 to generate responses to customer inquiries, Langchain makes it easy to plug that model into your workflow. Next, we have data connection and retrieval. One of the Langchain's strengths is its ability to connect to external data sources. So whether you need to pull data from a database or web API or even a file system, Langchain simplifies this process. You can retrieve, transform, and use data from almost any source, making your AI applications more robust and versatile. Next, we have chains. Langchain introduces the concept of chains, where you can link multiple models and components together to perform complex tasks. For example, you might have a chain where one component retrieves data and another processes it, and a third generates a human-like response. This chaining ability allows you to build workflows that would otherwise require extensive coding. Next, we have agents. Agents are like the decision makers in Langchain. They can create commands deciding the best course of action based on the input they receive. For example, an agent cloud determines which language model to use based on the type of query it's handling, making your application smarter and more adaptive. Then we have memory. Langchain supports both short-term and long-term memory, making that your AI can remember past interactions. This is particularly useful for applications like chatbots, where maintaining context over multiple interactions are significantly improve the user experience. Imagine you're building a virtual assistant. The assistant needs to remember previous interactions to provide relevant responses. Now, with the help of Langchain, you can easily implement memory so that the assistant knows what you have talked before, making the conversation more natural and engaging. So what are the integrations supported by Langchain? Well, Langchain is designed to work seamlessly with a wide variety of integrations, making it extremely versatile for different use cases. LLM providers. Langchain supports integration with major LLM providers like OpenAI, Hugging Face, and Cohort. This means you can easily incorporate the latest and most powerful language models into your applications. Then we have data sources. Langchain can connect to a variety of data sources such as Google Search, Wikipedia, and cloud platforms like AWS, Google Cloud, and Azure. This makes it easy to retrieve and use the most up-to-date information in your applications. Vector databases are used for handling large volumes of complex data such as images or long text. So Langchain integrates with vector databases like Pinecone, and these databases store data as high-dimensional vectors, which helps in allowing for efficient and accurate retrieval. So this is particularly useful for applications that require searching through large data sets quickly. For example, let's say you're building an application that needs to analyze thousands of documents to find relevant information. With Langchain, you can integrate a vector database like Pinecone, store your documents as vectors, and quickly search through using them powerful language models. This capability can save you a lot of time and make your application much more effective. Now the question arises how to create prompts in Langchain. Creating prompts in Langchain is much easier with something called a prompt template. A prompt template acts as a set of instructions for language model, and these templates can be customized to varying levels of customizations. For example, you might design a prompt template to ask simple questions, or you could create more detailed instructions that guide the language model to produce high-quality responses. Let's walk through how you can create a prompt using Langchain in Python. Step 1 is installing Langchain. First, you'll need to have Python installed in your system. Once that's set up, you can install Langchain by opening your Python shell or terminal and running the following command: pip install Langchain. The next step is adding integrations to Langchain. This often requires at least one integration to function properly. A common choice is OpenAI's Language Model API. To use OpenAI's API, you'll need to create an account on the OpenAI website and obtain your API key. After that, install OpenAI's Python package and input your API key like this. So this is the following command which is inserted below. You can look into that. Next step is importing and using a prompt template. Now that you have Langchain and the necessary integration set up, you can start creating your prompts. Langchain offers a pre-made prompt template that allows you to structure your text in a way that the language model can easily understand. Here's how you can do it through this particular prompt given below. So in this example, the prompt template asks two variables, which is an adjective and a content subject, and uses them to generate a prompt. The output might be something like, tell me an interesting fact about zebras. The language model would then take this prompt and return a relevant fact about zebras based on the given adjective. This is a simple but powerful way to generate dynamic prompt that can be adapted to a wide range of tasks, from answering questions to generating creative content. Let's now talk about how to develop applications with Langchain. So building applications with Langchain is straightforward and involves a few key steps. First, define your application, know exactly what problem it's solving, and identify the necessary components like language models, data sources, and user interaction. The next step is to build the functionality using Langchain's components such as prompt, chains, and agents. This is where you can create the logic that drives your application, like processing user input or retrieving data. Then we have customizing your application to meet specific needs. Langchain's flexibility allows you to tweak prompts, integrate additional data sources, and fine-tune models for optimal performance. Before going live, it's crucial to test and deploy your application. Testing helps catch any issues, and Langchain makes debugging easy, so you can deploy your application with confidence. For example, let's build a chatbot using Langchain. First, we have to define it is a chatbot that answers questions about technology trends. We then create a functionality by setting a prompt and a chain to process input. Next, we have customization. We customize it by integrating a new API to pull in the latest information. And finally, we test and deploy the chatbot to ensure it responds accurately to users. So Langchain offers endless possibilities across various industries. Let's now look into the examples and use cases of Langchain. Langchain offers endless possibilities across various industries. You can create customer service chatbots that manage queries and transaction, or coding assistants that suggest code snippets and debug issues. In healthcare, Langchain can assist doctors with diagnosis and patient data management. Then we have marketing and e-commerce. It can analyze consumer behavior, generate product recommendations, and craft compelling product descriptions. So with the help of this AI assistant, it helps doctors make quicker, more informed decisions. So Langchain is a powerful framework that makes AI development accessible and efficient.
Welcome to the RNN tutorial. That's the recurrent neural network. So we talk about a feed-forward neural network. In a feed-forward neural network, information flows only in the forward direction, from the input nodes through the hidden layers, if any, and to the output nodes. There are no cycles or loops in the network. And so you can see here we have our input layer. I was talking about how it just goes straight forward into the hidden layers. So each one of those connects and then connects to the next hidden layer, connects to the output layer. And of course we have a nice simplified version where it has a predicted output, and they refer to the input as X a lot of times and the output as Y. Decisions are based on current input, no memory about the past, no future scope. Why recurrent neural network? Issues in feed-forward neural network. So one of the biggest issues is because it doesn't have a scope of memory or time, a feed-forward neural network doesn't know how to handle sequential data. It only considers only the current input. So if you have a series of things, and because 3 points back affects what's happening now, and what your output affects what's happening, that's very important. So whatever I put as an output is going to affect the next one. A feed-forward doesn't look at any of that. It just looks at this is what's coming in. And it cannot memorize previous inputs. So it doesn't have that list of inputs coming in. Solution to feed-forward neural network. You'll see here where it says recurrent neural network, and we have our X on the bottom going to H, going to Y. That's your feed forward. But right in the middle it has a value C, so there's a whole other process. So it's memorizing what's going on in the hidden layers, and the hidden layers, as they produce data, feed into the next one. So your hidden layer might have an output that goes off to Y, but that output goes back into the next prediction coming in. What this does is this allows it to handle sequential data. It considers the current input and also the previously received inputs. And if we're going to look at general drawings and solutions, we should also look at applications of the RNN. Image captioning. RNN is used to caption an image by analyzing the activities present in it. A dog catching a ball in midair. That's very tough. I mean, we have a lot of stuff that analyzes images of a dog and the image of a ball, but it's able to add one more feature in there that's actually catching the ball in midair. Time series prediction. Any time series problem like predicting the prices of stocks in a particular month can be solved using RNN. And we'll dive into that in our use case and actually take a look at some stock. One of the things you should know about analyzing stock today is that it is very difficult. And if you're analyzing the whole stock, the stock market at the New York Stock Exchange in the U.S. produces somewhere in the neighborhood, if you count all the individual trades and fluctuations by the second, it's like 3 terabytes a day of data. So we're only going to look at one stock. Just analyzing one stock is really tricky. In here, we'll give you a little jump on that, so that's exciting, but don't expect to get rich off of it immediately. Another application of the RNN is natural language processing. Text mining and sentiment analysis can be carried out using RNN for natural language processing. And you can see right here the term natural language processing, when you stream those 3 words together, is very different than if I said processing language naturally. So the time series is very important when we're analyzing sentiments. It can change the whole value of a sentence just by switching the words around. Or if you're just counting the words, you might get one sentiment where if you actually look at the order they're in, you get a completely different sentiment. When it rains, look for rainbows. When it's dark, look for stars. Both of these are positive sentiments, and they're based upon the order of which the sentence is going in. Machine translation. Given an input in one language, RNN can be used to translate the input into a different languages as output. I myself am very linguistically challenged. But if you study languages and you're good with languages, you know right away that if you're speaking English, you would say big cat. And if you're speaking Spanish, you would say cat big. So that translation is really important to get the right order, to get, there's all kinds of parts of speech that are important to know by the order of the words. Here this person is speaking in English and getting translated. And you can see here a person is speaking in English in this little diagram. I guess that's denoted by the flags. I have a flag. I own it. No. But they're speaking in English and it's getting translated into Chinese, Italian, French, German, and Spanish languages. Some of the tools coming out are just so cool. So somebody like myself who's very linguistically challenged, I can now travel into worlds I would never think of, because I can have something translate my English back and forth readily, and I'm not stuck with a communication gap. So let's dive into what is a recurrent neural network. Recurrent neural network works on the principle of saving the output of a layer and feeding this back to the input in order to predict the output of the layer. Sounds a little confusing. When we start breaking it down, it'll make more sense. And usually we have a propagation forward neural network with the input layers, the hidden layers, the output layer. With the recurrent neural network, we turn that on its side. So here it is, and now our X comes up from the bottom into the hidden layers into Y, and they usually draw it very simplified, X to H, with C as a loop, A to Y, where A, B, and C are the perimeters. A lot of times you'll see this kind of drawing in here, digging closer and closer into the H and how it works. Going from left to right, you'll see that the C goes in, and then the X goes in. So the X is going upward bound, and C is going to the right. A is going out. And C is also going out. That's where it gets a little confusing. So here we have X in, C in, and then we have Y out and C out. And C is based on HT minus 1. So our value is based on the y and the h value are connected to each other. They're not necessarily the same value because h can be its own thing. And usually we draw this, or we represent it as a function. H of t equals a function of c, where h of t minus 1, that's the last h output, and x of t going in. So it's the last output of h combined with the new input of x, where ht is the new state, fc is a function with the parameter c, that's a common way of denoting it, ht minus 1 is the old state coming out, and then x of t is an input vector at time of step t. Well, we need to cover types of recurrent neural networks. And so the first one is the most common one, which is a one-to-one single output. One-to-one neural network is usually known as a vanilla neural network, used for regular machine learning problems. Why? Because vanilla is usually considered kind of just a real basic flavor. But because it's very basic, a lot of times they'll call it the vanilla neural network, which is not the common term, but it is, like kind of a slang term. People will know what you're talking about usually if you say that. Then we run one-to-many, so you have a single input, and you might have multiple outputs. In this case, image captioning, as we looked at earlier, where we have not just looking at it as a dog, but a dog catching a ball in the air. And then you have many-to-one network, takes in a sequence of inputs. Examples, sentiment analysis, where a given sentence can be classified as expressing positive or negative sentiments. And we looked at that as we were discussing, if it rains, look for a rainbow. So positive sentiment, where rain might be a negative sentiment if you were just adding up the words in there. And then, of course, if you're going to do a one-to-one, many-to-one, one-to-many, there's many-to-many networks, takes in a sequence of inputs and generates a sequence of outputs. Example, machine translation. So we have a lengthy sentence coming in English and then going out in all the different languages. Just a wonderful tool. Very complicated set of computations. If you're a translator, you realize just how difficult it is to translate into different languages. One of the biggest things you need to understand when we're working with this neural network is what's called the vanishing gradient problem. While training an RNN, your slope can be either too small or very large, and this makes training difficult. When the slope is too small, the problem is known as vanishing gradient. And you'll see here they have a nice image, loss of information through time. So if you're pushing not enough information forward, that information is lost, and then when you go to train it, you start losing the third word in the sentence or something like that, or it doesn't quite follow the full logic of what you're working on. Exploding gradient problem. Oh, this is one that runs into everybody. When you're working with this particular neural network, when the slope tends to grow exponentially instead of decaying, this problem is called exploding gradient. Issues in gradient problem: long training time, poor performance, bad accuracy. And I'll add one more in there. Your computer, if you're on a lower end computer testing out a model, will lock up and give you the memory error. Explaining gradient problem. Consider the following two examples to understand what should be the next word in the sequence. The person who took my bike and blank, a thief. The students who got into engineering with blank from Asia. And you can see in here we have our x value going in, we have the previous value going forward, and then you back propagate the error like you do with any neural network. And as we're looking for that missing word, maybe we'll have the person took my bike and blank was a thief. And the student who got into engineering with a blank were from Asia. Consider the following example, the person who took the bike. So we'll go back to the person who took the bike was blank a thief. In order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. So was a thief is singular. The student who got into engineering, well, in order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. And so you can see here the students who got into engineering with blank were from Asia. It might be sometimes difficult for the error to back propagate to the beginning of the sequence to predict what should be the output. So when you run into the gradient problem, we need a solution, the solution to the gradient problem. First, we're going to look at exploding gradient, where we have three different solutions depending on what's going on. One is identity initialization. So the first thing we want to do is see if we can find a way to minimize the identities coming in instead of having it identify everything, just the important information we're looking at. Next is to truncate the back propagation. So instead of having whatever information it's sending to the next series, we can truncate what it's sending. We can lower that particular set of layers. make those smaller. And finally is the gradient clipping. So when we're training it, we can clip what that gradient looks like and narrow the training model that we're using. When you have a vanishing gradient, the opposite problem, we can take a look at weight initialization, very similar to the identity, but we're going to add more weights in there so it can identify different aspects of what's coming in better. Choosing the right activation function. That's huge. So we might be activating based on one thing and we need to limit that. We haven't talked too much about activation functions, so we'll look at that just minimally. There's a lot of choices out there. And then finally there's long short-term memory networks, the LSTMS. And we can make adjustments to that. So just like we can clip the gradient as it comes out, we can also expand on that. We can increase the memory network, the size of it, so it handles more information. And one of the most common problems in today's setup is what they call long-term dependencies. Suppose we try to predict the last word in the text. The clouds are in the, and you probably said sky. Here we do not need any further context. It's pretty clear that the last word is going to be sky. Suppose we try to predict the last word in the text. I have been staying in Spain for the last 10 years. I can speak fluent. Maybe you said Portuguese or French. No, you probably said Spanish. The word we predict will depend on the previous few words in context. Here we need the context of Spain to predict the last word in the text. It's possible that the gap between the relevant information and the point where it is needed to become very large. LSTMs help us solve this problem. So the LSTMS are a special kind of recurrent neural network capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. All recurrent neural networks have the form of a chain of repeating modules of neural network connections. In standard RNNs, this repeating module will have a very simple structure such as a single tangent H layer. LSTMSs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. LSTMS are a special kind of recurrent neural network, capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. LSTMSs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. As you can see, the deeper we dig into this, the more complicated the graphs get. In here, I want you to note that you have x at t minus 1 coming in, you have x at t coming in, and you have x at t plus 1. And you have h at t minus 1, and h at t coming in, and h at t plus 1 going out. And of course, on the other side is the output A. In the middle, we have our tangent H, but it occurs in 2 different places. So not only when we're computing the x at t plus 1 are we getting the tangent H from x at t, but we're also getting that value coming in from the x at t minus 1. So the short of it is as you look at these layers, not only does the propagate through the first layer, goes into the second layer, back into itself, but it's also going into the third layer. So now we're kind of stacking those up. And this can get very complicated as you grow that in size. It also grows in memory too, and in the amount of resources it takes. But it's a very powerful tool to help us address the problem of complicated, long sequential information coming in, like we were just looking at in the sentence. And when we're looking at our long short-term memory network, there's 3 steps of processing in the LSTMS that we look at. The first one is we want to forget irrelevant parts of the previous state. A lot of times, like, is, as, in, a, unless we're trying to look at whether it's a plural noun or not, they don't really play a huge part in the language, so we want to get rid of them. Then selectively update cell state values. So we only want to update the cell state values that reflect what we're working on. And finally, we want to only output certain parts of the cell state. So whatever's coming out, we want to limit what's going out too. And let's dig a little deeper into this. Let's just see what this really looks like. So step 1 decides how much of the past it should remember. First step in the LSTM is to decide which information to be omitted from the cell in that particular time step. It is decided by the sigmoid function. It looks at the previous state, h at t minus 1, and the current input, x at t, and computes the function. So you can see over here we have a function of t equals the sigmoid function of the weight of f the h at t minus 1, and then x at t, plus, of course, you have a bias in there with any of our neural networks, so we have a bias function. So f at t equals forget gate, decides which information to delete that is not important from the previous time step. Considering an LSTM is fed with the following inputs from the previous and present time step. Alice is good in physics. John, on the other hand, is good in chemistry. So, previous output. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our current input. So as we look at this, the first step is the forget gate realizes there might be a change in context after encountering the first full stop. Compares with the current input sentence of x at t. So we're looking at that full stop and then compares it with the input of the new sentence. The next sentence talks about John, so the information on Alice is deleted. Okay, that's important to know. So we have this input coming in, and if we're going to continue on with John, then that's going to be the primary information we're looking at. The position of the subject is vacated and is assigned to John. And so in this one, we've seen that we've weeded out a whole bunch of information, and we're only passing information on John, since that's now the new topic. So step 2 is then to decide how much should this unit add to the current state. In the second layer, there are two parts. One is the sigmoid function, and the other is the tangent h. In the sigmoid function, it decides which values to let through, 0 or 1. Tangent h function gives the weightage to the values which are passed, deciding their level of importance, -1 to 1. And you can see the two formulas that come up. The I of t equals the sigmoid of the weight of I, h of t minus 1, x of t plus the bias of I. And the c of t equals the tangent of h of the weight of c of h of t minus 1, x of t plus the bias of c. So our I of t equals the input gate, determines which information to let through based on its significance in the current time step. If this seems a little complicated, don't worry, because a lot of the programming is already done when we get to the case study. Understanding, though, that this is part of the program is important when you're trying to figure out what to set your settings at. You should also note when you're looking at this, it should have some semblance to your forward propagation neural networks, where we have a value assigned to a weight plus a bias. Very important steps in any of the neural network layers, whether we're propagating into the information from one to the next, or we're just doing a straightforward neural network propagation. Let's take a quick look at this, what it looks like from the human standpoint, as I step out of my suit again. Consider the current input at x of t. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our input. Input gate analyzes the important information. John plays football and he was a captain of his college team is important. He told me over the phone yesterday is less important, hence it is forgotten. This process of adding some new information can be done via the input gate. Now this example is as a human form, and we'll look at training this stuff in just a minute. But as a human being, if I wanted to get this information from a conversation, maybe it's a Google Voice listening in on you or something like that, how do we weed out the information that he was talking to me on the phone yesterday? Well, I don't want to memorize that he talked to me on the phone yesterday, or maybe that is important. But in this case, it's not. I want to know that he was the captain of the football team. I want to know that he served. I want to know that John plays football and he was the captain of the college football team. Those are the two things that I want to take away as a human being. Again, we measure a lot of this from the human viewpoint, and that's also how we try to train them so we can understand these neural networks. Finally, we get to step 3, decides what part of the current cell state makes it to the output. The third step is to decide what will be our output. First, we run a sigmoid layer, which decides what parts of the cell state make it to the output. Then we put the cell state through the tangent h to push the values to be between -1 and 1, and multiply it by the output of the sigmoid gate. So when we talk about the output of t, we set that equal to the sigmoid of the weight of 0 of the h of t minus 1, back one step in time, by the x of t, plus of course the bias. The h of t equals the out of t times the tangent h of c of t. So our O of t equals the output gate, allows the passed in information to impact the output in the current time step. Let's consider the example to predicting the next word in the sentence. John played tremendously well against the opponent and won for his team. For his contributions, Brave blank was awarded player of the match. There could be a lot of choices for the empty space. Current input, brave, is an adjective. Adjectives describe a noun. John could be the best output after brave. Thumbs up for John. awarded player of the match. And if you were to pull just the nouns out of the sentence, team doesn't look right because that's not really the subject we're talking about. Contributions, brave contributions, or brave team, brave player, brave match. So you look at this and you can start to train this neural network so it starts looking at it and goes, oh no, John is what we're talking about. So brave is an adjective, John's going to be the best output. And we give John a big thumbs up. And then of course we jump into my favorite part, a case study. Use case implementation of LSTM. Let's predict the prices of stocks using the LSTM network based on the stock price data between 2012 2016. We're going to try to predict the stock prices of 2017. And this will be a narrow set of data. We're not going to do the whole stock market. It turns out that the New York Stock Exchange generates roughly 3 terabytes of data per day. That's all the different trades up and down of all the different stocks going on. And each individual one second to second or nanosecond to nanosecond. But we're going to limit that to just some very basic fundamental information. So don't think you're going to get rich off this today. But at least you can give a step forward in how to start processing something like stock prices, a very valid use for machine learning in today's markets. Use case implementation of LSTM. Let's dive in. We're going to import our libraries. We're going to import the training set and get the scaling going. Now, if you watch any of our other tutorials, a lot of these pieces just start to look very familiar because it's a very similar setup. But let's take a look at that. And just a reminder, we're going to be using Anaconda, the Jupyter Notebook. So here I have my Anaconda navigator. When we go under environments, I've actually set up a Keras Python 3.6. I'm in Python 3.6. And nice thing about Anaconda, especially the newer version, I remember a year ago messing with Anaconda in different versions of Python in different environments. Anaconda now has a nice interface. And I have this installed both on a Ubuntu Linux machine and on Windows, so it works fine on there. You can go in here and open a terminal window. And then in here, once you're in the terminal window, this is where you're going to start installing using pip to install your different modules and everything. Now we've already pre-installed them, so we don't need to do that in here. But if you don't have them installed in your particular environment, you'll need to do that. And of course, you don't need to use the Anaconda or the Jupyter. You can use whatever favorite Python IDE you like. I'm just a big fan of this because it keeps all my stuff separate. You can see on this machine I have specifically installed one for Keras, since we're going to be working with Keras under TensorFlow. When we go back to home, I've gone up here to application, and that's the environment I've loaded on here. And then we'll click on the Launch Jupyter Notebook. Now I've already, in my Jupyter Notebook, have set up a lot of stuff so that we're ready to go. Kind of like Martha Stewart's in the old cooking shows. We want to make sure we have all our tools for you so you're not waiting for them to load. And if we go up here to where it says New, you can see where you can create a new Python 3. That's what we did here underneath the setup, so it already has all the modules installed on it. And I'm actually renamed this. If you go under File, you can rename it. I'm calling it RNN Stock. And let's just take a look at start diving into the code. Let's get into the exciting part. Now we've looked at the tool, and of course you might be using a different tool, which is fine. Let's start putting that code in there and seeing what those imports and uploading everything looks like. Now, the first half is kind of boring when we hit the run button, because we're going to be importing NumPy as NP. That's the number Python, which is your NumPy array, and the matplot library, because we're going to do some plotting at the end, and our pandas for our data set. Our pandas is PD. And when I hit run, it really doesn't do anything except for load those modules. Just a quick note, let me just do a quick draw here. Oops, Shift-Alt, there we go. You'll notice when we're doing this setup, if I was to divide this up, oops, I'm going to actually, let's overlap these, here we go. This first part that we're going to do is our data prep. A lot of prepping involved. In fact, depending on what your system is, since we're using Keras, I put an overlap here, but you'll find that almost maybe even half of the code we do is all about the data prep. And the reason I overlap this with Keras, let me just put that down because that's what we're working in, is because Keras has like their own preset stuff, so it's already pre-built in, which is really nice. So there's a couple steps a lot of times that are in the Keras setup. We'll take a look at that to see what comes up in our code as we go through and look at stock. And then the last part is to evaluate. And if you're working with shareholders or classroom, whatever it is you're working with, the evaluate is the next biggest piece. So the actual code here, Cross is a little bit more, but when you're working with some of the other packages, you might have like 3 lines. That might be it. All your stuff is in your pre-processing and your data. Since Keras is cutting edge and you load the individual layers, you'll see that there's a few more lines here and Keras is a little bit more robust. And then you spend a lot of times, like I said, with the evaluate, you want to have something you present to everybody else and say, hey, this is what I did, this is what it looks like. So let's go through those steps. This is like a kind of just general overview. And let's just take a look and see what the next set of code looks like. And in here we have a dataset train, and it's going to be read using the PD, or pandas.readCSV, and it's the Google stock price train.csv. And so under this we have training set equals dataset train.iLocation, and we've kind of sorted out part of that. So what's going on here? Let's just take a look at it. Let's look at the actual file and see what's going on there. Now if we look at this, ignore all the extra files on this, I already have a train and a test set where it's sorted out. This is important to notice because a lot of times we do that as part of the pre-processing of the data. We take 20% of the data out so we can test it, and then we train the rest of it. That's what we use to create our neural network. That way we can find out how good it is. But let's go ahead and just take a look and see what that looks like as far as the file itself. And I went ahead and just opened this up in a basic WordPad and text editor just so we can take a look at it. Certainly you can open up an Excel or any other kind of spreadsheet. And we note that this is a comma-separated variables. We have a date, open, high, low, close, volume. This is the standard stuff that we import into our stock, and we're the most basic set of information you can look at in stock. It's all free to download. In this case, we downloaded it from Google. That's why we call it the Google stock price. And it specifically is Google. This is the Google stock values from, as you can see here, we started off at 1/3/2012. So when we look at this first setup up here, we have a dataset train equals PD_CSV. And if you noticed on the original frame, let me just go back there, they had it set to home Ubuntu downloads Google stock price train. I went ahead and changed that because we're in the same file where I'm running the code. So I've saved this particular Python code, and I don't need to go through any special paths or have the full path on there. And then of course we want to take out certain values in here. And you're going to notice that we're using our data set, and we're now in pandas. So pandas, basically it looks like a spreadsheet. And in this case we're going to do iLocation, which is going to get specific locations. The first value is going to show us that we're pulling all the rows in the data. And the second one is we're only going to look at columns 1 and 2. And if you remember here from our data, as we switch back on over, columns, we always start with 0, which is the date. And we're going to be looking at open and high, which would be 1 and 2. We'll just label that right there so you can see. Now, when you go back and do this, you certainly can extrapolate and do this on all the columns. But for the example, let's just limit a little bit here so that we can focus on just some key aspects of stock. And then we'll go up here and run the code. And again, I said the first half is very boring. Whenever you hit the run button, it doesn't do anything because we're still just loading the data and setting it up. Now that we've loaded our data, we want to go ahead and scale it. We want to do what they call feature scaling. And in here we're going to pull it up from the sklearn or the skKit pre-processing import min-max scaler. And when you look at this, you got to remember that biases in our data, we want to get rid of that. So if you have something that's like a really high value, let's just draw a quick graph. And I have something here like maybe the stock has a value, one stock has a value of 100 and another stock has a value of 5. You start to get a bias between different stocks. And so when we do this, we go ahead and say, okay, 100 is going to be the max, and 5 is going to be the min, and then everything else goes, and then we change this, so we just squish it down. I like the word squish. So it's between 1 and 0. So 100 equals 1, or 1 equals 100, and 0 equals 5. And you can just multiply. It's usually just a simple multiplication we're using. Multiplication. So it's going to be minus 5 and then 100 divided, or 95 divided by 1. So, or whatever value is divided by 95. And once we've actually created our scale, we're telling us it's going to be from 0 to 1. We want to take our training set and we're going to create a training set scaled. And we're going to use our scalar, SC, and we're going to fit. We're going to fit and transform the training set. So we can now use the SC, this particular object, we'll use it later on our testing set. Because remember, we have to also scale that when we go to test our model and see how it works. And we'll go ahead and click on the run. Again, it's not going to have any output yet because we're just setting up all the variables. Okay, so we paste the data in here, and we're going to create the data structure with the 60 time steps and output. First note, we're running 60 time steps, and that is where this value here also comes in. So the first thing we do is we create our xtrain and ytrain variables, and we set them to an empty Python array. Very important to remember what kind of array we're in and what we're working with. And then we're going to come in here, we're going to go for I in range 60 to 1258. There's our 60 time steps. And the reason we want to do this is as we're adding the data in, there's nothing below the 60. So if we're going to use 60 time steps, we have to start at point 60 because it includes everything underneath of it. Otherwise, you'll get a pointer error. And then we're going to take our xtrain and we're going to append training set scaled. This is the scaled value between 0 and 1. And then as I is equal to 60, this value is going to be 60 minus 60 is 0. So this actually is 0 to I. So it's going to be 0 to 60, 1 to 61. Let me just circle this part right here. 1 to 61, 2 to 62, and so on and so on. And if you remember, I said 0 to 60. That's incorrect because it does not count. Remember, it starts at 0, so this is a count of 60. So it's actually 59. Important to remember that as we're looking at this. And then the second part of this that we're looking at, so if you remember correctly, here we go from 0 to 59 of I, and then we have a comma, a 0 right here. And so finally, we're just going to look at the open value. Now, I know we did put it in there for 1 to 2. If you remember correctly, it doesn't count the second one, so it's just the open value we're looking at, just open. And then finally, we have ytrain.append training set I to 0. And if you remember correctly, I comma 0. If you remember correctly, this is 0 to 59, so there's 60 values in it. So when we do I down here, this is number 60. So what we're going to do this is we're creating an array, and we have 0 to 59. And over here we have number 60, which is going into the ytrain. It's being appended on there. And then this just goes all the way up. So this is down here is 0 to 59, and we'll call it 60 since that's the value over here, and it goes all the way up to 1258. That's where this value here comes in. That's the length of the data we're loading. So we've loaded two arrays. We've loaded one array that has, which is filled with arrays from 0 to 59, and we loaded one array which is just the value. And what we're looking at, you want to think about this as a time sequence. Here's my open. What's the next one in the series? So we're looking at the Google stock, and each time it opens, we want to know what the next one, 0 through 59, what's 60? 1 through 60, what's 61? 2 through 62, what's 62? And so on going up. And then once we've loaded those in our for loop, we go ahead and take xtrain and ytrain equals np.array xtrain.nparray ytrain. We're just converting this back into a numpy array. That way we can use all the cool tools that we get with numpy array, including reshaping. So if we take a look and see what's going on here, we're going to take our xtrain, we're going to reshape it. Wow, what the heck does reshape mean? That means we have an array, if you remember correctly, so many numbers by 60. That's how wide it is. And so when you do xtrain.shape, that gets one of the shapes. And you get xtrain.shape of 1 gets the other shape. And we're just making sure the data is formatted correctly. And so you use this to pull the fact that it's 60 by, in this case, where's that value? 60 by 1199, 1258 minus 60, 1199, and we're making sure that that is shaped correctly. So the data is grouped into 1199 by 60 different arrays. And then the 1 on the end just means at the end, because when you're dealing with shapes and NumPy, they look at this as layers. And so the end layer needs to be one value. That's like the leaf of a tree, where this is the branch, and then it branches out some more, and then you get the leaf. np.reshape comes from and using the existing shapes to form it. We'll go ahead and run this piece of code. Again, there's no real output. And then we'll import our different Keras modules that we need. So from Keras models, we're going to import the sequential model. We're dealing with sequential data. We have our dense layers. We have actually 3 layers we're going to bring in. Our dense, our LSTM, which is what we're focusing on, and our dropout. And we'll discuss these 3 layers more in just a moment. But you do need with the LSTM, you do need the dropout, and then the final layer will be the dense. But let's go ahead and run this, and that'll import our modules. And you'll see we get an error on here. And if you read it closer, it's not actually an error, it's a warning. What does this warning mean? These things come up all the time when you're working with such cutting-edge modules that are completely being updated all the time. We're not going to worry too much about the warning. All it's saying is that the H5PY module, which is part of Keras, is going to be updated at some point. And if you're running new stuff on Keras and you start updating your Keras system, you better make sure that your H5Pi is updated too, otherwise you're going to have an error later on. And you can actually just run an update on the H5Pi now if you wanted to. Not a big deal. We're not going to worry about that today. And I said we were going to jump in and start looking at what those layers mean. I meant that. And we're going to start off with initializing the RNN, and then we'll start adding those layers in. And you'll see that we have the LSTM and then the dropout. LSTM, then dropout. LSTM, then dropout. What the heck is that doing? So let's explore that. We'll start by initializing the RNN, regressor equals sequential, because we're using the sequential model, and we'll run that and load that up. And then we're going to start adding our LSTM layer and some dropout regularization. And right there should be the cue, dropout regularization. And if we go back here and remember our exploding gradient, well, that's what we're talking about. The dropout drops out unnecessary data, so we're not just shifting huge amounts of data through the network. So we go in here. Let's just go ahead and add this in. I'll go ahead and run this. And we had 3 of them. So let me go ahead and put all 3 of them in, and then we can go back over them. Here's the second one, and let's put 1 more in. Oops, put that in, and we'll go ahead and put 2 more in. I said 1 more in, but it's actually 2 more in. And then let's add 1 more after that. And as you can see, each time I run these, they don't actually have an output. So let's take a closer look and see what's going on here. So we're going to add our first LSTM layer in here. We're going to have units 50. The units is the positive integer, and it's the dimensionality of the output space. This is what's going out into the next layer. So we might have 60 coming in, but we have 50 going out. We have a return sequence, because it is a sequence data, so we want to keep that true. And then you have to tell it what shape it's in. Well, we already know the shape by just going in here and looking at xtrain shape. So input shape equals the xtrain shape of 1, 1. It makes it real easy. You don't have to remember all the numbers that put in 60 or whatever else is in there. You just let it tell the regressor what model to use. And so we follow our STM with a dropout layer. Now, understanding the dropout layer is kind of exciting because one of the things that happens is we can overtrain our network. That means that our neural network will memorize such specific data that it has trouble predicting anything that's not in that specific realm. To fix for that, each time we run through the training mode, we're going to take 0.2 or 20% of our neurons and just turn them off. So we're only going to train on the other ones. And it's going to be random. That way, each time we pass through this, we don't overtrain. These nodes come back in the next training cycle. We randomly pick a different 20. And finally, I see a big difference as we go from the first to the second and third and fourth. The first thing is we don't have to input the shape. Because the shape's already, the output units is 50 here, the next step automatically knows this layer is putting out 50, and because it's the next layer, it automatically sets that and says, oh, 50 is coming out from our last layer. It's coming out, goes into the regressor, and of course we have our dropout. And that's what's coming into this one, and so on, and so on. And so the next 3 layers, we don't have to let it know what the shape is. It automatically understands that. And we're going to keep the units the same. We're still going to do 50 units. It's still a sequence coming through, 50 units and a sequence. Now, the next piece of code is what brings it all together. Let's go ahead and take a look at that. And we come in here, we put the output layer. the dense layer. And if you remember up here, we had the 3 layers. We had LSTM, dropout, and dense. Dense just says we're going to bring this all down into one output. Instead of putting out a sequence, we just want to know the answer at this point. And let's go ahead and run that. And so in here, you notice all we're doing is setting things up, one step at a time. So far, we've brought in our, way up here, we brought in our data, we brought in our different modules, we formatted the data for training it, we set it up, we have our X train and our Y train, we have our source of data and the answers we know so far that we're going to put in there. We've reshaped that, we've come in and built our Keras, we've imported our different layers, and we have in here, if you look, we have 5 total layers. Now, Keras is a little different than a lot of other systems because a lot of other systems put this all in one line and do it automatic, but they don't give you the options of how those layers interface, and they don't give you the options of how the data comes in. Keras is cutting edge for this reason. So even though there's a lot of extra steps in building the model, this has a huge impact on the output and what we can do with these new models from Keras. So we brought in our dense, we have our full model put together, our regressor. So we need to go ahead and compile it, and then we're going to go ahead and fit the data. We're going to compile the pieces so they all come together, and then we're going to run our training data on there and actually recreate our regressor so it's ready to be used. So let's go ahead and compile that, and I can go ahead and run that. And if you've been looking at any of our other tutorials on neural networks, you'll see we're going to use the optimizer Atom. Atom is optimized for big data. There's a couple other optimizers out there beyond the scope of this tutorial, but certainly Atom will work pretty good for this. And loss equals mean squared value. So when we're training it, this is what we want to base the loss on. How bad is our error? Well, we're going to use the mean squared value for our error and the Atom optimizer for its differential equations. You don't have to know the math behind them, but certainly it helps to know what they're doing and where they fit into the bigger models. And then finally we're going to do our fit, fitting the RN into the training set. We have the regressor.fit, X-train, Y-train, epochs, and batch size. So we know where this is. This is our data coming in. For the X-train, our Y-train is the answer we're looking for of our data, our sequential input. Epochs is how many times we're going to go over the whole data set. We created a whole data set of X-train. So this is each of those rows, which includes a time sequence of 60. And batch size, another one of those things where Keras really shines, is if you were pulling this, say, from a large file, instead of trying to load it all into RAM, it can now pick smaller batches up and load those indirectly. We're not worried about pulling them off a file today because this isn't big enough to cause the computer too much of a problem to run, not too straining on the resources. But as we run this, you can imagine what would happen if I was doing a lot more than just one column in one set of stock, in this case Google stock. Imagine if I was doing this across all the stocks and I had, instead of just the open, I had open, close, high, low, and you can actually find yourself with about 13 different variables times 60 because it's a time sequence. Suddenly you find yourself with a gig of memory you're loading into your RAM, which will just completely, if you're not on multiple computers or cluster, you're going to start running into resource problems. But for this, we don't have to worry about that. So let's go ahead and run this, and this will actually take a little bit on my computer because it's an older laptop. And give it a second to kick in there. There we go. All right, so we have epoch. So this is going to tell me it's running the first run through all the data. And as it's going through, it's batching them in 32 pieces. So 32 lines each time. And there's 1198. I think I said 1199 earlier, but it's 1198. I was off by 1. And each one of these is 13 seconds. So you can imagine this is roughly 20 to 30 minutes runtime on this computer. Like I said, it's an older laptop running at 0.9 gigahertz on a dual processor. And that's fine. What we'll do is I'll go ahead and stop, go get a drink of coffee, and come back, and let's see what happens at the end and where this takes us. And like any good cooking show, I've gone and gotten my latte. I also had some other stuff running in the background, so you'll see these numbers jumped up to like 19 seconds, 15 seconds. But you can scroll through, and you can see we've run it through 100 steps, or 100 epochs. So the question is, what does all this mean? One of the first things you'll notice is that our loss is over here. It kind of stopped at 0.0014, but you can see it kind of goes down until we hit about 0.014 3 times in a row. So we guessed our epoch pretty close since our loss has remained the same on there. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And a real stock price, data set, test allocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. You see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open, stock open. And let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And a real stock price, data set, test iLocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. You see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open, stock open. And let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data because that's part of the next data, or it's actually the top 59. So that's what this first setup is over here, is we're going in, we're doing the real stock price, and we're going to just take the data set test and we're going to load that in, and then the real stock price is our data test location. So we're just looking at that first column, the open price. And then our data set total, we're going to take pandas and we're going to concat, and we're going to take our data set train for the open and our data set test open. And this is one way you can reference these columns. We've referenced them a couple different ways. We've referenced them up here with the 1, 2, but we know it's labeled as a panda set as open. So pandas is great that way. Lots of versatility there. And we'll go ahead and go back up here and run this. There we go. And you'll notice this is the same as what we did before. We have our open data set. We appended our concatenated our two data sets together. We have our inputs equals data set total length, data set total minus length of data set minus test minus 60 values. So we're going to run this over all of them, and you'll see why this works, because normally when you're running your test set versus your training set, you run them completely separate. But when we graph this, you'll see that we'll be looking at the part that we didn't train it with to see how well it graphs. And we have our inputs equals inputs dot reshape, so reshaping like we did before. We're transforming our inputs. So if you remember from the transform between 0 and 1, and finally we want to go ahead and take our X test, and we're going to create that X test, and for I in range 60 to 80. So here's our X test, and we're appending our inputs I to 60, which remember is 0 to 59, and I comma 0 on the other side. So it's just the first column, which is our open column. And once again, we take our X test, we convert it to a NumPy array. We do the same reshape we did before, and then we get down to the final two lines, and here we have something new. Right here on these last two lines, let me just highlight those or mark them. Predicted stock price equals regressor.predicts X test. So we're predicting all the stock, including both the training and the testing model here. And then we want to take this prediction and we want to inverse the transform. So remember, we put them between 0 and 1, well, that's not going to mean very much to me to look at a float number between 0 and 1. I want the dollar amounts. I want to know what the cash value is. And we'll go ahead and run this, and you'll see it runs much quicker than the training. That's what's so wonderful about these neural networks. Once you put them together, it takes just a second to run the same neural network that took us, what, a half hour to train? Head and plot the data. We're going to plot what we think it's going to be, and we're going to plot it against the real data, what the Google stock actually did. So let's go ahead and take a look at that in code. And let's pull this code up. So we have our PLT. That's our, if you remember from the very beginning, let me just go back up to the top. We have our matplotlibary.pyplot as PLT. That's where that comes in. And we come down here, we're going to plot, and let me get my drawing thing out again. We're going to go ahead, and PLT is basically kind of like an object. It's one of the things that always threw me when I'm doing graphs in Python, because I always think you have to create an object, and then it loads that class in there. Well, in this case, PLT is like a canvas you're putting stuff on. So if you've done HTML5, you'll have the canvas object. This is the canvas. So we're going to plot the real stock price. That's what it actually is. And we're going to give that color red. So it's going to be a bright red. We're going to label it real Google stock price. And then we're going to do our predicted stock. And we're going to do it in blue. And it's going to be labeled predicted. And we'll give it a title, because it's always nice to give a title to your graph, especially if you're going to present this to somebody, to your shareholders in the office. And the X label is going to be time, because it's a time series. And we didn't actually put the actual date and times on here, but that's fine. We just know they're incremented by time. And then, of course, the Y label is the actual stock price. PLT.legend tells us to build the legend on here so that the color red and real Google stock price show up on there. And then the plot shows us that actual graph. So let's go ahead and run this and see what that looks like. And you can see here we have a nice graph, and let's talk just a little bit about this graph before we wrap it up. Here's our legend I was telling you about. That's why we have the legend to show the prices. We have our title and everything. And you'll notice on the bottom we have a time sequence. We didn't put the actual time in here. Now we could have. We could have gone ahead and plotted the X, since we know what the dates are, and plotted this to dates. But we also know this is only the last piece of data that we're looking at. So last piece of data, which ends somewhere probably around here on the graph. I think it's like about 20% of the data, probably less than that. We have the Google price, and the Google price has this little up jump and then down, and you'll see that the actual Google, instead of a turn down here, just didn't go up as high and didn't go down. So our prediction has the same pattern, but the overall value is pretty far off as far as stock. But then again, we're only looking at one column. We're only looking at the open price. We're not looking at how many volumes were traded. And like I was pointing out earlier, when we talk about stock, just right off the bat, there's 6 columns. There's open, high, low, close, volume. Then there's volume shares. Then there's the adjusted open, adjusted high, adjusted low, adjusted close. They have a special formula to predict exactly what it would really be worth based on the value of the stock. And then from there, there's all kinds of other stuff you can put in here. So we're only looking at one small aspect, the opening price of the stock. And as you can see here, we did a pretty good job. This curve follows the curve pretty well. It has like little jumps on it, bends. They don't quite match up. So this bend here does not quite match up with that bend there, but it's pretty darn close. We have the basic shape of it, and the prediction isn't too far off. And you can imagine that as we add more data in and look at different aspects in the specific domain of stock, we should be able to get a better representation each time we drill in deeper. Of course, this took a half hour for my computer to train, so you can imagine that if I was running it across all those different variables, it might take a little bit longer to train the data. Not so good for doing a quick tutorial like this. So we're going to dive right into what is Keras. We'll also go all the way through this into a couple of tutorials, because that's where you really learn a lot, is when you roll up your sleeves. So when we talk about what is Keras, Keras is a high-level deep learning API written in Python for easy implementation of neural networks. It uses deep learning frameworks such as TensorFlow, PyTorch, etc. as backend to make computation faster. And this is really nice because as a programmer, there is so much stuff out there and it's evolving so fast, it can get confusing. And having some kind of high-level order in there, we can actually view it and easily program these different neural networks is really powerful. It's really powerful to have something out really quick and also be able to start testing your models and seeing where you're going. So Keras works by using complex deep learning frameworks such as TensorFlow, PyTorch, MLPlaid, etc. as a backend for fast computation, while providing a user-friendly and easy-to-learn front-end. And you can see here we have the Keras API specifications, and under that you'd have like TF Keras for TensorFlow, Thano Keras, and so on. And then you have your TensorFlow workflow that this is all sitting on top of. And this is, like I said, it organizes everything. The heavy lifting is still done by TensorFlow or whatever underlying package you put in there. And this is really nice because you don't have to dig as deeply into the heavy end stuff while still having a very robust package you can get up and running rather quickly. And it doesn't distract from the processing time because all the heavy lifting is done by packages like TensorFlow. This is the organization on top of it. So the working principle of Keras. The working principle of Keras is Keras uses computational graphs to express and evaluate mathematical expressions. And you can see here we put them in blue. They have the expression expressing complex problems as a combination of simple mathematical operators, where we have like the percentage, or in this case in Python that's usually your remainder, or multiplication. You might have the operator of x to the power of 0.3. And it is useful for calculating derivatives by using back propagation. So if we're doing with neural networks, when we send the error back up to figure out how to change it, this makes it really easy to do that without really not banging your head and having to hand write everything. It's easier to implement distributed computation, and for solving complex problems, specify input and outputs and make sure all nodes are connected. And so this is really nice as you come in through, is that as your layers are going in there, you can get some very complicated different setups nowadays, which we'll look at in just a second. And this just makes it really easy to start spinning this stuff up and trying out the different models. So when we look at Keras models, Keras model, we have a sequential model. Sequential model is a linear stack of layers where the previous layer leads into the next layer. And this, if you've done anything else, even like the sklearn with their neural networks and propagation and any of these setups, this should look familiar. You should have your input layer, it goes into your layer 1, layer 2, and then to the output layer. And it's useful for simple classifier or decoder models. And you can see down here we have the model equals a Keras sequential. And this is the actual code. You can see how easy it is. We have a layer that's dense, your layer 1. As an activation, they're using the ReLU in this particular example. And then you have your name layer 1, layer dense ReLU, name layer 2, and so forth. And they just feed right into each other. So it's really easy just to stack them, as you can see here, and it automatically takes care of everything else for you. And then there's a functional model. And this is really where things are at. This is new. Make sure you update your Keras, or you'll find yourself running this, doing the functional model. You'll run into an error code because this is a fairly new release. And it uses multi-input and multi-output model. The complex model which forks into 2 or more branches. And you can see here we have our image inputs equals your Keras input shape equals 32 by 32 by 3. You have your dense layers, dense 64 activation ReLU. This should look similar to what you already saw before, but if you look at the graph on the right, it's going to be a lot easier to see what's going on. You have 2 different inputs. And one way you could think of this is maybe one of those is a small image and one of those is a full-sized image. And that feedback goes into, you might feed both of them into one node because it's looking for one thing, and then only into one node for the other one. And so you can start to get kind of an idea that there's a lot of use for this kind of split and this kind of setup. Where you have multiple information coming in, but the information's very different even though it overlaps. And you don't want it to send it through the same neural network. And they're finding that this trains faster and also has a better result depending on how you split the data up and how you fork the models coming down. And so in here we do have the 2 complex models coming in. We have our image inputs, which is a 32 by 32 by 3, or 3 channels, or 4 if you're having an alpha channel. You have your dense, your layers, dense is 64 activation using the ReLU, very common. X equals dense inputs, X layers dense X64 activation equals ReLU, X outputs equals layers dense 10X, model equals Keras, model inputs equals inputs, outputs equals outputs, name equals minced model. So we add a little name on there. And again, this is this kind of split here. This is setting us up to have the input go into different areas. So if you're already looking at Keras, you probably already have this answer. What are neural networks? But it's always good to get on the same page, and for those people who don't fully understand neural networks, to dive into them a little bit or do a quick overview. Neural networks are deep learning algorithms modeled after the human brain. They use multiple neurons, which are mathematical operations, to break down and solve complex mathematical problems. And so just like the neuron, one neuron fires in and it fires out to all these other neurons, or nodes as we call them, and eventually they all come down to your output layer. And you can see here we have the really standard graph: input layer, a hidden layer, and an output layer. One of the biggest parts of any data processing is your data pre-processing. So we always have to touch base on that. With a neural network, like many of these models, they're kind of, when you first start using them, they're like a black box. You put your data in, you train it, and you test it and see how good it was. And you have to pre-process that data, because bad data in is bad outputs. So in data pre-processing, we will create our own data examples set with Keras. The data consists of a clinical trial conducted on 2,100 patients, ranging from ages 13 to 100, with the patients under 65 and the other half over 65 years of age. We want to find the possibility of a patient experiencing side effects due to their age. And you can think of this in today's world with COVID, what's going to happen on there. And we're going to go ahead and do an example of that in our live hands-on. Like I said, most of this you really need to have hands-on to understand. So let's go ahead and bring up our Anaconda, and open that up and open up a Jupyter notebook for doing the Python code in. Now, if you're not familiar with those, you can use pretty much any of your setups. I just like those for doing demos and showing people, especially shareholders. It really helps because it's a nice visual. So let me go ahead and flip over to our Anaconda. And the Anaconda has a lot of cool tools. They just added Data Lore and IBM Watson Studio Cloud into the Anaconda framework. But we'll be in the Jupyter Lab or Jupyter Notebook. I'm going to do Jupyter Notebook for this because I use the lab for like large projects with multiple pieces because it has multiple tabs. Or the notebook will work fine for what we're doing. And this opens up in our browser window because that's how Jupyter Notebook is set to run. And we'll go under New, create a new Python 3, and it creates an untitled Python. We'll go ahead and give this a title, and we'll just call this Keras tutorial. And let's change that to capital. There we go. We'll go ahead and just rename that. And the first thing we want to go ahead and do is get some pre-processing tools involved. And so we need to go ahead and import some stuff for that, like our NumPy, do some random number generation. I mentioned sklearn or your scikit. If you're installing sklearn, the sklearn stuff, it's scikit you want to look up. That should be a tool of anybody who is doing data science. If you're not familiar with the sklearn toolkit, it's huge, but there's so many things in there that we always go back to. And we want to go ahead and create some train labels and train samples for training our data. And then just a note of what we're actually doing in here. Let me go ahead and change this. This is kind of a fun thing you can do. We can change the code to Markdown. And then Markdown code is nice for doing examples once you've already built this. Our example data, we're going to do experimental. There we go. Experimental drug was tested on 2,100 individuals between 13 to 100 years of age. Half the participants are under 65, and 95% of participants are under 65. Experienced no side effects, while 95% of participants over 65 experienced side effects. So that's kind of where we're starting at. And this is just a real quick example, because we're going to do another one with a little bit more complicated information. And so we want to go ahead and generate our setup. So we want to do for I in range, and we want to go ahead and create, if you look here, we have random integers, train the labels, append. So we're just creating some random data. And let me go ahead and just run that. And so once we've created our random data, and you can certainly ask for a copy of the code from Simplilearn. They'll send you a copy of this, or you can zoom in on the video and see how we went ahead and did our train samples, append. And we're just using this. I do this kind of stuff all the time. I was running a thing on that had to do with errors following a bell-shaped curve on a standard distribution error. And so what do? I generate the data on a standard distribution error to see what it looks like and how my code processes it, since that was the baseline I was looking for. In this, we're just doing generating random data for our setup on here. And we could actually go in, print some of the data up. Let's just do this, print. We'll do train samples, and we'll just do the first 5 pieces of data in there to see what that looks like. And you can see the first 5 pieces of data in our train samples is 49, 85, 41, 68, 19. Just random numbers generated in there. That's all that is. And we generated significantly more than that. Let's see, 50 up here, 1,000. Yeah, so there's 1,000 here. 1,000 numbers we generated. And we could also, if we wanted to find that out, we can do a quick print the length of it. And so, or you could do a shape kind of thing, and if you're using NumPy, although the length for this is just fine. And there we go, it's actually 2,100, like we said in the demo setup in there. And then we want to go ahead and take our labels. Oh, that was our train labels. We also did samples, didn't we? So we could also print, do the same thing. Oh, labels. And let's change this to labels. And labels. And run that just to double check, and sure enough we have 2,100, and they're labeled 10, 10, 10. I guess that's if they have symptoms or not. 1 symptoms, 0 none. And so we want to go ahead and take our train labels and we'll convert it into a NumPy array, and the same thing with our samples. And let's go ahead and run that. And we also shuffle. This is just a neat feature you can do in NumPy right here. Put my drawing thing on, which I didn't have on earlier. I can take the data and I can shuffle it. So we have our, it just randomizes it. That's all that's doing. We've already randomized it, so it's kind of an overkill. It's not really necessary. But if you're doing a larger package where the data is coming in, and a lot of times it's organized somehow, and you want to randomize it just to make sure that the input doesn't follow a certain pattern that might create a bias in your model. And we go ahead and create a scalar. The scalar range, minimum max scalar, feature range 0 to 1. Then we go ahead and scale the scaled train samples. So we're going to go ahead and fit and transform the data so it's nice and scaled. And that is the age. So you can see up here we have 49, 85, 41. We're just moving that so it's going to be between 0 and 1. And so this is true with any of your neural networks. You really want to convert the data to 0 and 1, otherwise you create a bias. So if you have like 100 creates a bias versus the math behind it gets really complicated. If you actually start multiplying stuff, because there's a lot of multiplication and addition going on in there, that higher end value will eventually multiply down, and it will have a huge bias as to how the model fits it, and then it will not fit as well. And then one of the fun things we can do in Jupyter Notebook is that if you have a variable and you're not doing anything with it, and it's the last one on the line, it will automatically print. And we're just going to look at the first 5 samples on here. And so it's going to print the first 5 samples. And you can see, here we go, 0.9195, 0.791. So everything's between 0 and 1. And that just shows us that we scaled it properly and it looks good. It really helps a lot to do these kind of print-ups halfway through. You never know what's going to go on there. I don't know how many times I've gotten down and found out that the data sent to me that I thought was scaled was not. And then I have to go back and track it down and figure it out on there. So let's go ahead and create our artificial neural network. And for doing that, this is where we start diving into TensorFlow and Keras. TensorFlow, if you don't know the history of TensorFlow, it helps to jump into, we'll just use Wikipedia. Be careful, don't quote Wikipedia on these things because you get in trouble. But it's a good place to start. Back in 2011, Google Brain built Disbelief as a proprietary machine learning setup. TensorFlow became the open source for it. So TensorFlow was a Google product, and then it became open sourced, and now it's just become probably one of the de factos when it comes for neural networks as far as where we're at. So when you see the TensorFlow setup, it's got like a huge following. There are some other setups like the Scikit under the sklearn has their own little neural network, but the TensorFlow is the most robust one out there right now. And Keras sitting on top of it makes it a very powerful tool, so we can leverage both the Keras easiness in which we can build a sequential setup on top of TensorFlow. And so in here we're going to go ahead and do our input of TensorFlow, and then we have the rest of this is all Keras here from number 2 down. We're going to import from TensorFlow the Keras connection. And then you have your TensorFlow Keras models, import sequential. It's a specific kind of model. We'll look at that in just a second. If you remember from the files, that means it goes from one layer to the next layer to the next layer. There's no funky splits or anything like that. And then we have from TensorFlow Keras layers, we're going to import our activation and our dense layer. And we have our optimizer atom. This is a big thing to be aware of, how you optimize your data. When you first do it, Atom's as good as any. Atom is usually, there's a number of optimizer out there. There's a couple of main ones, but Atom is usually assigned to bigger data. It works fine. Usually the lower data does it just fine, but Atom is probably the mostly used. But there are some more out there, and depending on what you're doing with your layers, your different layers might have different activations on them. And then finally down here you'll see our setup where we want to go ahead and use the metrics, and we're going to use the TensorFlow Keras metrics for categorical cross entropy, so we can see how everything performs when we're done. That's all that is. A lot of times you'll see us go back and forth between TensorFlow, and then Scikit has a lot of really good metrics also for measuring these things. Again, it's the end of the at the end of the story, how good does your model do? And we'll go ahead and load all that. And then comes the fun part. I actually like to spend hours messing with these things. And 4 lines of code. You're like, you're going to spend hours on 4 lines of code? No, we don't spend hours on 4 lines of code. That's not what we're talking about when I say spend hours on 4 lines of code. What we have here, and I'm going to explain that in just a second, we have a model. And it's a sequential model. If you remember correctly, we mentioned the sequential up here where it goes from one layer to the next. And our first layer is going to be your input. It's going to be what they call dense, which is usually it's just dense, and then you have your input and your activation. How many units are coming in? We have 16. What's the shape? What's the activation? And this is where it gets interesting. Because we have in here ReLU on 2 of these and softmax activation on 1 of these. There are so many different options for what these mean and how they function. How does the ReLU, how does the softmax function? And they do a lot of different things. We're not going to go into the activations in here. That is what really you spend hours doing, is looking at these different activations. And just some of it is just almost like you're playing with it like an artist. You start getting a feel for like a inverse tangent activation or the tan H activation. takes up a huge processing amount. So you don't see it a lot. Yet it comes up with a better solution, especially when you're doing when you're analyzing Word documents and you're tokenizing the words. And so you'll see this shift from one to the other because you're both trying to build a better model. And if you're working on a huge data set, it'll crash the system. It'll just take too long to process. And then you see things like softmax. Softmax generates an interesting setup where a lot of these, when you talk about ReLU, oops, let me do this. ReLU, there we go. ReLU has a setup where if it's less than 0, it's 0, and then it goes up. And then you might have what they call lazy setup, where it has a slight negative to it so that the errors can translate better. Same thing with softmax. It has a slight laziness to it so that errors translate better. All these little details make a huge difference on your model. So one of the really cool things about data science that I like is you build your what they call you build to fail, and it's an interesting design setup. Oops, I forgot the end of my code here. The concept of build to fail is you want the model as a whole to work, so you can test your model out, so that you can do you can get to the end and you can do your, let's see, where was it? Overshot down here. You can test out the quality of your setup on there. And see, where did I do my TensorFlow? Oh, here we go. It was right above me. There we go. We start doing your cross entropy and stuff like that. Is you need a full functional set of code so that when you run it, you can then test your model out and say, hey, it's either this model works better than this model and this is why. And then you can start swapping in these models. And so when I say I spend a huge amount of time on pre-processing data, it's probably 80% of your programming time. Well, between those two, it's like 80-20. You'll spend a lot of time on the models. Once you get the model down, once you get the whole code and the flow down set, depending on your data, your models get more and more robust as you start experimenting with different inputs, different data streams, and all kinds of things. And we can do a simple model summary here. Here's our sequential, here's our layer, our output, our parameter. This is one of the nice things about Keras is you can see right here, here's our sequential 1 model. Boom, 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 boom. Everything's set and clear and easy to read. So once we have our model built, the next thing we're going to want to do is we're going to go ahead and train that model. And so the next step is, of course, model training. And when we come in here, this a lot of times is just paired with the model because it's so straightforward. It's nice to print out the model setup so you can have a tracking. But here's our model. The keyword in Keras is compile, optimizer atom, learning rate, another term right there that we're just skipping right over that really becomes the meat of the setup is your learning rate. So whoops, I forgot that I had an arrow, but I'll just underline it. A lot of times the learning rate set to 0.01. Depending on what you're doing, this learning rate can overfit and underfit. So you'd want to look up, I know we have a number of tutorials out on overfitting and underfitting that are really worth reading once you get to that point and understanding. And we have our loss, sparse categorical cross entropy. So this is going to tell Keras how far to go until it stops. And then we're looking for metrics of accuracy. So we'll go ahead and run that. And now that we've compiled our model, we want to go ahead and run it, fit it. So here's our model fit. We have our scaled train samples, our train labels, our validation split. In this case, we're going to use 10% of the data for validation. Batch size, another number you kind of play with. Not a huge difference as far as how it works, but it does affect how long it takes to run, and it can also affect the bias a little bit. Most of the time, though, a batch size is between 10 to 100, depending on just how much data you're processing in there. We want to go ahead and shuffle it. We're going to go through 30 epochs and put a verbose of 2. Let me just go ahead and run this. And you can see right here, here's our epic, here's our training, here's our loss. Now if you remember correctly up here, we set the loss. Let's see, where was it? Compiled our data. There we go, loss. So it's looking at the sparse categorical cross entropy. This tells us that as it goes, how much does the error go down? Is the best way to look at that. And you can see here, the lower the number, the better. It just keeps going down. And vice versa, accuracy we want. Let's see, where's my accuracy? Value accuracy at the end. And you can see 0.619, 0.69, 0.74, it's going up. We want the accuracy, would be ideal if it made it all the way to 1. But we also, the loss is more important because it's a balance. You can have 100% accuracy and your model doesn't work because it's overfitted. Again, you want to look up overfitting and underfitting models. And we went ahead and went through 30 epics. It's always fun to kind of watch your code going. To be honest, I usually, the first time I run it, I'm like, oh, that's cool, I get to see what it does. And after the second time of running it, I'm like, I'd like to just not see that. And you can repress those, of course, in your code. Repress the warnings in the printing. And so the next step is going to be building a test set and predicting it now. So here we go. We want to go ahead and build our test set. And we have, just like we did our training set, a lot of times you just split your initial set up. But we'll go ahead and do a separate set on here. And this is just what we did above. There's no difference as far as the randomness that we're using to build this set on here. The only difference is that we already did our scalar up here. Well, that doesn't matter because the data is going to be across the same thing. But this should just be transform down here instead of fit transform. Because you don't want to refit your data on your testing data. There we go. And now we're just transforming it because you never want to transform the test data. Easy mistake to make, especially on an example like this where we're not doing, we're randomizing the data anyway, so it doesn't matter too much because we're not expecting something weird. And then we want to go ahead and do our predictions. The whole reason we built the model is we take our model, we predict, and we're going to do, here's our X-scale data, batch size 10, verbose, and now we have our predictions in here, and we could go ahead and do a, we'll print predictions, and then I guess I could just put down predictions in 5 so we can look at the first 5 of the predictions. And what we have here is we have our age and the prediction on this age versus what we think it's going to be, what we think is they're going to have symptoms or not. And the first thing we notice is that's hard to read because we really want a yes/no answer. So we'll go ahead and just round off the predictions using the argmax, the numpy argmax for predictions. So it just goes to a 0 or 1. And if you remember, this is Jupyter Notebook, so I don't have to put the print. I can just put in rounded predictions, and we'll just do the first 5. And you can see here 0, 1, 0, 0, 0. So that's what the predictions are that we have coming out of this. Is no symptoms, symptoms, no symptoms, symptoms, no symptoms. And just as we were talking about at the beginning, we want to go ahead and take a look at this. There we go. Confusion matrices for accuracy check. Most important part, when you get down to the end of the story, how accurate is your model before you go and play with the model and see if you can get a better accuracy out of it. And for this, we'll go ahead and use the scikit, the sklearn metrics, scikit being where that comes from. Import confusion matrix, some iteration tools, and of course a nice matplot library. That makes a big difference, so it's always nice to have a nice graph to look at. Picture's worth 1,000 words. And then we'll go ahead and call it CM for confusion matrix, y true equals test labels, y predict rounded predictions. we'll go ahead and load in our CM. And I'm not going to spend too much time on the plotting, going over the different plotting code. You can spend we have whole tutorials on how to do your different plotting on there. But we do have here is we're going to do a plot confusion matrix. There's our CM, our classes, normalized false, title, confusion matrix. CMAP is going to be in blues. And you can see here we have to the nearest CMAP, titles, all the different pieces, whether you put tick marks or not, the marks, the classes, the color bar. So a lot of different information on here as far as how we're doing the printing of the confusion matrix. You can also just dump the confusion matrix into a Seaborn and real quick get an output. It's worth knowing how to do all this when you're doing a presentation to the shareholders. You don't want to do this on the fly. You want to take the time to make it look really nice, like our guys in the back did. And let's go ahead and do this. Forgot to put together our CM plot labels. We'll go ahead and run that. And then we'll go ahead and call the definition for our mapping. And you can see here, plot confusion matrix. That's the little script we just wrote. And we're going to dump our data into it. So our confusion matrix, our classes, title confusion matrix. And let's just go ahead and run that. And you can see here we have our basic setup. No side effects, 195. Had side effects, 200. No side effects that had side effects. So we predicted the 10 of them who actually had side effects. And that's pretty good. I mean, I don't know about you, but you know, that's 5% error on this. And this is, because there's 200 here, that's where I get 5% is. Divide these both by 2 and you get 5 out of 100. You can do the same kind of math up here. Not as quick on the fly because it's 15 and 195, not an easily rounded number. But you can see here where they have 15 people who predicted to have with the no side effects but had side effects kind of set up on there. And these confusion matrix are so important at the end of the day. This is really where you show whatever you're working on comes up, and you can actually show them, hey, this is how good we are or not, how messed up it is. So this was I spent a lot of time on some of the parts, but you can see here it's really simple. We did the random generation of data, but when we actually built the model coming up here, here's our model summary, and we just have the layers on here that we built with our model on this, and then we went ahead and trained it and ran the prediction. Now we can get a lot more complicated. Let me flip back on over here because we're going to do another demo. So that was our basic introduction to it. We talked about the oops, here we go. Okay, so implementing a neural network with Keras. After creating our samples and labels, we need to create our Keras neural network model. We will be working with a sequential model which has 3 layers. And this is what we did. We had our input layer, our hidden layers, and our output layers. And you can see the input layer coming in was the age factor. We had our hidden layer, and then we had the output. Are you going to have symptoms or not? So we're going to go ahead and go with something a little bit more complicated. Training our model is a 2-step process. We first compile our model and then we train it in our training data set. So we have compiling. Compiling converts the code into a form of understandable by machine. We used the atom in the last example, a gradient descent algorithm, to optimize the model, and then we trained our model, which means it let it learn on training data. And I actually had a little backwards there, but this is what we just did. Is if you remember from our code we just had, oops, let me go back here. Here's our model that we created, summarized. We come down here and we compile it. So it tells it, hey, we're ready to build this model and use it. And then we train it. And this is the part where we go ahead and fit our model and put that information in here, and it goes through the training on there. And of course we scaled the data, which was really important to do. And then you saw we did the creating a confusion matrix with Keras. As we are performing classifications on our data, we need a confusion matrix to check the results. A confusion matrix breaks down the various misclassifications as well as correct classifications to get the accuracy. And so you can see here, this is what we did with the true positive, false positive, true negative, false negative. And that is what we went over. Let me just scroll down here. On the end, we printed it out, and you can see we have a nice printout of our confusion matrix with the true positive, false negative, true negative. And so the blue ones, we want those to be the biggest numbers because those are the better side. And then we have our false predictions on here as far as this one. So it had no side effects, but we predicted, let's see, no side effects predicting side effects and vice versa.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Now, saving and loading models with Keras. We're going to dive into a more complicated demo. And you're going to say, oh, well, that was a lot of complication before. Well, if you broke it down, we randomized some data, we created the Keras setup, we compiled it, we trained it, we predicted, and we ran our matrix. So we're going to dive into something a little bit more fun. Is we're going to do a face mask detection with Keras. So we're going to build a Keras model to check if a person is wearing a mask or not in real time. And this might be important if you're at the front of a store. This is something today which is might be very useful as far as some of our, making sure people are safe. And so we're going to look at mask and no mask. And let's start with a little bit on the data. And so in my data I have with a mask. You can see they just have a number of images showing the people in masks. And again, if you want some of this information, contact Simplilearn, and they can send you some of the information as far as people with and without masks, so you can try it on your own. And this is just such a wonderful example of this setup on here. So before I dive into the mask detection, talking about being in the current with COVID and seeing if people are wearing masks, this particular example I had to go ahead and update to a Python 3.8 version. It might run in a 3.7, I'm not sure. I kind of skipped 3.7 and installed 3.8. So I'll be running in a Python 3.8, and then you also want to make sure your TensorFlow is up to date, because they call functional layers, that's where they split, if you remember correctly from back. Let's take a look at this. Remember from here, the functional model and a functional layer allows us to feed in the different layers into different nodes into different layers and split them. Very powerful tool, very popular right now in the edge of where things are with neural networks and creating a better model. So I've upgraded to Python 3.8, and let's go ahead and open that up and go through our next example, which includes multiple layers, programming it to recognize whether someone wears a mask or not, and then saving that model so we can use it in real time. So we're actually almost a full end-to-end development of a product here. Of course, this is a very simplified version, and there'd be a lot more to it. You'd also have to do like recognizing whether it's someone's face or not. All kinds of other things go into this. So let's go ahead and jump into that code, and we'll open up a new Python 3. Oops, Python 3. It's working on it. There we go. And then we want to go ahead and train our mask. We'll just call this train mask. And we want to go ahead and train mask and save it. So it's save mask, train mask detection, not to be confused with masking data. A little bit different. We're actually talking about a physical mask on your face. And then from the Keras standpoint, we got a lot of imports to do here. And I'm not going to dig too deep on the imports. We're just going to go ahead and notice a few of them. So we have in here, oops, let me go Alt-D, there we go. Have something to draw with a little bit here. We have our image processing, and the image processing right here, let me underline that, deals with how do we bring images in, because most images are like a square grid, and then each value in there has 3 values for the 3 different colors. Keras and TensorFlow do a really good job of working with that, so you don't have to do all the heavy listening and figuring out what's going to go on. And we have the mobile net average pooling 2D. This again is how do we deal with the images and pulling them? Dropout's a cool thing worth looking up. If you haven't, as you get more and more into Keras and TensorFlow, it'll auto drop out certain nodes. That way you'll get a better, the nodes just kind of die. They find that they actually create more of a bias than a help, and they also add processing time, so they remove them. And then we have our flatten. That's where you take that huge array with the 3 different colors and you find a way to flatten it so it's just a one-dimensional array instead of a 2 by 2 by 3. Dense input, we did that in the other one, so that should look a little familiar. Oops, there we go. Our input, our model, again, these are things we had on the last one. Here's our optimizer with our atom. We have some pre-processing on the input that goes along with bringing in the data in. More pre-processing with image to array, loading the image. This stuff is so nice. It looks like a lot of work, so you have to import all these different modules in here. But the truth is it does everything for you. You're not doing a lot of pre-processing. You're letting the software do the pre-processing. And we're going to be working with setting something to categorical. Again, that's just a conversion from a number to a category. 0, 1 doesn't really mean anything. It's like true, false. Label binarizer, the same thing. We're changing our labels around. And then there's our train test split classification report. Our IM utilities, let me just go ahead and scroll down here a notch for these. This is something a little different going on down here. This is not part of the TensorFlow or the sklearn. This is the scikit setup in TensorFlow above. The path, this is part of OpenCV, and we'll actually have another tutorial going out with the OpenCV. So if you want to know more about OpenCV, you'll get a glance on it in this software, especially the second piece when we reload up the data and hook it up to a video camera. We're going to do that on this round. But this is part of the OpenCV thing, and you'll see CV2 is usually how that's referenced. But the IM utilities has to do with how do you rotate pictures around and stuff like that, and resize them. And then the matplot library for plotting, because it's nice to have a graph, tells us how good we're doing, and then of course our numpy numbers array and just a straight OS access. Wow, so that was a lot of imports. Like I said, I'm not going to spend a little time going through them, but we didn't want to go too much into them. And then I'm going to create some variables that we need to go ahead and initialize. We have the learning rate, number of epochs to train for, and the batch size. And if you remember correctly, we talked about the learning rate to the negative 4.00001. A lot of times it's 0.001 or 0.001. Usually it's in that variation depending on what you're doing and how many epochs, and they kind of play with the epochs. The epochs is how many times we're going to go through all the data. And now I have it as 2. The actual setup is for 20, and 20 works great. The reason I have it for 2 is it takes a long time to process. One of the downsides of Jupyter is that Jupyter isolates it to a single kernel. So even though I'm on an 8-core processor with 16 dedicated threads, only one thread is running on this, no matter what. So it doesn't matter. So it takes a lot longer to run, even though TensorFlow really scales up nicely. And the batch size is how many pictures do we load at once and process. Again, those are numbers you have to learn to play with depending on your data and what's coming in. And the last thing we want to go ahead and do is there's a directory with a data set we're going to run. And this just has images of masks and not masks. And if we go in here, you'll see data set. And then you have pictures with masks. They're just images of people with masks on their face. And then we have the opposite. Let me go back up here. Without masks. So it's pretty straightforward. They look kind of askew because they tried to format them into very similar setup on there. So they're mostly squares. You'll see some that are slightly different on here. And that's kind of an important thing to do on a lot of these data sets. Get them as close as you can to each other. And we actually will run in this processing of images up here and the Keras layers and importing and dealing with images. It does such a wonderful job of converting these that a lot of it we don't have to do a whole lot with. So you have a couple things going on there. And so we're now going to be, this is now loading the images, and let me see. And we'll go ahead and create data and labels. Here's our here's the features going in, which is going to be our pictures, and our labels going out. And then for categories in our list directory, and if you remember, I just flashed that at you. It had face mask or no face mask. Those are the two options. And we're just going to load into that. We're going to append the image itself and the labels. So we're just going to create a huge array. And you can see right now this could be an issue if you had more data. At some point, thankfully I have a 32 gig hard drive or RAM. Even that, you could do with a lot less of that. Probably under 16 or even 8 gigs would easily load all this stuff. And there's a conversion going on in here. I told you about how we are going to convert the size of the image so it resizes all the images. And that way our data is all identical the way it comes in. And you can see here with our labels, we have without mask, without mask, without mask. The other one would be with mask. Those are the two that we have going in there. And then we need to change it to the one-hot encoding. And this is going to take our, up here we had, what was it, labels and data. We want the labels to be categorical. So we're going to take labels and change it to categorical. And our labels then equal a categorical list. We'll run that. And again, if we do labels and we just do the last or the first 10, let's do the last 10 just because minus 10 to the end. There we go. Just so we can see what the other side looks like. We now have 1. That means they have a mask. 1, 0, 1, 0, so on. 1 being they have a mask and 0 no mask. And if we did this in reverse, I just realized that this might not make sense if you've never done this before. Let me run this. 0, 1. So 0 is, do they have a mask on? 0. Do they not have a mask on? 1. So this is the same as what we saw up here without mask. 1 equals, the second value is without mask. So with mask, without mask. And that's just with any of your data processing, we can't really, if you have a 0, 1 output, it causes issues as far as training and setting it up. So we always want to use a one-hot encoder if the values are not actual linear value or regression values, are not actual numbers, if they represent a thing. And so now we need to go ahead and do our train X, test X, train Y, test Y, train, split, test data. And we'll go ahead and make sure it's going to be random, and we'll take 20% of it for testing and the rest for setting it up as far as training their model. This is something that's become so cool. When they're training these set, they realize we can augment the data. What does augment mean? Well, if I rotate the data around and I zoom in, I zoom out, I rotate it, shear it a little bit, flip it horizontally, fill mode, as I do all these different things to the data, it is able to, it's kind of like increasing the number of samples I have. So if I have all these perfect samples, what happens when we only have part of the face, or the face is tilted sideways, or all those little shifts cause a problem if you're doing just a standard set of data. So we're going to create an augment in our image data generator, which is going to rotate, zoom, and do all kinds of cool things. And this is worth looking up, this image data generator and all the different features it has. A lot of times, the first time through my models, I'll leave that out because I want to make sure there's a thing what we call build to fail, which is just cool to know. You build the whole process, and then you start adding these different things in so that you can better train your model. And so we go and run this, and then we're going to load. And then we need to go ahead, and you probably would have gotten an error if you hadn't put this piece in right here. I haven't run it myself because the guys in the back did this. We take our base model, and one of the things we want to do is we want to do a MobileNet v2. And this is a big thing right here. Include the top equals false. A lot of data comes in with a label on the top row. So we want to make sure that that is not the case. And then the construction of the head of the model that will be placed on the top of the base model. We want to go ahead and set that up. And you'll see a warning here. I'm kind of ignoring the warning because it has to do with the size of the pictures and the weights for input shape. So it'll switch things to defaults, just saying, hey, we're going to auto shape some of this stuff for you. You should be aware that with this kind of imagery, we're already augmenting it by moving it around and flipping it and doing all kinds of things to it. So that's not a bad thing in this. But in other data, it might be if you're working in a different domain. And so we're going to go back here, and we have our base model. We're going to do our head model equals our base model output. And what we got here is we have an average pooling 2D, pool size 7.7 head model. Head model flatten, so we're flattening the data. So this is all processing and flattening the images. And the pooling has to do with some of the ways it can process some of the data. We'll look at that a little bit when we get down to the lower level and this processing it. And then we have our dense. We've already talked a little bit about a dense, just what you think about. And then the head model has a dropout of 0.5. What we can do with a dropout, the dropout says that we're going to drop out a certain amount of nodes while training. So when you actually use the model, it will use all the nodes, but this drops certain ones out, and it helps stop biases from forming. So it's really a cool feature in here. They discovered this a while back. We have another dense mode, and this time we're using softmax activation. Lots of different activation options here. Softmax is a real popular one for a lot of things, and so is the ReLU. And we could do a whole talk on activation formulas. And what their different uses are and how they work. When you first start out, you'll use mostly the ReLU and the softmax for a lot of them, just because they're some of the basic setups. It's a good place to start. And then we have our model equals model, inputs equals base model dot input, outputs equals head model. So again, we're still building our model here. We'll go ahead and run that. And then we're going to loop over all the layers in the base model and freeze them so they will not be updated during the first training process. So for layer and base model layers, layers.trainable equals false. A lot of times when you go through your data, you want to kind of jump in partway through. I'm not sure why in the back they did this for this particular example, but I do this a lot when I'm working with series and specifically in stock data. I want it to iterate through the first set of 30 data before it does anything. I would have to look deeper to see why they froze it on this particular one. And then we're going to compile our model. So compiling the model, atom, init, layer, decay, initial learning rate over epochs, and we go ahead and compile. Our loss is going to be the binary cross entropy, which will have that print out. Optimizer for opt, metrics is accuracy. Same thing we had before, not a huge jump as far as the previous code. And then we go ahead and we've gone through all this, and now we need to go ahead and fit our model. So train the head of the network, print info training head, run. Now I skipped a little time because you'll see the runtime here is at 80 seconds per epoch. It takes a couple minutes for it to get through on a single kernel. One of the things I want you to notice on here while it's finishing the processing is that we have up here our augment going on. So anytime the train X and train Y go in, there's some randomness going on there, and is jiggling it around what's going into our setup. Of course, we're batch sizing it, so it's going through whatever we set for the batch values, how many we process at a time. And then we have the steps per epoch, the train X, the batch size, validation data. Here's our test X and test Y, where we're sending that in. And this, again, it's validation. One of the important things to know about validation is when both our training data and our test data have about the same accuracy, that's when you want to stop. That means that our model isn't biased. If you have a higher accuracy on your testing, you've trained it, and your accuracy is higher on your actual test data, then something in there is probably has a bias and it's overfitted. So that's what this is really about right here with the validation data. and validation steps. So it looks like let me go ahead and see if it's done processing. It looks like we've gone ahead and gone through 2 epochs. Again, you could run this through about 20 with this amount of data, and it would give you a nice refined model at the end. We're going to stop at 2 because I really don't want to sit around all afternoon, and I'm running this on a single thread. So now that we've done this, we're going to need to evaluate our model and see how good it is. And to do that, we need to go ahead and make our predictions. These are our predictions on our test X to see what it thinks are going to be. So now it's going to be evaluating the network, and then we'll go ahead and go down here, and we will need to turn the indexing, because remember it's either 0 or 1. It's 0, 1, 0, 1. So you have 2 outputs: not wearing a mask, not wearing a mask. And so we need to go ahead and take that argument at the end and change those predictions to a 0 or 1 coming out. And then to finish that off, we want to go ahead and let me just put this right in here and do it all in one shot. We want to show a nicely formatted classification report so we can see what that looks like on here. And there we have it. We have our precision. It's 97% with a mask. There's our F1 score, support without a mask, 97%. So that's pretty high setup on there. You know, 3 people are going to sneak into this door who are without a mask and thinks they have a mask, and there's going to be 3 people with a mask that's going to flag the person at the front to go, oh, hey, look at this person, he might not have a mask. That's I guess if it's a setup in front of a store. So there you have it. And of course, one of the other cool things about this is if someone's walking into the store and you take multiple pictures of them, you know, this is just it would be a way of flagging, and then you can take that average of those pictures and make sure they match or don't match if you're on the back end. And this is an important step because this is just cool. I love doing this stuff. So we're going to go ahead and take our model and we're going to save it. So model save maskdetector.model. We're going to give it a name. We're going to save the format. In this case, we're going to use the H5 format. And so this model we just programmed has just been saved. So now I can load it up in the model. Now they can use it for whatever. And then if I get more information and we start working with that, at some point I might want to update this model. Make a better model. And this is true of so many things, where I take this model and maybe I'm running a prediction on making money for a company, and as my model gets better, I want to keep updating it, and then it's real easy just to push that out to the actual end user. And here we have a nice graph. You can see the training loss and accuracy as we go through the epochs. We only did only shows just the one epoch coming in here, but you can see right here as the value loss, train accuracy, and value accuracy start switching and they start converging. And you'll hear converging. This is the convergence they're talking about when they say I know when I work in the scikit with sklearn neural networks, this is what they're talking about, a convergence, is our loss and our accuracy come together, and also up here, and this is why I'd run it more than just 2 epochs. As you can see, they still haven't converged all the way. So that would be a cue for me to keep going. But what we want to do is we want to go ahead and create a new Python 3 program. And we just did our train mask. So now we're going to go ahead and import that and use it and show you in a live action. Get a view of both myself in the afternoon along with my background of an office, which is in the middle still of reconstruction for another month. And we'll call this mask detector. And then we're going to grab a bunch of a few items coming in. We have our MobileNet v2 import preprocessing input, because we're still going to need that. We still have our TensorFlow image to array. We have our load model. That's where most of the stuff's going on. This is our CV2 or OpenCV. Again, I'm not going to dig too deep into that. We're going to flash a little OpenCV code at you, and we actually have a tutorial on that coming out. Our NumPy array, our IM utilities, which is part of the OpenCV or CV2 setup. And then we have, of course, time and just our operating system. So those are the things we're going to go ahead and set up on here. And then we're going to create, this takes just a moment. Our module here, which is going to do all the heavy lifting. So we're going to detect and predict a mask. We have frame, FaceNet, MaskNet. These are going to be generated by our OpenCV. We have our frame coming in, and then we want to go ahead and create a mask around the face. It's going to try to detect the face and then set that up so we know what we're going to be processing through our model. And then there's a frame shape here. This is just our height versus width. That's all HW stands for. They've called it blob, which is a CV2 DNN blob form image frame. So this is reformatting this frame that's going to be coming in literally from my camera. And we'll show you that in a minute, that little piece of code that shoots that in here. And we're going to pass the blob through the network and obtain the face detections. So FaceNet.setImport blob, detections FaceNet forward, print detections shape. So this is what's going on here. This is that model we just created. We're going to send that in there, and I'll show you in a second where that is, but it's going to be under FaceNet. And then we go ahead and initialize our list of faces, their corresponding locations, and the list of predictions from our face mask network. We're going to loop over the detections, and this is a little bit more work than you think as far as looking for different faces. What happens if you have a crowd of faces? So we're looping through the detections and the shapes going through here. And probability associated with the detection. Here's our confidence of detections. We're going to filter out weak detection by ensuring the confidence is greater than the minimum confidence. So we've set it, remember, 0 to 1. So 0.5 would be our minimal confidence, probably is pretty good. And then we're going to put in compute bounding boxes for the object. If I'm zipping through this, it's because we're going to do an OpenCV, and I really want to stick to just the Keras part. And so I'm just kind of jumping through all this code. You can get a copy of this code from Simplilearn and take it apart, or look for the OpenCV coming out. And we'll create a box. The box sets it around the image. Ensure the bounding boxes fall within the dimensions of the frame. So we create a box around what we hope is going to be the face. Extract the face, ROI, convert it from BGR to RGB channel. Again, this is an OpenCV issue. Not really an issue, but it has to do with the order. I don't know how many times I've forgotten to check the order colors when working with OpenCV. Because there's all kinds of fun things when red becomes blue and blue becomes red. And we're going to go ahead and resize it, process it, frame it, face frame, setup. Again, the face, the CV2 color, we're going to convert it. We're going to resize it, image to array, pre-process the input, pin the face, locate face, start X, start Y, and X. Boy, that was just a huge amount, and I skipped over a ton of it, but the bottom line is we're building a box around the face, and that box, because the OpenCV does a decent job of finding the face, and that box is going to go in there and see, hey, does this person have a mask on it? And so that's what all this is doing on here. And then finally we get down to this where it says predictions equals masknet.predict faces batch size 32. So these different images where we're guessing where the face is are then going to go through and generate an array of faces, if you will. And we're going to look through and say, does this face have a mask on it? And that's what's going right here is our prediction. That's the big thing that we're working for. And then we return the locations and the predictions. The location just tells where on the picture it is, and then the prediction tells us what it is. Is it a mask or is it not a mask? Alright, so we've loaded that all up. So we're going to load our serialized face detector model from disk. And we have the path that it was saved in. Obviously, you're going to put it in a different path depending on where you have it or however you want to do it and how you saved it on the last one where we trained it. And then we have our weights path. And so finally our FaceNet, here it is, equals cv2.dnn.readnet proto text path awaits path. And we're going to load that up on here. So let me go ahead and run that. And then we also need to, I'll just put it right down here. I always hate separating these things in there. And then we're going to load the actual mass detector model from disk. This is the model that we saved. So let's go ahead and run that on there also. So this is pulling in all the different pieces we need for our model. And then the next part is we're going to open up our video. And this is just kind of fun because it's all part of the OpenCV video setup. And let me just put this all in as one. There we go. So we're going to go ahead and open up our video. We're going to start it and we're going to run it until we're done. And this is where we get some real kind of live action stuff, which is fun. This is what I like working about with images and videos, is that when you start working with images and videos, it's all right there in front of you. It's visual and you can see what's going on. So we're going to start our video streaming. This is grabbing our video stream source 0 start. That means it's grabbing my main camera I have hooked up. And then starting video, you're going to print it out. Here's our video source equals 0 start. Loop over the frames from the video stream. Oops, a little redundancy there. Let me close. I'll just leave it. That's how they had it in the code. So while true, we're going to grab the frame from the threaded video stream and resize it to have the maximum width of 400 pixels. So here's our frame. We're going to read it from our visual stream. We're going to resize it. And then we're returning. Remember, we returned from our procedure the location and the prediction. So detect and predict mask. We're sending it the frame. We're sending it the face net and the mask net. So we're sending all the different pieces that say this is what's going through on here. And then it returns our location and predictions, and then for our box and predictions in the location and predictions, and the box is again, this is an OpenCV set that says, hey, this is a box coming in from the location, because you have the 2 different points on there. And then we're going to unpack the box and predictions, and we're going to go ahead and do mask without a mask equals prediction. We're going to create our label, no mask. We're going to create color if the label equals mask L00225. And this is going to make a lot more sense when I hit the run button here. But we have the probability of the label. We're going to display the label and bounding box rectangle in the output frame. And then we're going to go ahead and show the output from the frame, CV2 IM show frame. And then the key equals CV2 wait key 1. We're just going to wait till the next one comes through from our feed. And we're going to do this until we hit the stop button pretty much. So are you ready for this? Let's see if it works. We've distributed our model. We've loaded it up into our distributed code here. We've got it hooked into our camera. And we're going to go ahead and run it. And there it goes. It's going to be running, and we can see the data coming down here, and we're waiting for the pop-up. And there I am in my office with my funky headset on. And you can see in the background my unfinished wall, and it says up here, no mask. Oh no, I don't have a mask on. I wonder if I cover my mouth, what would happen? You can see my no mask goes down a little bit. I wish I'd brought a mask into my office. It's up at the house. But you can see here that this says, there's a 95, 98% chance that I don't have a mask on. And it's true, I don't have a mask on right now. And this could be distributed. This is actually an excellent little piece of script that you could start, you install somewhere on a video feed on a security camera or something, and then you'd have this really neat setup saying, hey, do you have a mask on when you enter a store or public transportation or whatever it is where they're required to wear a mask. Let me go ahead and stop that. Now, if you want a copy of this code, definitely give us a holler. We will be going into OpenCV in another one, so I skipped a lot of the OpenCV code in here as far as going into detail. Really focusing on the Keras, saving the model, uploading the model, and then processing a streaming video through it so you can see that the model works. We actually have this working model that hooks into the video camera, which is just pretty cool and a lot of fun. So I told you we're going to dive in and really roll up our sleeve and do a lot of coding today. We did the basic demo up above for just pulling in a cross, and then we went into a cross model where we pulled in data to see whether someone was wearing a mask or not. So very useful in today's world as far as a fully running application.
Imagine harnessing the power of artificial intelligence to kickstart your own digital business. AI has unlocked endless possibilities, making it easier than ever to create and sell digital products online. From generating captivating art to crafting engaging text, AI tools are your gateway to effortlessly producing a wide range of digital products that can elevate your business or even be sold for profit. The beauty of AI lies in the accessibility. No need to be a tech expert to dive in. In this thrilling article, we will explore the diverse digital products you can create with AI, reveal the best tools at your disposal, and guide you through the process step by step. Get ready to unleash your creativity and see how AI can transform your entrepreneurial aspirations into reality. So, let us understand what are digital products. Whenever we hear the term digital products, we generally think of images, arts, or files that can be downloaded. While these are the majority of the products we can find online, the definition of digital products is much broader. Digital products include paintings, illustrations, graphic designs, photographs, or other forms of visual and multimedia content, and other web-based services. And these are intangible items that are created, sold, and distributed online. Unlike physical goods, digital products exist in a digital format, meaning they don't require inventory, shipping, or storage. Examples of digital products like software, ebooks, online courses, memberships, digital music, and other web-based services. Now let us understand why sell digital products. Selling digital products using AI offers numerous advantages that can significantly enhance your business's efficiency, creativity, and profitability. AI is a game changer for selling digital products online. Whether it's generating stunning artwork, composing music, or writing compelling text, AI expands your creative possibilities, allowing you to produce high-quality digital products quickly. Leveraging AI reduces the need for extensive human resources, cutting down on costs associated with hiring designers, writers, or developers. AI can even analyze customer data to help create personal digital products that are catered to specific audiences. This targeted approach increases the likelihood of sales and customer satisfaction as the products are tailored to meet individual needs and preferences. AI constantly evolves, providing you with cutting-edge tools and techniques to stay ahead in the market. By integrating AI in your digital product business, you position yourself as an innovative leader offering products that stand out with competition. In short, selling digital products using artificial intelligence enables you to tap into the enhanced creativity, efficiency, and scalability while keeping costs low and maintaining a high level of personalization and innovation. It's a smart, future-focused approach to building a successful digital product business. Now let us understand where to sell digital products exactly. Sell your digital products in multiple online sales channels to increase their reach and expose more people to your brand. Starting an online store to list your digital products, promoting your brand, and publish the content that appeals to your audience. Try promoting your digital products in social media and set up social media storefronts so that users can check when they scroll. Most importantly, initially use an e-commerce platform which already has a bunch of perks like huge audience, easy setup, and so much more. For example, Etsy, Gumroad, and Shopify. Now let us understand the top 5 digital products to sell online. The first product is generating guides. There are some famous shops in Etsy that have guides for everything, including the real estate guides, Airbnb cleaning checklists, cooking guides, and so much more templates. Basically, they have good templates with attractive fonts. With the help of AI, you can make it personalized depending on your interest. For example, you can ask the ChatgPT all the things an individual needs to know on Airbnb cleaning and make a good guide of it. Here, 75% of the work is done by AI, and you yourself need to copy the template to Canva or Word and ultimately make it look good. The next product is logo design. Let me tell you, one doesn't need to be a graphic designer to design logos, as Midjourney has the ability to create logos for almost everything. Take up the list from the ChatGPT on which business you can create logos for, and you're halfway there. Finally, you need to utilize your idea and write your prompt in the Midjourney, and the result will shock you for sure. It is one of the most profitable business among all, but you need to understand the language of AI, Midjourney, and a bit of Photoshop. The next product is business cards. This is one of the top selling cards online as it is demanded by most businesses. Basically, it's a card carrying information regarding the type of businesses, their landmarks and contact details, etc. You need to go to the Midjourney to tell it your exact card design and pick up a design and put it in Canva to make it personalized and usable. The next product is resume templates. Without any doubt, this product is booming in the market. With the advantage of AI, it can be one of the most profitable businesses overall. Professionals are continuously searching for better resumes that create impressions and even cross the application tracking system and finally get hired. You just need to tell ChatGPT to create a particular type of resume with necessary sections. You can just write a prompt in Midjourney to create great looking resumes that are unique and you are done. Using both the things together, you can just start the most profitable business. The next product is product mockups. Product mockup is a broad market including frame mockups, t-shirt mockups, pillow mockups, etc. The hero product is the mug mockup, which are actually best for gifting purpose. In the modern era, people are a fan of personalized products and this field actually fans the desires. You need to be back on Midjourney and simply ask to show some simple mugs with white background and Photoshop it to make it personalized. It's a great idea to start the business as it's a trending market and can earn a lot. Now let us understand how to create and sell digital products. After you have basic knowledge about what digital products are and what products to sell, the next step is to know how to create and sell them. So let us understand the step-by-step guide to create and sell digital products. The first point is identifying a product. Begin by identifying a digital product that's in demand. Kate's research led her to gallery wall art. Kate identified a potential product by conducting market research on Etsy, a popular online platform for selling homemade goods. She spotted a demand for a specific type of product, gallery wall art sets, bundles of printable art images. She analyzed the listings using the Adobe Chrome extension to estimate the potential revenue and total sales. Seeing the demand for this type of product and its high earning potential, Kate decided to utilize AI technology to simplify the creation process. Follow the same process and you can identify the real diamond pretty soon. The next point is the website to generate designs. Use websites like Midjourney to generate designs, images, text, anything and everything in just a few steps. Midjourney uses text prompts to generate the search. The next point is download the design. After you select a particular type of design of the product, download it in your system for further process. The next point is use of AI tool. ChatGPT is the next wonder of AI. Use that wonder to make the product personalized and gain all the knowledge if you are making any type of guides. The next comes use of photo editor. For selling digital products online, one of the skills you need to master is the use of photo editors like Photoshop, Canva, etc. The better you can use, the better your product will look. Having intermediate knowledge of photo editors will be great to start with. The final step is listing the product. After everything is done, give life to your product by listing it on a website like Etsy, Gumroad, etc. and you are good to go. Now let us understand the tips to sell digital products. Before you start a business, understand your target audience. Knowing your target audience will help you create products that meet your needs and preferences, which can lead to more sales. The next comes identifying profitable digital products. It will help you go a long way. Choose products that are doing well in the market like logos, wedding cards, resumes, and more. Use Google ChatgPT to gain information, have a research on websites like Etsy, Gumroad to see the business. The bestsellers use the great marketing strategies. You too need to do that. AI can help you market your digital products. You can use AI-powered chatbots to answer customers' inquiries and send automatic generated mail marketing campaigns and create an audience. The last but not the least, the most important step is to have a competitor analysis. Research on competitors' products, their pricing strategies, their audience, etc. can help you a lot in formulating your marketing. To make $1,000 a month with digital products using AI, you must create valuable products that solve your customers' problems and market them effectively. Pricing your products correctly, creating an automated sales funnel, and scaling up your business and all are critical components of a successful digital product business. With this, we have come to the end of the video. Hope you have liked it. For any queries, do comment and one of our experts will definitely help you out.
So what are confusion matrices and why do we need them? So in machine learning, classification is used to divide data into different categories. But after we have cleaned, prepared the data and trained our model, how we can tell if the model is performing well? So there is where confusion matrix come in handy. So a confusion matrix is a tool that helps measure the performance of a classifier in detail. It goes beyond just giving an overall accuracy score. It shows exactly where the model is making mistake and how it is classifying each category. For example, if there is an imbalance in the data where one category has many more instances than other, the model might predict the majority category most of the time and still show a high accuracy. But this wouldn't be helpful because the model is not accurately predicting the minority categories. The confusion matrix helps visualize these outcomes by showing a table of all the predicted and the actual values, allowing you to see where the model is performing well and where it needs improvement. So moving forward, let's see confusion matrices parts or how to create 2x2 matrix. So we can get 4 different outcomes when comparing the predicted actual values from a classifier. The first one is true positive. This is when the model correctly predicts a positive outcome. You predicted positive and it was actually positive. The second one is false positive. This happens when the model incorrectly predicts a positive outcome for something that is actually negative, or a predictive positive but it was actually negative. The third one, true negative. This is when the model correctly predicts a negative outcome. You predicted negative and it was actually negative. And the fourth one, false negative. This occurs when the model incorrectly predicts a negative outcome for something that is actually positive. You predicted negative but it was actually positive. So moving forward, let's see some matrices of confusion matrix. So this is a graph. So we know there are 4 parts: true positive, false negative, and true negative. So this one is true positive, this one is false positive, this one is false negative, this one is true negative. So just consider a confusion matrix made for a classifier that classify people based on whether they speak English or they speak Spanish. Okay, from this diagram you can see that. Fine. So these are some values: TP, FN, FP, TN. There is nothing true positive, true negative like this. Just from looking at the matrix, the performance of our model is not very clear. So to find out how accurate our model is, we use the following matrices. The first one is accuracy. So this is the formula of accuracy. TP means true positive, means this 86 value. So the accuracy is used to find the portion of correctly classified values. It tells us how often a classifier is right. It is the sum of all the true values divided by total values. So in this case, this is 88%. Okay, 86 plus 79, true positive plus true negative divided by this. It will come 88.23. Okay, and the second one is precision. So precision is used to calculate the model ability to classify positive value correctly. It is the true positive divided by the total number of predicted positive value. So this is the formula. It is true positive divided by true positive plus false positive. So in this case, the value will come 87.75%.
Okay, and the third one is recall. So recall is used to calculate the model's ability to predict positive values. How often does the model predict the correct positive values? So it is true positives divided by the total number of actual positive values. So in this case, the value is 88.93. Okay, and the last one is F1 score. So it is the harmonic mean of recall and precision. It is useful when you need to take both precision and recall into an account. So in this case, the value is 88.77%. So now let's jump into the demo part and see how we can get these values, accuracy, precision, recall, and F1 score from our dataset using hands-on. So I'm performing this in Google Colab. So first I will rename it to confusion matrix. Okay, so yes, let's start. So first we will import some basic libraries of Python like NumPy and the pandas. So here I will like import NumPy as np and import pandas as pd. Why I'm writing this np and pd? Because I don't want to write again and again NumPy and pandas. Okay, this is a short form, NP. So everyone knows, I guess, NumPy and pandas because these are the basic library. So NumPy is used for mostly linear algebra stuff, and pandas is used for the creating data frames, data processing, or if you want to read files, CSV files like that. Okay, yeah. So now let's import our data. Okay, so data equals to pd dot read underscore CSV, then file name data.csv. So I will upload this file on the description box below. You guys can check out from there. Okay, yes. So okay, what is saying? No such file or directory on data or CSV. I guess it's there. Okay, it's not. Let me import it. Okay, yeah. Okay, now file is there. So, yeah, it's working fine. So now let's check. Okay, 5 rows. Yeah, so this is our data. You can see we have columns with data dot columns. Okay, so we have this 32 columns in our data set: ID, diagnosis, radius means, texture means, parameter mean. So I just simply took this data. There is nothing related to confusion matrix and all. Okay, we can perform confusion matrix to any data. So head is used for displaying top 5 rows of our data set. Okay, if I will write data simply, you can see the full data. Okay, with 33 columns and all the rows, right? So now we don't need this ID, and one is this unnamed data because there is no values. Okay, so what I will do, I will write data dot drop ID comma. Okay, let me copy it because I don't want any spelling mistake. Yeah, copy, paste here. Okay, let me write axis equals to 1, then comma, in place equals to true. Okay, let me run it. Okay, if you will check data dot head, now I guess there will be no ID and all. See, there is now no ID and all. Okay, this we remove that large column as well, unnamed 32. Okay, so now what I have to do, I will write here data dot diagnosis equals to 1 if each equals to m. Okay, else 0 for each in data dot diagnosis.
diagnosis. Yeah. So if you can see, there is MMM value and there is, other values as well. So for M, I am putting 1. For the rest, I will put 0. Okay, let's check again. Yeah. Okay, you can see it's done. Replacement is done, basically. Okay. So let's check the info of the data. So these are some basic functions of Python. So these are the column, these are the non-null values, these are the data type values. Okay, float we have or int we have. Okay, so we have only two type of data sets. So now what we will do normalization. Okay, y equals to data dot diagnosis dot values. Okay, so here I will write x underscore data equals to data dot drop diagnosis comma axis equals to 1. Okay, here I will write x equals to x underscore data minus np dot minimum value and the x underscore data and divided by, so I am using that formula if you guys know. Okay, divided by np. So what I'm finding is accuracy. Okay, I'm using that formula, np dot max of x underscore data, then minus np dot min value, then x underscore data. Okay, axis value is wrong, sorry, spelling is wrong. Now fine, yes, it's fine. So now we will do train test split. So what is train test split? Okay, so first let me write underscore selection import train test split. Okay, so what is train test split? So what we do, we split our data set into training and the testing. Mostly we train and the some part of data we test. Okay, so here I will set the ratio. So x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train test split, then x comma y comma test underscore size equals to 0.15. Means 85% we are on the training and 15% we are on the testing part. Okay, comma random state equals to 42. Okay, let me run it. It's working fine. Yeah, it's working fine. So now let's see the accuracy from the random forest. So I will write from sklearn dot ensemble import random forest classifier. Okay, then rf equals to random forest classifier and n underscore estimators equals to 100, and here I will set random state to
1. Okay, then rf, this is a short form of random forest, dot fit x underscore train comma y underscore train, then print random forest score comma rf dot score, then x underscore test comma y underscore test. Okay, now let's check how much the accuracy. So accuracy is coming 95%. Okay, which is very good. So now what I will do, I will create confusion matrix now. Y underscore prediction equals to rf dot predict x underscore test. Okay, then y underscore true equals to y underscore test. Okay, so here now let's create the array sklearn dot matrix import confusion matrix. Okay, then I will write cm, short form of confusion matrix. Here I will write y true comma y prediction, then confusion matrix. So this is our array. Okay, the true positive, and this is false negative, and this is false positive, like this. Okay, so now let's create the visualization of confusion matrix. Okay, so here I will write import cborn as SNS, then import matplotlib dot pyplot as plt. plt means plot. Okay, the short form f comma ax equals to plt dot subplots. Let's give the figure size equals to 5,5. Then SNS dot heat map, then confusion matrix comma n naught equals to true, then comma line width equals to 0.5, comma line color equals to, let's give red, then fmt equals to, I don't need any that decimal values, comma ax equals to ax. Okay, then plt dot x label y underscore prediction, then plt dot y label, then y underscore true. Add the, okay, forgot to add this braces, then plt dot show. Yeah, so as you can see, this is the y true values and this is the y prediction values. Okay, this is the heat map we have created. So this is how you can visualize your confusion matrix. Fine.
Today, I will tell you a story of a guy named Leo. Leo, a young software engineer with big dreams. He loved building things, mobile apps, web platforms, and even small games. But coding was tricky, even for someone as skilled as Leo. No matter how much experience he had, he kept running into bugs and inefficiencies that made his applications crash or run slowly. He would spend hours staring at his computer screen, debugging line after line of codes, trying to figure out where things went wrong. One day, Leo heard about Cursor AI, a powerful code editor that could help him code faster and smarter. Unlike regular code editors, Cursor AI didn't just highlight errors, it understood the code deeply. It could analyze problems, suggest better solutions, and even write sections of code for him. Feeling curious, Leo decided to give it a try. He opened Cursor AI and loaded his project, which had been stuck for days due to a tricky bug. Almost instantly, Cursor AI flagged the error in the code and suggested an efficient fix. Not only that, it also recommended a cleaner way to structure his code, making it easier to read and less prone to future bugs. Leo followed the suggestions and his app started running flawlessly. In fact, Cursor AI helped him optimize the entire project, making the application faster and smoother than before. Tasks that would usually take hours like debugging, refactoring, and testing were now completed in minutes. Before I tell you that you too can code in minutes like Leo, just for your information, in this video, I will let you know what Cursor AI is and your ultimate guide to use it as a beginner. So let's jump into the video. Let us understand what is Cursor AI. Cursor AI is a smart coding assistant that speeds up your workflow by suggesting code completions, fixing bugs, and optimizing code in real time. It supports multiple languages, helps with code reviews, and even generate documentation, making coding faster, easier, and more efficient for developers of all levels. Well, after we have a basic understanding of Cursor AI, let us explore more. I will first take you to the browser, and in that, you need to search for Cursor AI. And the first official website that will appear is www.cursor.com. You need to click on it and obviously download it. It is free and you need to sign in as you are using their model. So it is very important to log in before exploring their model. After you download and install it, I will show you what screen you are gonna get. Yeah. This is the visual representation of Cursor AI, the code editor, and it somewhat looks like VS Code. If you have seen VS Code before, it almost looks like this. This is basically your project section. And yeah, obviously file, edit, selection, view, go, run, and everything. So initially, it is very important to start with the basics. So obviously, you're using a new application for the first time. It is very important to learn the cursor settings. So to see the cursor settings, for that press Command Shift plus P. Command Shift plus P. Yeah, see? It will direct you to a menu bar on the top of the application and search there as cursor settings. See, it is already available. So cursor settings. So basically cursor setting has 4 types of settings: general, models, features, and beta. So initially start with this general. Account, basically the account shows like through what Gmail account you have logged in. And currently I'm using this pro trial and it is basically of 2 weeks, I guess, for free. And after that, if you want to use it, then you can use it like upgrading to pro. And after that, there is VS Code import. This is basically for like if you have VS Code in this particular laptop or system you're using, then you can obviously import the type of extensions or key bindings you have there. You can generally import it. And after that comes rules for AI. This is basically the section where you can like tell or instruct the Cursor AI what are the things you want or even what are the things you don't want. Like for example, you're working on a particular project and you only want to like use a particular language, then you can just type there, like I will show you. Use only React.js. So basically you can write there and it will automatically get saved, but obviously I won't be using that. And after that comes a very important part. There is a privacy mode. It is already written: if on, none of your code will be stored by us. If off, we may save prompts or collect telemetry data to improve Cursor. So obviously I don't want my data to get to them. So obviously I have enabled it. If you have no problem in showing your data to the Cursor, so you can obviously disable it. Then I will show you about the models. This is basically the section where you can see what are the type of models, API models you're using or it is getting used, and even you can even add your own model and see like Open AI API key, Anthropic API key, Google API. Oh wow, this is nice. Azure API key, they're almost there. Let's come to beta. This is basically a section where if any of the new features like get upgraded in Cursor AI, then you can obviously see it over here. And it is like a default setting is disabled, so let it be. Like don't have to do anything. So after you have seen the Cursor settings, I will take you to see the actual presentation where you can actually code more faster than any of the editors. So I will take you to see a magic. So let's start. So I will cross it. I will now show you why Cursor AI is the next code editor. For that, press Ctrl+Shift+I and you can see the composer. It is named as composer. You can write here any instructions or commands that you want Cursor AI to execute. So basically you can give prompts like create a particular website for me using this. So I will let you understand with an example. Create a simple retro game using HTML, CSS and JavaScript. I hope it does. And enter. See, it has even started to build this game. Pong style, retro style Pong game using HTML, CSS and JavaScript. Okay, it has already made index.html and it has been building with JavaScript. Okay, it has only used HTML and JavaScript. Okay, I wanted to use CSS too for better appearance. Obviously, CSS is the thing you need to. Okay, it has already started linking. Okay, here's the code for the game. Okay, maybe some confusion has occurred. Okay, it has used CSS as a. Okay, it has not made a different file. So I wanted to make a CSS as a different file. I want a separate file for CSS. Okay, now see, it has actually executed what I said. Okay. Now, after you have got it, you can just accept all and see if it is actually working or not. So let's start. Accept all. After that, you can close this composer window and you will find that files already in your project section. See, it is there. If you want to like run the game and see if it is actually getting the code is running or not and the game is playable or not, you need to download one extension. Yeah, here like live server. Yeah, I have already installed it. You need to just install it and you are ready to go. Let's come back and right click on the index.html and open with live server. Okay, see, it's nice. Oh wow. Move your mouse up and down to control the left paddle first to 10 points. First to 10 points win. Okay. This is nice. So I want basically my game, it is glowing, yeah. So I want to use one theme. So see if it can. Let's see. After the game is basically made, you can just use your imagination or your creativeness on how you can design your game. So Control Shift I. Yeah. Wow, the game is nice. I don't know why I'm appreciating, but yes, you need to appreciate because it did so much work for you. Oh, wow, the game is nice. I want you to use Harry Potter theme. I think everyone knows Harry Potter, and I want it basically to use Harry Potter theme in the game and submit. So it has started formulating it. I think it is nice. Okay, accept all. And now you can cross it. And let's see. Open with live server. Wow, see. Oh, it is nice. See, it is almost green and yellow, the type of that is used in Harry Potter and everything. See, it is nice. And it is also written golden snitch. Wow, it is nice. So basically, you can do anything. You can even use a particular type of like font. You can do anything. Let's see how we can improve it. Control Shift I. Yeah, this is nice. Can you just use the font style used in Harry Potter movie? I hope it does. Enter. I understand. Yeah, it is trying. Because of the copyright, maybe it fully can't, but yeah, it is trying. Let's see. Accept all. Cross it. And right click and open with live server. Okay. Maybe there's a difference there. There is a difference. I can see. Fine. It is nice. So in this way, you can just command it and do anything. You can even like attach files, I guess. You can over here, you can just use @, and you can like upload files, folders, code, web, like you can attach, you can @web, and you can even tell it to take a picture from the website and replicate it, use that for reference and anything. So it basically depends upon your designing and your creativeness, how you want to make it, and it will just code for you. This is the power of AI. So you can do anything over here, I believe. It will help you to code much, much, much faster.
So let's talk about the very first top AI tool, which is Skillora.ai. This AI tool aims to provide the best AI-driven mock interview experience. You can take mock interviews for any job roles and subject, receiving instant constructive feedback. Skillora's AI interviewer listens to your responses and asks dynamic flow-up questions to test your depth of knowledge. With the Essential plan, you gain access to 6 AI mock interviews per month. You'll receive instant feedback, ideal answers, and performance reports, helping you upgrade your skills for just $8 per month. The premium plan allows you to enjoy 15 AI mock interviews per month. You'll get the same instant feedback, ideal answers, and performance reports along with priority support, maximizing your learning for only $15 per month. Next up, we have Visco's. Visco's advanced AI coach is designed to elevate your job interview skills, harnessing insights from over 10,000 companies. It offers tailored sessions that simulate real interviews, providing personalized feedback and performance analytics. It transcribes your performance and delivers a conversational experience akin to an actual interview. It also offers customized feedback and performance analytics, helping you refine both your answers and communication skill. During practice session, you can craft questions specific to your desired role and industry, ensuring relevance and depth in your preparation. Supporting various interview styles. The price for AVA services are available for free. Next up, we have interviewing.io. Interviewing.io is an AI-powered platform that provides candidates with simulated technical interviews. The platform uses machine learning algorithms to assess your coding skills, problem-solving abilities, and communication style. You can get 4 simulated technical interviews for $225. Next up, we have MockMate. MockMate is an AI-powered tool that allows you to practice answering common interview questions. This tool provides feedback on your answers and gives tips on how to improve your performance. The service is available for $29 per month. Moving on to ChatGPT. ChatGPT is an AI chatbot that can be used to practice answering interview questions in a conversational setting. The chatbot can be customized to simulate the style of an actual interview, and it provides feedback on your answers. The free plan allows you to get started with writing assistant, problem solving, and many more. You will have limited access to ChatGPT 4.0 mini, including data analysis, file uploads, vision, web browsing, and custom GPTs. All of this is available at no cost. Then we have the Plus plan, which is for $20 per month. The Plus plan amplifies your productivity by offering early access to new features, access to ChatGPT 4, 4.0 and GPT 4.0's mini, up to 5x more messages for ChatGPT 4.0. You can access to data analysis, upload files, vision web browsing, and DALL-E image generation. You can also create and use custom GPTs. Then we have My Interview Practice. My Interview Practice is an AI tool that allows you to practice interviews in a simulated environment. The platform uses AI to generate interview questions based on your chosen field and provides instant feedback on your responses. This tool is particularly useful for those who want to practice their interview skills in low-pressure environment. The Plus plan is for $49 per month. You get 1 month of access. And the premium plan is for $57 per month, and you will get access to additional features and many more benefits. Next up, we have Udly. Udly offers real-time interview coaching using AI. It analyzes your speech and body language, providing feedback on how to improve your performance. Udly services are available for free. Now you might be wondering how AI tools can help you ace your job interviews. AI tools can assist in several ways. At first, we have research companies. AI tool provides information about companies' website, news articles, and social media, helping you tailor your answers to the interview's question. Practice questions. AI tool help you practice answering common interview questions, boosting your confidence and preparation. Feedback. AI tool offers feedback on your answers, highlighting areas for improvement and refining your responses. Personalized advice. AI tools provide tips and advice on improving your interview skills, giving you an edge to your next job interview. Choose the right AI tool and select an AI tool that fits your needs and preferences. Use the tool consistently, starting a few weeks before your interview to maximize its benefits. After practicing with the AI tool, get feedback from others to identify areas for further improvement. Dress professionally and be punctual for your interview to make a positive first impression. Show enthusiasm and confidence during the interview to leave a lasting impression on the interviewer. AI tools can significantly aid in interviewing preparation. By using them effectively, you can enhance your chances of success in your next job interview.
Hey everyone, welcome back to our channel. In today's video, we are diving deep into the world of machine learning interview preparation. As we gear up for 2024, it's crucial to be well prepared for the questions that can come your way in any machine learning interview. We have compiled 30 essential interview questions and answers, thoughtfully categorized into beginner, intermediate, and advanced levels. So let's start with beginner level questions, and number one is, what is machine learning? So machine learning is a subset of artificial intelligence that involves the use of algorithms and statistical models to enable computers to perform tasks without explicit instructions, that is, by relying on patterns and inference. And now moving to number second question, that is, what are the different types of machine learning? So the three main types of machine learning are, number one is supervised learning, and then comes unsupervised learning, and then there is reinforcement learning. Now moving to next question, that is third, that is, what is supervised learning? So supervised learning involves training a model on a labeled dataset, which means each training example is paired with an output label. The model learns to predict the output from the input data. Now moving to the fourth question, that is, what is unsupervised learning? So unsupervised involves training a model on data that does not have labeled responses. The model tries to learn the patterns and the structure from the input data. So guys, these are the beginner level questions. And now we'll move to the fifth question, that is, what is reinforcement learning? So reinforcement learning is a type of machine learning where an agent learns to make decisions by performing actions and receiving rewards or penalties. The goal is to maximize the cumulative reward. So now moving to the sixth question, that is, what is a model in machine learning? So a model in machine learning is a mathematical representation of a real-world process. It is trained on data to recognize patterns and make predictions or decisions based on new data. So now moving to seventh question, that is, what is overfitting? So overfitting occurs when a machine learning model performs well on the training data but poorly on new unseen data. It indicates that the model has learned the noise and details in the training data instead of the actual patterns. So now coming to question number 8, that is, what is underfitting? So underfitting occurs when a machine learning model is too simple to capture the underlying patterns in the data. It performs poorly on both the training data and new data. Now move to the next question, that is ninth question, and the question is, what is a confusion matrix? So confusion matrix is a table used to evaluate the performance of a classification model. It summarizes the number of correct and incorrect predictions made by the model, and that is categorized by each class. Now moving to the 10th question, that is, what is cross-validation? So cross-validation is a technique for assessing how the results of a statistical analysis will generalize to an independent dataset. It involves partitioning the data into subsets, training the model on some subsets and validating it on the remaining subsets. So this was all about, that is, the 10th question or the overall 1 to 10 questions for beginner level. Now we'll move to intermediate level, and here we'll cover 10 questions. So we'll start with 11th question, that is, what is a ROC curve? So ROC, that is, receiver operating characteristic curve. It is a graphical representation of a classifier's performance across different thresholds. It plots the true positive rate, that is TPR, against a false positive rate, that is FPR. Now moving to 12th question, that is, what is precision and recall? So precision is the ratio of correctly predicted positive observations to the total predicted positives. And recall is the ratio of correctly predicted positive observations to all actual positives. So the formula is precision equal to TP slash TP plus FP, and the recall is TP slash TP plus FN. So now we'll move to the 13th question, that is, what is the F1 score? So the F1 score is the harmonic mean of precision and recall. It provides a balance between the two metrics and is useful when you need to balance precision and recall. F1 score is equal to twice into precision into recall, and that is divided by precision plus recall. Now we'll move to 14th question, and here we will cover regularization. So the question is, what is regularization? So it is a technique used to prevent overfitting by adding a penalty to the model's complexity. And the common types of regularization include L1, that is lasso, and L2, ridge regularization. Now we'll move to the 15th question, that is, what is the bias variance trade-off? So the bias variance trade-off is a fundamental issue in machine learning that involves balancing the error introduced by the model's assumptions and the error due to model complexity. So a good model should have low bias and low variance. Now we'll move to the question number 16, that is, what is feature engineering? So feature engineering is the process of creating new features or modifying existing ones to improve the performance of a machine learning model. It involves techniques like normalization, encoding categorical variables, and creating interaction terms. So now we'll move to question number 17, and that is about gradient descent. So the question is, what is gradient descent? And your answer is, gradient descent is an optimization algorithm used to minimize the cost function in machine learning models, and it iteratively adjusts the model parameters in the direction of the steepest descent of the cost function. So with this, we'll move to the 18th question, and that will cover with the difference between bagging and boosting. So the question is, what is difference between bagging and boosting? And you could answer this with starting with bagging, that is bootstrap aggregating. That involves training multiple models on different subsets of the data and averaging their predictions. Then comes boosting, that involves training models sequentially with each new model focusing on correcting the errors of the previous ones. And then we have the question number 19, that is, what is a decision tree? So a decision tree is a non-parametric supervised learning algorithm used for classification and regression. It splits the data into subsets based on the value of input features, resulting in a tree-like structure of decisions. Now we'll move to question number 20, that is, what is a random forest? So random forest is an ensemble learning method that combines multiple decision trees to improve the accuracy and robustness of the model. It builds each tree using a random subset of features and data points and then averages their predictions. So these were the questions that are for the intermediate level, and these are just the basic questions, or I will just say the theoretical questions that can be asked in an interview. So be prepared for that. Now we'll move to the advanced level interview questions, and we'll start with question number 21, and here also we'll cover the 10 questions. So number one question, or that is 21st question, and the question is, what is a support vector machine? So support vector machine is a supervised learning algorithm used for classification and regression. It finds the optimal hyperplane that maximizes the margin between different classes in the feature space. And then comes question number 22, that is, what is principal component analysis? So principal component analysis is a dimensionality reduction technique that transforms high dimensional data into a lower dimensional space by finding the directions, that is, principal components that maximize the variance in the data. And then comes the question number 23, that is, what is a neural network? So a neural network is a series of algorithms that attempt to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. It consists of layers of interconnected nodes or neurons. And then comes the question number 24, that is, what is deep learning? So deep learning is a subset of machine learning that involves neural networks with many layers, that is, deep neural networks, and it is particularly effective for tasks like image and speech recognition. Now I'll move to question number 25, that is, what is convolutional neural network, that is CNN. So we will start the answer by answering the interviewer that a convolutional neural network is a type of deep learning model specifically designed for processing structured grid data like images. It uses convolutional layers to extract spatial features or the spatial features and patterns from the input data. Now we'll move to the question number 26, that is, what is a recurrent neural network or RNN? So a recurrent neural network is a type of neural network designed for sequential data, and it has connections that form directed cycles, allowing it to maintain a memory of previous inputs and process sequences of data. So this was all about question number 26. And now we will cover the question number 27, that is, what is the difference between batch gradient descent and stochastic gradient descent? So batch gradient descent computes the gradient of the cost function using the entire training dataset, while stochastic gradient descent, that is SGD, computes the gradient using only one training example at a time. So SGD is faster but noisier. Now we'll move to question number 28, that is, what is dropout in neural networks? So dropout is a regularization technique used in neural networks to prevent overfitting, and it involves randomly setting a fraction of the neurons to 0 during training, forcing the network to learn more robust features. And now we'll move to question number 29, and that will be about transfer learning. And your question is, what is transfer learning? So we'll answer this to the interviewer by starting that transfer learning is a technique in machine learning where a model developed for one task is reused as the starting point for a model on a second related task. It is particularly useful when there is limited data available for the second task. Now we'll move to the last question and the 30th question. So that is, what is a generative adversarial network, that is GAN? So you can start answering this. So generative adversarial network is a type of deep learning model consisting of two neural networks, a generator and a discriminator, that are trained simultaneously. The generator creates fake data while the discriminator tries to distinguish between real and fake data, leading to the generator producing increasingly realistic data. And these questions and answers are over, and these covers a wide range of topics in machine learning and should help prepare for interviews at various levels.
Thank you for joining on this journey. If you found this video helpful, do hit the notification bell and subscribe for more videos by Simplilearn. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.